this lecture is precisely for the audience who wanted me to teach in English. So basically the learners who are not very well versed in Hindi. So if you want to follow my Hindi lectures, they are also available and you can find them in our homepage also, right? For those who do not know me, my name is Prashant Jain. I am a graduate from IIT Bombay, BTech 2008, IIT Bombay, AIR 42, author of 19 books. So I have written 19 books. My IOQM book is like one of the bestseller. Most viewed IOQM educator since last 6 years, mentor of AIR 1, 6 and 22 in ISIB Math 2023, mentor of numerous top 100 ranks in JEE 2023, and CHO gold medalist, INPHO and TSC qualified. So guys, all the content that I give is already in English. So that way, we do not have to segregate between the learners who are comfortable in Hindi and the learners who are comfortable in English, right? So, see, like the timetable of this, every Wednesday I am planning to take these lectures. Obviously, other than me, other educators will also join in some time so that this course can be completed properly. These are certain links which you can follow. All the information that are shared, like all the strategies that I make, all the strategy videos that you can see, you can find these videos here. Just a second, let me mark it for you. Telegram, https:/t.me/pjsir42, right? So you can get all the IOQM PYQs assignments mock test on this link. This is free, right? This is free content. You can get IOQM PYQs assignments. All these are already in English, right? And for other Olympiads also, you can follow these links, right? Good to go, guys. So first of all, let me tell you certain things. IOQM is a very demanding examination, but this year IOQM was a doable examination, right? In 2023, if I see the paper of 2023, getting 10 marks was arduous task, right? It was a very, very difficult task. 10 marks, only 4,000 students across the nation got marks which were more than 10, right? So but this year the marks have improved, and around 30 to 40% students, 30 to 40% learners who gave IOQM this year are from those states, like the states which do not have like Hindi as their primary language, and that is why I decided to record these lectures in English, right? So the first lecture is basic number sense. So let's talk about the syllabus and everything, right? So I'm going to scope the syllabus of IOQM, right? All of us saw that in IOQM, they have reduced the dependency. In IOQM 2024, they have reduced the dependency on higher concepts. They did not ask any high concept. So please try and understand this thing. This is very, very important. For the first time, I am going to teach like IOQM 2024, right? IOQM 2024. So I am going to teach at the level of IOQM 2024 paper, right? It has its pros and cons, right? Initially, what used to happen when I taught IOQM, the level of theory was at par with RMO, right? The level of theory was at par with RMO. You do not have to study additionally for RMO, concept wise. Obviously, you have to do extra practice in RMO, but in this year, I am going to keep the level so that the students can comfortably score. Our target is to score 40 in IOQM 2025, right? So this means we are going to do 9th and 10th mathematics at high level, right? This is going to be done at high level, right? What do I mean by 9th and 10th, right? Number system, real numbers, the complete number theory is going to be done at this level. Then there are certain advanced topics of number theory which will be covered from the month of April. For first few lectures, we are going to focus on this, right? After this, we will go after the number theory, then we will do algebra, then we will do geometry, and then we will do combinatorics, right? Combinatorics is pretty much basically like JEE combinatorics, JEE permutation and combination. This is what we are going to do, right? Sir, what about your IOQM book? What about that? Just buy it. It is a very good book, and in fact, it is the only proper literature available for IOQM. It has solved examples, it has theory, it has lot of problems, it has AIME problems. And by the way, this course is useful for all the learners who are comfortable in English as well as they are planning to attempt AMC AIME, right? American Mathematics Contest and American Invitational Mathematics Exam, right? So let's start with basic number system, right? Number system is a method of writing numerals to represent numbers. 10 symbols. So this is so when we use 10 digits, right? So let's do a very thoughtful experiment. Just imagine that we have only 5 digits available, right? This is our convention. This is a convention made by human beings, right? This is a convention made by human beings that we are going to have 10 digits. Just imagine that that particular human being settled for 5 digits. Now let's assume that there are 12 oranges. How many oranges? 12 oranges. So how are these guys going to count it? Just see this. 1 orange, 2 orange, 3 orange, 4 orange. Now they cannot write 5 because digit 5 is not available. So what comes after 9? 10, right? So this is 5. Then 6, 7, 8, 9, 10, 11, 12, right? So while counting those 12 oranges, these people would have written 22. So what I am trying to say, 12 in decimal is 22 in base 5. So this is called, if 5 digits are available, then that system is base 5. Please write it down. And if you are lagging behind in writing, you can write all these things after the lecture is completed, right? After the lecture is completed. Getting my point? So see, like, this is our made convention, right? 10, using 10 digits is a convention made by us. It is not made by God, it is not divine intervention, right? It is made by us, right? So if we follow the convention of using 5 digits, then this is how the counting will work, right? This is how the counting will work. This particular aspect we will dive deep. We will deep dive into it after some time, right? This is called base system. This is a particular topic. This is a particular topic in number system, right? Number theory, it is a particular topic which we are going to deal later. But for now, we will assume that we are dealing with 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, you imagine any number that you have written in your life. You must have used some of these digits in particular combination, right? In particular combination. Getting my point? Right? Right? Yes, I can see your chat. Nultron, I can see your chat, right? The lectures are not in accordance with the book, right? The lectures are not in accordance with the book. So I'll provide you with certain assignments for it. The book can be attempted after some time. Each of the symbol is called a digit, right? So this is a very simple thing. The start of IOQM paper was very simple. Likewise, the start of this lecture is going to be very simple. It is going to be demanding after some time. It is going to be demanding after some time. So do we need to make 2 separate copies of worksheet and your book exercise? Yes. If you are preparing for IOQM seriously, you need to make a proper answer copy, different copy for my book. If you are using my book as a textbook, which is your primary study material, then you need to solve it in a separate homework copy. Okay. Got it? Got it? Yes. Chali. So classification of numbers, this you must have seen. So see, like, this is important in JEE, imaginary number. For us, it is not important. For us, let's start from here. Real numbers. Real numbers are bifurcated into rational numbers and irrational numbers. Irrational numbers which cannot be represented in the form of P by Q, right? See, like, if you are preparing for IOQM, you cannot expect me to write the definition of all these things, right? These will be available to you in the notes. I will be providing you with the notes of these lectures. So you can write the definitions of these. If you do not actually see, like, as per my opinion, you know the definition, you may not know the exact definition. There may be some fine point which you may have been missing, but those points will be covered in the notes. I will be providing you with the notes. So there are rational numbers and there are irrational numbers. Rational numbers are basically P by Q, which can be written in the form of P by Q. Q is not equal to 0, and HCF of P and Q has to be 1. Irrational number. Then we have integers, negative integers, whole numbers. Whole numbers are also called non-negative integers. So this is the terminology which is used in IOQM questions. If you see, they do not use the term whole numbers, they use non-negative integers. Natural numbers are positive integers, right? Now, what is the other name for natural number? Can you tell me? It is written in the NCERT. What is the other name for natural number? Positive integer, natural numbers are the two names which I am giving you. What is the other name given for natural numbers? Can you tell me? What is the other name given for natural numbers? Counting numbers. Very good, Arindam. So Arindam is saying counting numbers. So these are called counting numbers also. Okay. Then these are fractions. Fractions are proper, improper, mixed. Proper, improper and mixed. Okay. So proper fractions in which, so m by n basically, if m is less than n, then it's a proper fraction. If m greater than n, it is improper. And see, like, if it is like this and you write it like this, then it becomes mixed. So all these are terminologies which you need to write. So can you make this flow chart in your copy? Please make sure that you are making a new copy for it, right? I would very much appreciate if you can make a new copy for these lectures, right? JEE 2028 aspirants. Basically, fractions are positive rational numbers. Yeah, this is written in many books. I also believe that fractions are positive always, right? Roman bhai, okay. Sir, Pathfinder book. Sir, what is going to be the difference in content of English and Hindi lecture? See, like, if there, see, the difference is not in the language. If there were a difference in the two content, two different educators would be teaching. Since I am the one only who like teaching in the English, so there is not going to be any difference. That is what I feel, at least. Yes, my book is enough to crack IOQM. Got it? So natural numbers. So like I said, I am just going to go through the definition, but here are certain terminologies. Now, when I write it like this, this is a collection. What do I call it? This is a collection. And in mathematical term, it is called set. What do I call it? Set. Okay. So when I say 2 belongs to n, this symbol is known as belongs to. See, like, why we are doing these things? Because these things help us understand the question better. Whatever is written in IOQM question paper is in mathematical language. So this is a mathematical language. 2 belongs to n means 2 is an element of the set of natural number. So sets are always represented in capital letters. Always represented in capital letters. Got it? Always represented in capital letters. Correct? No. Ramanujan students do not have to watch this. They have a different Zoom course. Okay. Whole numbers. All natural numbers together with 0 form the collection of whole numbers. Now, again, when I am saying it is a collection, this becomes set. Like I said, every set is represented with capital letter. W is a capital letter, right? And it is a well-known symbol for whole numbers. It is well accepted. Well known means well accepted. If you see NCERT, which is the standard textbook for mathematics in India, W is what is written in 11th class first chapter for whole numbers, right? Okay. Yes, all the topics will be covered, guys. All the topics will be covered. You don't have to worry about it. Integers. All numbers 0 and negative of natural numbers form the collection of all integers. Yes, this is very obvious. So I'm just going to go through all these things, right? You can just simply write done. If you are well versed with all the definitions till now, you can write done. You can write this in chat. DN. Just write DN in the chat. Just write DN in the chat. Do I have to watch Hindi lectures if I watch these lectures? It totally depends on you, man. Like I said, the level is not going to be like my old IOQM lectures, because at that point of time I was covering RMO as well with IOQM, right? This is to get 40 marks in IOQM 2025. I am assuming that IOQM 2025 is going to be of the same level as IOQM 2024, right? Thank you. Right? Thank you. Rational numbers. These are real numbers which can be expressed in the form of P by Q, where P and Q are integers, Q and Q not equal to 0. For example, these things, right? All natural numbers, whole numbers and integers are rational, right? This is very obvious thing, and that is why we make a particular type of diagram, right? There is a diagram associated with all these numbers which I am going to make in some time. Rational numbers including all integers without any decimal, also non-terminating but recurring decimal. This is a very important terminology. Non-terminating but recurring. Recurring means the pattern will repeat. For example, if you have 1 by 7, you can write it as 0.142857, and then this means that this pattern will repeat. Such numbers are also rational numbers. The numbers which are non-terminating and non-recurring, are called irrational numbers. Okay, are called irrational numbers. Got it? Perfect. So like these are simply like we do not require them, to be honest. If you were giving board examination, if you were giving any school examination, you would require these definitions. I have included them so that you can get them in notes. If you find them useful, please note it down. Feel free to note them down after the lecture ends, right? Irrational number. Now this is very important. All real numbers which are not rational are irrational. These are non-recurring as well as non-terminating. Now these are very simple looking irrational numbers. We all know them, right? We all know these things, right? We all know these irrational numbers. But what we do not know, I am going to write a number. You tell me if it is rational or irrational, right? You just tell me if it is rational or irrational. And the pattern continues. What is it? Is it a rational number or irrational number? You need to tell me. Pi is irrational. Pi is irrational. It is a definite irrational number. In fact, let me give you a very good fact. Pi is 4 times 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 minus 1 by 11. This is how the value of pi is calculated. Right? There is no pattern in it. Irrational. Why are you saying it is irrational? Because there is no pattern which is following. You can see only 0 and 1, 0 and 1, but the number of zeros between the two consecutive one increase. We have 1 0 here, we have 2 zeros here, we have 3 zeros here, we have 4 zeros here, we have 5 zeros here, right? 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 See, like guys, I'm I am taking a huge effort in teaching in English, like for teaching in English, right? Obviously, English is not my first language. Hindi is my first language. I teach, like I had to prepare a lot for this lecture. Believe me when I'm saying this. And it is just because of the love of students. Like I went to Vijayawada last month. Last month I went to Vijayawada. There were many learners who told me, sir, we see your lectures, we cannot understand them because we are well versed in English, we cannot understand Hindi. Please, sir, do some lectures for us as well. And because of that support, because of that love, I prepared these lectures in English, right? So please, please bear with me, right? So is there any of you, like, is there any, so like some of the people in the chat are the ones who can understand Hindi as well, but they are simply doing this lecture as I am live, right? So do we have anyone in the chat who can understand only English? Do we have anyone? IOQM result will come after 24th of September. That is what I think. Nice. Okay, thank you. So like, please keep spreading these lectures. You are the beacon of hope for me, right? I get demotivated when I see a very few learners attending these lectures. But even if you see the recording, if you spread the word that sir is now teaching in English, it is going to make huge difference for me, right? So these are irrational numbers, right? Pi is irrational. One more fact, E, 1 plus 1 upon 1 factorial, 1 upon 2 factorial, 1 upon 3 factorial, so on. It is also irrational. It is also irrational, right? What is 3 factorial? 3 factorial is 3 into 2 into 1. In fact, n factorial or n is 1 into 2 into 3. This was the first question. This was the first question in IOQM 2024. Did you see this? Did you see this? Right? So, like factorial is just a name, right? Factorial is just a name. Believe me when I am saying this, factorial is just a name. Okay, it's very, so I am in Bangalore right now and it is very cold here. Anyway, let's move on to the next thing. Then we have something called real numbers. So, just a second, yeah. So now I am going to make a figure, right? This is natural number. All natural numbers are whole number. All whole numbers are integers. Z is something which is written for integers. Then all integers are rational numbers. Then we have a set of irrational numbers. Together they make real number, right? So this is the diagram which you should always remember when classification of numbers is talked about, right? Okay. How can I be smarter than you? Believe me, Johnny, if you are as smart as I am, then also your life will thrive. Your life will thrive. Like you will literally do wonders in your life. Don't worry. So why do you want to become smarter than me? Okay. So this is the image which you need to remember when you visualize classification of numbers. Okay. Perfect. Now let's dive deep into natural numbers. There are certain type of natural numbers which are to be remembered, specifically prime numbers. All natural numbers that have 1 in itself only as their factors are called prime numbers. So two divisors only are exactly divisible by and themselves. So these are the numbers. Now there are certain things which you need to remember. 25 prime numbers between 1 to 100, 21 prime numbers of 2 digits. These are certain facts. See, like to develop number sense, you need to remember certain things, right? Because we see the pattern which we have recognized earlier. What is the meaning of this sentence? If you know certain things, then you are more likely to see that pattern, right? For example, in 2016-17, I saw a number plate 1681 and it fascinated me. 1681 is 41 square, right? 16 is a square of 4, 81 is a square of 9, 4 is a square of 2, 9 is a square of 3. This is the only number which can be written like this. Now how I could see this pattern? Because I knew 16 and 81 were squares. Because I knew that squares are certain things which are to be remembered. So I recorded a video for a 5-minute challenge. The English audience may not be able to understand that, but here is the challenge, right? 5-minute challenge. I am going to give you this challenge, 5-minute challenge. On a plain sheet of paper, you need to write a square of numbers from 1 to 50. Table of 1 to 30. 2 to the power 1, 2 to the power 2 till 2 to the power 10. 3 to the power 1, 3 to the power 2 till 3 to the power 8. 5 to the power 1, 5 to the power 2 till 5 to the power 8. Additionally, I am also assigning you this task till 15 cube, right? If you see 2197 is 13 cube, you should be able to remember these things, right? I have seen particular problems which becomes extremely simple if you know certain of these numbers. Few of these numbers if you remember, then those questions become extremely simple. So you need to remember these things. Please write them down. After this lecture, you need to write them on a piece of paper, right? Just write them down and paste it on your wall, so that every day when you see that particular chart, you are seeing these numbers. And believe me, if you increase the frequency of seeing these numbers, they will get imprinted in your muscle memory, and then you will not be able to forget these numbers. Okay. Shyam Umale, I have already recorded RMO strategy. Just attend the lectures of SPSS sir. We are giving free lectures, and the learners who prefer YouTube, they can see the RMO lectures of me and SPSS sir in this channel also. Okay, perfect. Let's move on. Then we have composite numbers. 1 is neither prime nor composite. We all know this fact, because 1 has only one divisor. 2 divisors prime, 1 divisor 1, more than 2 divisors composite numbers. more than 2 divisors, composite numbers, right? Then there is a very interesting theorem, right, which is called fundamental theorem of algebra. Fundamental theorem of algebra. Fundamental theorem of algebra, no, it is actually arithmetic. Arithmetic. Fundamental theorem of arithmetic. So what does FTA says? Every composite number can be uniquely represented as product of power of primes, right? disregarding the order of appearance. Now what does this mean? Let's take one number 2160. Let's take this number 2160, right? I can write it as 2 to the power 4, 3 to the power 3, 5 to the power 1, right? Please check it, please confirm it. If it can be written like this, please confirm it. Please confirm, guys. I want you to confirm this. Can it be written like this? Can it be written like this? Can it be written like this? Please say yes or no. Can it be written like this? Right? It can be written like this. Now, what does this theorem says? Every composite number, obviously 2160 is a composite number, can be uniquely represented as product of primes. Product of power of primes, it is written like this. Uniquely, this is very important, uniquely. There is no other way you can write it. If you say, no sir, I can write it like this, you are just simply changing the order of appearance, right? So that is why we have written disregarding the order of appearance. We are disregarding the order of appearance. Okay. Okay. Disregarding the order of appearance. Okay, guys. Got it? See, like 19 from Tamil Nadu, you have slight chance, but it is going to be 50-50, right? Okay, perfect. Let's move on. Classification of co-prime numbers. This is again another important terminology. This is something which is required to understand the problem very, very carefully, right? If the HCF of two given numbers, not necessarily prime is 1, then they are called co-prime numbers. Example, 4 and 9 are co-prime, as HCF of 4 and 9 are 1. Any two consecutive numbers will always be co-prime. This is something. Now, when you see this terminology, this means HCF of A and B. When you see this terminology, like we will use these terminologies, right? LCM of A and B. Okay, this is HCF of A and B, this is LCM of A and B. Don't worry guys, we will be doing certain problems. You don't have to worry about it, we will be doing certain problems. Meanwhile, can you please like the video? Okay, many of you have already liked it. Got it. Perfect. So, even numbers. We all know what are even numbers, what are odd numbers, we all know, right? We can neglect this definition. For now, we can neglect this definition. We do not have to worry about this definition, right? But see this, 0 is an even number. They can be represented as 2n. Odd numbers can be represented as 2n minus 1. This is very important, right? You just plug in any integral value of n, you will get odd. Let's assume that you are putting n equal to 14. 2 into 14 is 28, 28 minus 1 is 27, 27 is an odd number, right? That is how we represent odd numbers in a particular way, okay? Got it? Perfect. Perfect. Complex number you can just ignore. Now, this is very important. Square and square root was a chapter in your class 8. Square and square root, cube and cube roots, right? So, like I said, you need to remember the square till 50. Square roots are simply not to be like remembered as such. For example, square root of 2 is 1.4142. Square root of 3 is 1.732. If you do not remember them, it's okay. I don't mind. By itself, then the product is called square of the number. Perfect square, you already know, 149. Perfect squares are always non-negative. This is something which you need to remember here is this. There are two things. Square root of 81 is only 9. Square root of 81 is not minus 9. So, square root of positive number is always positive. This is one rule which you need to remember, right? This is one. Second, if a square plus b square plus c square, it is given to be less than equal to 0, it implies a equal to b equal to c equal to 0, provided a, b, c are real numbers. If they are imaginary number, then it's a different story altogether. But squares of 3 real numbers adding, and if the addition is less than or equal to 0, it implies a equal to b equal to c equal to 0. Got my point? Got my point? Perfect. Perfect. Let's move on. So, properties of square root. This is something which is related to cyclicity. Cyclicity also. Unit digit of numbers 2, 3, 7 or 8, then it does not have a square root in n. What does this mean? There exists no perfect square with unit digit 2, 3, 7, 8, right? So, let's write down some perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, right? If you see, unit digit has a cyclic pattern, 14965, 69410, right? 14965, 69410, again 14965. So, this unit digit pattern will repeat, and that is why I am calling it cyclic pattern. Cyclic pattern, it is cyclic, right? It is simply cyclic. And as you can see, these digits do not appear in unit digit in this cycle. You cannot find 2, you cannot find 3, you cannot find 7, or you cannot find 8. Getting my point? Getting my point? Right? Are you getting my point? Perfect. If a number adds an odd number of zeros, then it does not have a square root in n, obviously. See, like if you do 100 square, the number of zeros will always be even, right? So, this is a very self-explanatory point. If square root of even number is even, the square root of odd number is odd, right? This is also self-explanatory. But these points are to be written. These points are to be written in your notebook, believe me. When I am saying this thing, an obedient learner is the one who blindly follows the instruction of educators. And believe me, examinations like JEE, IOQM, NEET, these examinations can be cracked in mentored studies. What is a mentored study? You are seeing my lectures, you are doing as I am instructing you, and you are following what path I am laying down for you, right? Right? Perfect. Cube and cube roots again. Now, cubes are something which can be negative also. So, minus 2 whole cube is minus 8, right? These are certain definitions only, right? So, a and a cube will always be of the same sign. Will always be of the same sign. Correct? Correct? Will always be of the same sign. Got it? Now, this is where the fun begins. This is where the fun begins. In class 9th, you must have done problems related to rationalization of numbers. In class 7th or 8th also, you may have done problems related to rationalization of numbers, right? So, we have a term called surds. Any irrational number of the form this is given a special name surd, where a is called radicand, also the symbol is called radical sign, and index n is called order of surd. It is read as nth root of a, nth root of a, and can be written as a to the power 1 by n. Now again, if we were giving board examination, we would have written what is n, is n natural number only, right? Can n be rational? All these things do not matter here. All that is matter, all the things which matter to us are the properties which are coming next. Which are coming next. But these are the irrational numbers which we study till IOQM. Irrational numbers like e, pi, pi plus e, log, all these type of numbers, these are also irrational numbers, but they are important in JEE. They are not important in IOQM. Log to some extent is important, but it is not that important, right? Got it. So, these are the laws of surds. They are simply like exponents, right? So, nth root of a, if you just raise it to the power n, you get a. Obviously, we assume that a is greater than 0. We are assuming that a is greater than 0. Nth root of a into nth root of b is this. Order should be same. Nth root of this is also okay. Now, this is something which you need to understand. A to the power 1 by m to the power 1 by n, these powers get multiplied. And if you write them, just like you write the surd, you can write it like this, right? And you can see that you can change the order also. Here n is written, here m is written, here m is written, here n is written, okay? And this is very important to change the order of surd. For example, if you have 2 to the power 1 by 2, you can write it as 2 to the power 3 to the power 1 by 6, because you can multiply them. Then you can write them as 8 to the power 1 by 6. Got it? You can write these laws. You can write these laws. Also, a to the power 1 by m into a to the power 1 by n is equal to a to the power 1 by m plus 1 by n. Right? Got it? Sir, please explain once more. Which point? Which point do you want me to explain once more? Can you just tell the number of points which you want me to explain once more? Please explain fifth point. Fifth point is changing the order. So let us take one example now. Let us take one example. Let us take one example. Right? Which is bigger? Which is bigger? 2 to the power 1 by 2 or 5 to the power 1 by 5. Right? Let's compare these two. Now we cannot compare them simply. We cannot compare them simply. What we do? We need to change the order. Now what is LCM of 2 and 5? LCM of 2 and 5 is 10. Right? So what I need to do? I need to make 10 here. But I had only half. So what I will do? I will write half as like this. Similarly, I will write 1 by 5 as 2 by 10. Now, according to a particular law which we have just studied, you can write them like these, right? And then 32. That is why, by the way, I told you. That is why, by the way, I told you, you need to remember powers of 2 till 10. Right? Getting my point? 32 to the power 1 by 10, 25 to the power 1 by 10. Now this is greater, hence this is greater, hence this is greater, hence this is greater. Right? So this is the application of fifth point. Now do you understand the fifth point? Right? So there are certain properties which are very difficult to understand when we just read them. But once we see the example like this, now we are seeing the example like this, we can actually understand it properly. Okay. I don't think the voice is low, right? I don't think the voice is low. Is my voice okay? Is my voice okay? This is going to be a 90-minute lecture. This is supposed to be a 90-minute lecture. Sir, we do not get feel in English. Do not study from these lectures. We have Hindi lectures already recorded, right? You can go for it. Okay. Perfect. Perfect. So now, like I said, it is used, like the order changing theorem is used for comparison of surds, right? So this is something which is important. Please write it down. Comparison of surds. Obviously, whatever we are studying here, we will do problems of these things. We are going to do problems of all the concepts that we have studied in this lecture only. Don't worry. Every lecture is going to give you the sense of fulfillment. Every lecture will give you the sense of fulfillment. Don't worry about it. Okay. I do not have any experience of Bernard and Child. I have not seen this book. Hollandite, for me, Hollandite is very good for higher algebra. Right? Rationalizing factors. Right? Now I am going to skip all these things. We are going to do exponents. Right? Because those things we will do in problems. Right? Right, because we need to understand the application of these things. We are not giving any board exams. I am again and again repeating, these are certain terminologies. Trinomial surd, nobody is going to ask you what are trinomial surds. Nobody is going to ask you what is binomial surd. Nobody is going to ask you that, right? So you don't have to worry about it. Okay. All these problems we are going to do. Okay. Now, exponents and surds go hand in hand. In fact, I think all of you must have seen these rules. Can you please just note them down? And if you have any problem in any of the rules, Just let me know which rule is to be explained. You can just simply tell me which rule is to be explained. Which rule? Yes, yes, this is code, this is free for everyone. This is free for everyone. Seventh point. Okay. A to the power bn, positive number, n is rational number. Okay. So this is also very simple thing. I don't know what is the problem here, but it is also very simple thing. See, it is written as a to the power bn, right? Now b can be written as b plus b plus b n times, right? So it can be written as, this is what it is saying. Okay. 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 And one more thing which you can write here is, see, this is a symbol. If A equal to BC, ABC belongs to natural number, it implies B divides A. So we write it as like this. We write it like this. B divides A. C divides A. Okay. Okay. This is very important, guys. This is very important. Okay. While explaining, the voice is very low. Is it? Is it? The voice is very low when you are explaining, sir. See, like I have increased the levels. I have increased the levels. I have increased the levels. I don't think it will be a problem anymore. It will be a problem anymore. I don't think it will be a problem anymore. Fifth, the explanation of fifth point. A to the power n into a to the power minus n is a to the power 0. So like the powers get added, right? N minus n. This is the same thing. While we divide, the powers get subtracted. While here the powers get added. So if you replace n with minus m, you replace it everywhere. M minus m is 0. Okay. Okay. Next class is next Wednesday. Next class is next Wednesday. You can ignore them, guys. You can always ignore the spams. There are going to be some people who will always spam. You don't have to worry about them. You don't have to be worried about them. Okay. Chalo. Let's move on to the problems. Simply make the denominator rational. Now I am going to tell you how it works. Basically, when you see irrational numbers, what is root 5 plus root 2 into root 5 minus root 2? This is the identity which is very important. Always you have to think it like this. This becomes root 5 square minus root 2 square, right? A plus b into a minus b. So you have to think it like this. You have to think it like this, right? So when you have root 5 minus 2 root 2, just take root 5 plus 2 root 2 as the rationalizing factor, right? So what you have to do, make the denominator rational. So this thing, let us do it, and you will help me in calculation. My calculations are very weak, so you can help me in this, right? What I am saying, that this is the number which is actually written. Now I am going to replace this subtraction with addition, and since it is mathematics, I cannot simply multiply it in denominator. I have to multiply it in numerator as well, right? Now can you help me in multiplying these two? Can you help me in multiplying these two? Please help me, guys. Please help me, guys. Right? This is my request. Don't be lazy. Don't be lazy. Please do it. Don't be lazy. Right? Perfect. So now I'll consider this as A and this as B. Okay. For simplicity, I will write numerator as NR. This, because otherwise it will be very tedious to write each and everything again and again. 3 plus root 5. Now, what is A minus B into A plus B? This. Right? Now, let us do some rough work. 3 plus root 5 whole square is A square plus B square plus 2AB. So, it is 14 plus 6 root 5. Okay. So, it becomes numerator upon 14 plus 6 root 5 minus 8. Right? 2 root 2 square is 8. So, this becomes numerator upon 6 plus 6 root 5. Now it is interesting. Now it is interesting. We already had 12 here. So, now I will write it properly. Till here, I was very lazy. I was just writing NR in terms of this. Now I can write it like this, actually, to cancel some of the factors. Okay. Okay. But still, my denominator is not rationalized. So, now this is the difference between IOQM. When I said this thing that I am going to teach you 9th and 10th at the level of IOQM, this is what I meant. You cannot find double rationalization. We are doing double rationalization here. What is double rationalization? We have rationalized it once to get a number which is not yet rationalized. So, we are going to rationalize it again. This is double rationalization. This is not asked in NCERT. Right? So, this is IOQM. 2 into 3 plus root 5 plus 2 root 2. We are simply going to multiply it with root 5 minus 1. And now, I am taking the liberty to write it directly. Root 5 plus 1 into root 5 minus 1 is 4. Okay. 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 See, like, see, if you had the intent of sending the sweets at my home, then I already told you the address, right? It is PJ House. Right? You could have searched Prashant Jain House on Google. You would have got the address. Now we just have to simply multiply. Root 5 into 3, 3 root 5 plus root 5 into root 5 is 5 plus 2 root 10 minus 3 minus root 5 minus 2 root 2. Okay. Upon 2. So, what do we get? 3 root 5 minus root 5 is 2 root 5. 5 minus 3 is 2. Nice. Plus 2 root 10 minus 2 root 2 upon 2. So, we have root 5 plus 1 plus root 10 minus root 2. Okay. Okay. I think I am making sense here. This is going to be the final answer. This is going to be the final answer. And I think Dhairya Gupta has got the exact same answer. Dhairya Gupta has got exact same answer. Right? Okay. Right? Sir, why did we multiply? Again, we are rationalizing it. That is what I told you. We always use this, right? So root 5 plus 1. How do I rationalize it? By multiplying it with root 5 minus 1. Our aim is to square it. How can you square it? A plus b into a minus b. So a square minus b square is the most important identity to rationalize the irrational numbers, specifically in denominator. Okay. Next question. Next problem. Square root of 7 plus 2 root 10. Now what are we asked? I am going to give you a very simple. We are asked this. What is going to be the square root? Root a plus root b. Just square them and compare the coefficients. Right? Just square them. A and b are irrational. Follow what I am saying. Square them. So the tagging is irrational numbers. This is the key idea. Root 5 plus root 2. Aditya Sharma is saying root 5 plus root 2. That was very fast. Maybe you did it already. So what I am trying to say, you just have to square it. Right? Root a plus root b. So 7 plus 2 root 10 is equal to root a plus root b square. So when you square it, you get a plus b plus 2 root ab. Now let's compare. 7 is a plus b and 10 is ab because it is 2 is common. Right? Right? Now, a very important note here. Very important note. Quadratic equation with root ab is x square minus a plus bx plus ab equal to 0. Because when you factorize it, you will get this. You will get this. Now you already have a plus b. So by this logic, you have this quadratic equation. And once you solve it, you will get 2 and 5 as the two roots. These are the two roots. Right? So you simply have the answer root 2 plus root 5. Got it? Please write dn. If you have understood it, write dn and note it down. Write dn in the chat and note it down. Why? Sir, aap 2020, the way you were teaching in 2020, you are not teaching with the same enthusiasm. Like I said, see, I am putting in a lot of effort in my language. So it is going to be, it is very obvious. It is very obvious that I cannot teach with the same enthusiasm because the total energy is conserved. If I am putting my energy in language, then I have to save some energy from the enthusiasm, right? Right? Okay, perfect. Now this is the question. This is very important. This is very important. Now I will let you do it on your own. I will let you do it on your own. This is a very important key idea. There is a key idea behind this question. Right? Do it. Very interesting. Very interesting. This is very fast. You are getting the answer very fast. Sir, one class every night, please sir, with questions. Guys, I have a life. I have a son and a daughter and a beautiful wife. I need to spend time with them also. Right? I started teaching in 2017-18. So now, first of all, we will rationalize it. Right? So you will get this. You must have got this. Then we will take it here like this. So what do I get? X square minus 4x plus 1 is equal to 0. Just simply square it and you will get it. Right? Now here is an interesting part. You see x cube. Right? Now let's do some manipulation here. I will write it as like this. Okay. Why I am doing it like this, I will tell you. But I had only minus x square. So I will write plus 3x square minus 12x plus 3. Right? Now here I can take x as common to get this. Why I am generating this? Because this is the thing which is equal to 0. So this is 0. Right? And the beautiful part about writing it like this, first you get the answer as 1 because rest of the thing is 0. You have also learned to factorize, to divide the polynomial. This polynomial can be written as, see, like x square minus 4x plus 1 was the divisor. Let us take this as a divisor. X is one term, plus 3 is another term. So you are essentially writing this particular polynomial which is given in the question, the value of which is to be found as the divisor into quotient plus remainder polynomial. Now since this is 0, you get this as 1. Getting my point? This is the answer. This is the answer. Please write it down, guys. This is a very important problem. This technique, like I have named it, this is called reduction technique. This is called reduction technique. When you take the help of given condition, to reduce the degree, see, like the degree of this polynomial was 3. You used this information to reduce it to a constant. So you essentially reduced the degree. Okay. Okay. Next, let's do the next problem. Guys, I want you, see, like if any of the learner is coming to see the recorded of this video, please mention in the comment section. Please mention in the comment section that, sir, I have seen the recording of this video. I could not attend it live due to certain circumstances, but I have attended it in recording. Please, guys, this motivates me that the learners are actually liking the idea of English lectures. Okay. Perfect. Now, this is a question very similar to that. Again, a different typology, but it is required. See, solve it. 3 minus 2 root 2. Find the value of x square plus 1 by x square. If x is equal to 3 minus 2 root 2, find x square plus 1 by x square. You are saying 634. Some of you are saying 34. So x square plus 1 by x square. Now in these certain problems, see, like these are the particular type of surds. 3 minus 2 root 2 into 3 plus 2 root 2. This is 1, right? So this is a very important type of irrational numbers in which you multiply them with their rationalizing factor and you get 1. Okay. Now, since this is x, obviously this is 1 by x. That is why, that is how the multiplication will be 1, right? So this is going to be reciprocal of this. So if I have x as 3 minus 2 root 2, I have 1 by x as 3 plus 2 root 2. Now what I will do, I will just simply add them. If I add them, I have 6. Now when I square them, I will get this, and hence x square plus 1 by x square is 34. Now you can note down these points. If x plus 1 by x is s, then x square plus 1 by x square is s square minus 2. X cube plus 1 by x cube is s cube minus 3s. Right? You can note these points. Good to know these things. Sir, isn't it 2 times a square minus b square? You can assume it to be like this. But like, I always find this method to be easier calculation wise. Easier calculation wise. Now, what Arise Dubus wants to say is this. Sir, see, like x is a minus b. You yourself said x is a plus b. Now x square plus 1 by x square is nothing but a minus b square plus a plus b square. So you can simply write them as 2 times a square plus b square. A square is 9, b square is 8. So it is 34. I am certainly appreciating this method, but this is not something which you will use in your examination, in my opinion, because once you are asked about x cube plus 1 by x cube, this method falls flat. Right? Because now x cube plus 1 by x cube can be simply written as 6 cube minus 3 into 6. 216 minus 18 is 198. Okay. So this method is preferred. This is more general. Okay, guys. Am I making sense? Am I making sense to all of you? Got it. Rationalize the denominator. Now you can rationalize the denominator. This is a very simple problem. This is added so that I can gauge if you are able to do it or not. Sir, want to study for AMC Head? You can follow these lectures. See, like if you are studying for AMC Head, you will be comfortable in English. How you doing? I'm doing great. Right? See, like the beauty of these lectures is these are going to be live. So if anybody wants to learn live from me, these are the lectures, right? Perfect. Now 1 by root 3 minus root 2 minus root 1. Simply what I will do, 1 upon root 3 minus root 2 minus 1, right? I'll simply multiply it with this. Okay. So now again I will carry numerator here. Denominator, take this as a and 1 as b. So root 3 minus root 2 square minus 1. Numerator is numerator. Root 3 minus root 2 square is 5 minus 2 root 6 minus 1. So it becomes numerator upon 4 minus 2 root 6. See, like, you should not be worried about calculation. If you are preparing for IOQM, calculation should be least of your worries, because you will get enough time to solve the calculation, right? 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 So root 3 minus root 2 plus 1 into. Now you can see this becomes 2 into 2 minus root 6, right? Which is obviously a negative number, but we are not worried about it. 2 minus root 6, just simply multiply it with 2 plus root 6, right? What do you get? What do you get? It was a negative number anyway. What do you get? In the denominator, you get 2 minus root 6 into 2 plus root 6 is 2 minus 2. So in denominator you get minus 4. In numerator you get 2 root 3 minus 2 root 2. I am simply multiplying 2 with all of them, plus 2 plus root 18 minus root 12 plus root 6. Okay. So 2 root 3 minus 2 root 2 plus 2, 3 root 2, this is 3 root 2 minus 2 root 3 plus root 6 upon minus 4. 2 root 3 gets cancelled. 3 root 2 plus, so you get 2 plus root 6 plus root 2 upon minus 4. So this is your final answer. Can you please check it? Can somebody please check it? Yeah. If you take minus above, you will get subtraction in the denominator, in the numerator. Yeah, this is actually a good convention. We should always write negative in numerators. The denominator should always be positive, right? Okay. Sir, should I refer your book for AMC2? Yes. See, like, I have included AIME problems for the same reason. For the precise reason, I have included them. Got it? Now, do these problems. Very simple to develop your number sense, so that you should not be afraid. You should not be afraid of irrational numbers. You should not be afraid of irrational numbers. Do these problems. Half, right? So now what I do, 64 to the power 1 by 3, 1 by half. So it becomes 64 to the power 1 by 6. This becomes 64 to the power 1 by 6. And minus is always used to just invert it. So 64 to the power 1 by 6 is 2. So you have 1 by 2, right? Now 1 by 121 upon 169 is, first of all, write it like this, and then take half inside and then cube. So this becomes 13 upon 11 to the power 3, 2197 upon 1331. Okay. Okay. Please do not write 13 cube upon 11 cube. I told you to remember these numbers. 13 cube is 2197, 11 cube is 1331. You need to remember these numbers. You need to remember these numbers. Kush Agarwal is saying SOF level content. See, like, every lecture of, in fact, every first lecture of any competitive examination is going to be of basic level, right? If you want to see my levels, come after 10-15 weeks, right? Then you will know. then you will know. And this is how the teacher has to teach, right? It has to, like, a learner has to develop his thinking from the basic. Perfect. Now this is very important. How to approach problems like these. A to the power x is b, b to the power y is c to the power z is a. Prove that x, y, z is 1. A, b, c are distinct numbers. Distinct numbers. Why it is written distinct numbers? Because see, like, if a equal to b equal to c equal to 1, then x, y, z can be anything. X, y, z can be anything. That is why it is written that these are distinct numbers. Right? Just put value of x. Now this is very interesting, right? A to the power x is b, b to the power y is c, c to the power z is a. Now I'll put value of b here. Now I will put the value of this as here. You get this? Now a to the power x, y, z, it has two solutions. Either a is equal to 1 or x, y, z equal to 1. This is rejected as it will result in a equal to b, which is contradiction to the given situation. A, B, C are given to be distinct. Got it? So we have proved it. We have proved it. We have proved it. Okay. Should we move on, guys? Sir, how to start JEE preparation earlier in 10th currently, and should I prepare for IOQM 2025? See, if you are in class 10, doing IOQM preparation is covering your early start. You are preparing for JEE if you are preparing for IOQM, for sure. Right? Now, n square plus 2n minus 8 is a prime number. Prime number, right? We had a discussion related to prime number where n belongs to n. Then n is. What is n? You need to tell me this thing. This is a very interesting problem. It has to do with the fact that prime numbers has only two factors. Prime numbers has only two factors. Right? Right? Also a prime number. Then n is. So first of all, we need to factorize it. We will learn factorization. Don't worry, we will learn factorization. But those who know can see that this is the factorization. N plus 4 into n minus 2. Now, this is a prime number. Now, prime number has one of the factor as 1 and itself. So, this is a smaller number. So, n minus 2 has to be 1, which means n is equal to 3 and this prime number is 7. So, n has to be equal to 3. N has to be equal to 3. This is a very important thing. First of all, you factorize it. You factorize this quadratic polynomial. Once you factorize this quadratic polynomial, then only when you factorize this quadratic polynomial, then only you can say that one of these factor has to be 1. So just put it as 1. So n is equal to 3, so it is a relatively prime number. It is a prime number. Relatively prime to 10, yes, not a composite number. So A and B, A and B, A and B. Okay. 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 Done, guys? Perfect. I Prachitas Bhattacharya. I remember Prachitas Bhattacharya. Were you there in my first English course? So I already attempted IOQM English course once in 2021, right? So, but I stopped teaching. Sir, please start live batch in Hindi. No, it is not going to happen. Guys, do not be in any type of like, I am not going to make any false promises to you. I am not going to start any batch in Hindi because I have already taught in Hindi. This batch also I am doing it for the last time because I had no content in English. This is why I am doing it live. If you want to study live from me, follow this batch only. Okay? Follow this batch only. Got it? Chaliye. Oh, just a second. Consider the equation. Number of even integers satisfying the equation. Now you need to solve this equation. See, so it is factorized like this. Equal to 0. So x into x minus 1 into x minus 2. So when you have equations like this, you have roots as 0, 1 and 2. These are the 3 roots. These are the 3 solutions. So number of even integers satisfying the equation is 2. Number of odd integers satisfying the equation is 1. Number of odd prime natural number. Number of composite natural number satisfying the equation is 1. Correct. In fact, yes. In fact, nothing. No composite number is satisfying. Right? No composite number. A and B only. A and B only. Again. Got it? Am I making sense, guys? Am I making sense, guys? Am I making sense? Got it. Now you can see. So twin primes is like this, which we both are prime, difference is 2. They are called twin primes. Twin primes, right? So it is a pair of prime, it is a twin prime, is a pair of co-prime, okay. 2, 6 is pair of even number. So you need to match the column. You need to match the column. So A is P R, right? For B, P Q R. For C, P pair of prime, co-prime. For D, 2, 6. 2, 6. Only S. For E, we have 23 and 81. 81 is not a prime number. So P is incorrect, Q is incorrect, R is correct. So this is going to be the answer key. Can you see it? Yes. Hindi batch is recorded. Hindi batch is recorded. It will be premiered today also at 7 p.m. It will be premiered today also at 7 p.m. right? Got it. What about paid batch? So paid batch is already live Tuesday, Thursday, Saturday. We are teaching on Zoom, right? So it's a different platform. We are using Zoom for it. The multiplication of rational number x and irrational number y is, now you tell me the answer. Multiplication of a rational number x and an irrational number y is, always rational, incorrect. Always take the counter example. If you have to prove something wrong, just give counter example. 2 and 2 root 2. Rational except this is incorrect. Always irrational, incorrect. 0 and root 3. Irrational except when x is equal to 0. This is correct. D option is correct. Right? Right? If somebody wants to attend the Hindi lecture, they can obviously drop out from here. Okay? Right? Now, find the total number of even factors. Now, this we do not know. So, we are going to skip it. We'll discuss this later. This again we have not discussed today. Yeah, this is something, this is a homework for you all. Right? Write answer in comment. Write answer in comment. Right? Basically, see, like we studied how to find the square root of irrational numbers. So, you have to find the square root of this, then you have to find the square root of this, then you have to find the square root of this. This is how you are going to do it. This is how you are going to do it. I have given you the hint. Do it and write it in the comment section. Comment section, right? Which is greater. So, all these are homeworks. All these are homeworks. Like you were asking, are there any homework questions? These are the homework problems. All these are homework problems. You can write the answers in the comment section. You can write the answer in comment section. Right? You are saying there is no A. This is A. This is A. This is A. Okay. This is A. Today, we are going to do something very, very important. Factorization of polynomials. It is going to be the foundation for algebraic identities, algebra. In fact, the first lecture we did was foundation of number theory. This is going to be foundation of algebra, right? This is going to be foundation for algebra. So, it is my request that all of you should like this session before we start, right? And so, these are certain links. First of all, you should definitely follow this channel. This is my personal channel of an academy. In this channel, you will get all the updates. Even if you are missing out on any lecture, you will get the update here. Okay. So, guys, first of all, what do I mean by factorization of polynomial, right? We all know what are polynomials, the degree of polynomial. So, let's assume that this is a quadratic polynomial, right? This is a quadratic polynomial, right? Now, I can factorize it in two linear polynomials, right? So, the basis of factorization, which I want you to understand very, very properly, is that if Px, if we are factorizing polynomial Px into this, it implies degree of Px must be equal to degree of Qx plus degree of Rx. Okay. Please note it down, guys. This is very, very important. Total degree of Qx and Rx should be equal to degree of Px. Okay. The live is in English. These lectures are in English. I have already told you these things. This course is going to be in English, complete English. And in the future time, SPSS sir will also be taking these sessions. SPSS sir will also be teaching in English, right? So, what do I mean by factorization? What do I mean by factorization? And what will this mean to me, right? So, if you see this polynomial Px, x square minus 5x plus 6. Now, when I am putting P2 you can see I am getting 5 minus 10 plus 6 is equal to 0. Now this implies x minus 2 is factor of x square minus 5x plus 6, right? Similarly, I get P3 equal to 0, because of which x minus 3 is also factor. Now, what is the name of this theorem? Can you tell me the name of this theorem? Right? X equal to 2 is called 0 of polynomial, right? 0 of polynomial. What is written? Let's consider polynomial Px. P of minus 4 is equal to 0. The value of x for which Px equal to 0 are called 0 of polynomial. Now, this is something which is assumed to be true, which I am assuming that you know it. Like I am assuming that you already know it, right? The thing which is to be done is the factor theorem. This is called factor theorem. Yes, Arindam Chaudhary is correctly mentioning the name of the theorem, not factory theorem, like somebody is saying factory theorem. It is not factory theorem, it is factor theorem, right? It is factor theorem, right? So this is the basis of factorization. This tells us that polynomials can be factorized, but this is largely hit and trial. If you can see, this is largely hit and trial method. If you are putting some value and getting the value of polynomial to be 0, then that linear factor is the factor of that polynomial. It is a hit and trial thing, right? In this lecture, we will be doing certain methods which helps us directly factorize without hit and try. Okay? Okay? Am I making sense, guys? Am I making sense? Am I making sense, guys? Please tell me if I am making sense. Please tell me if I am making sense. Perfect. Yes, the Hindi YouTube course will cover the entire syllabus. Okay, perfect. Perfect. So, if you have noted it down, please write DN so that I can move on to the next slide. You can write DN in the chat bot so that I can see it and I can move on to the next slide, right? RMO workshop is being held on Olympiad goal, right? Okay, perfect. So, remainder theorem. Now, we will go a bit back in remainder theorem. Let Px be any polynomial of degree greater than equal to 1, right? So, what is it saying? What is it saying? That if Px is, this is division algorithm, right? You must have done it in some of the lectures, right? In your previous classes or somewhere, you must have done this, right? Okay. So, if Px is equal to, let's assume that this is a polynomial of degree greater than equal to 1. This is a quotient polynomial. This is remainder. This is remainder. It will be a constant remainder because of one condition which I am telling you. This is linear polynomial. We have the condition that if we are dividing it with a polynomial of degree k, the remainder polynomial is either 0 or degree of Rx, remainder polynomial, is always less than degree of dx. This is the case, right? So, if your divisor polynomial is linear, then your remainder will be a constant value. Okay? Constant value, right? It will be a constant value. So, let's try to figure out. Now, when you put x equal to a, you get P of a here. This becomes 0. So, the radius becomes, remainder becomes P of a. So, you can directly get the remainder by putting value of x is equal to a. So, the basic benchmark rule here is you just need to put x minus a is equal to 0. Whatever value of x you get, you just put it in the polynomial in this whole division algorithm equation. You will get remainder to be this, and this is precisely, so this is the explanation, this is the statement, this is basically remainder theorem. How it is useful, we are going to see in the next slide. Can you please write it down? Can you please write it down? Can you please write it down? Can you please write it down, guys? Can you please write it down? Done? Perfect. Perfect. So this is remainder theorem. This is remainder theorem. Now, do you know what is the meaning of corollary? Corollary is logical extension of a theorem. Logical extension of a theorem. So factor theorem is a logical extension of remainder theorem, which says if PA is 0, right, the remainder is 0. PA is 0 means remainder is 0. It implies x minus a divides px. I told you in the last lecture this symbol means divide, right? I told you in the last lecture this symbol means divide. Okay. This is for IOQM. Yeah, the syllabus is very, very similar to AMC. That is true. Okay, guys. Sir, can I do Hollandite after completing till 10th syllabus? Yes, you can do it. Hollandite, elementary algebra and higher algebra. You can do both. Perfect. So this is the logical corollary, right? Factor theorem. If Px is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is factor of P of a, right? We are going to write one more statement here. I am going to write it as one note. Find quadratic polynomial with zeros a1 and a2. Can you please give me quadratic polynomial with zeros a1 and a2? You can write it in the chats. You can write it in chat. Can you please give me that? Sir, I will send enlarged pizza to your address if I qualify RMO Pakka. Promise, do you eat pizza? Yes, everybody eats pizza, right? It's just that I eat it only on Saturday, Sunday. I do not cheat on weekdays. I cheat only on weekends. This is why I am so, I like to believe that I am good healthy person. X square minus a1 plus a2x plus a1 a2. This is one such polynomial, right? So many of you are saying that, sir, this is the required polynomial. Now actually I did not mean to ask in the expanded form, right? Actually this polynomial will be k times. Please make sure of this k. It will be like this. So this is how you represent a polynomial with given zeros. A k should always be there, because you can see if you are putting a1, p of a1 is 0, p of a2 is 0, right? It is the quadratic polynomial. And one more thing which you need to mention is that k is not equal to 0 and k is a real number. K is a real number. This is what you need. This is what you need. Are you getting my point? Are you getting my point? Right? So this is and for that matter, polynomial with a1, a2, an as zeros is k times x minus a1, x minus a2, x minus a. See, like sometimes we are able to factorize the polynomial, sometimes we are not able to factorize the polynomial. It is just part of the game. It is just part of the game, right? But we need to understand this thing, that if possible, if the factorization of polynomial is possible, if it is of, let's say, 4 degree, then there will be 4 linear factors. If it is possible to factorize it, there will be 4 linear factors. It can be factorized into one quadratic also. But the benchmark rule is the same, which I told you in last to last slide. What did I tell you? If Px is equal to Qx into Rx, then degree of Qx plus degree of Rx is equal to degree of Px. Getting my point? Right? Yes. Got it? Let's move on to the next. Let's move on to the next thing then. Okay. Let's See, let's solve this problem. Can you solve this problem? X equal to 2, x equal to 0 are zeros of the polynomial. This. Find the values of a and b. Use the theorem. Find value of a and b. Find value of a and b. Like I said, the level of the problems will be easy initially, but it will go to the IOQM level. Also, in the starting, the lectures are of basic level because I am teaching from the basic. Yes, result has not come yet. Meanwhile, guys, can you please like the video? It will be good if you can like it. Four comma minus 4. Okay, a2. So like, see, like x equal to 2, x equal to 0 are 0. So this means, first of all, you need to understand what this means. This means f of 2 equal to 0. This is one equation, and f of 0 equal to 0. So let's put what is f of 2. When I put 2 here, I'll get 16 minus 20 plus 2a plus b, which essentially means 2a plus b is equal to 4. F of 0 equal to 0, this is very simple. All these will be 0. So b becomes 0, this becomes a equal to 2. Right? You always need to understand that if fx is, let's say, ax cube plus bx square plus cx plus d, then this coefficient is f of 0. You need to understand that the constant term is equal to f of 0. Right? So value of a is equal to 2, value of b is equal to 0. Okay. Do you get it? Please write it down. All the questions are to be written in a particular copy. This lecture is to be noted in a class or copy. If you are just starting IOQM preparation, if you are doing the IOQM preparation for the first time, you are attending these lectures live, then you need to write them, write these problems, write the solutions with me. Right? You do not have to wait to end. You do not have to wait for the class to end. Getting my point? Getting my point? Perfect. Let's move on, guys. Let's move on. Let's move on to the next problem. If there is another problem, yes. The remainder. This is the direct application of the theorem. Please write it down. Find the remainder when fx is equal to x cube minus 6x square plus 2x minus 4. If this is divided by gx is equal to 1 minus 2x, find the remainder. Okay. Let's see. Let's see. So what do I do? 1 minus 2x is equal to 0, which essentially gives me x is equal to half. Now I will put half here. Right? I will get 1 minus 1 by 8 minus 6 by 4 plus 1 minus 4. So 8 is my LCM. 1 minus 12. This is minus 3, right? This is minus 3. So minus 24 minus 35 by 8. Am I making sense, guys? Am I making sense? Live lectures are always at 5 p.m. Live lectures are always at 5 p.m. Live lectures are always. Yes! So one fine student, Uday Bhanu, is saying, sir, use reduction. So I am going to tell you a smart way to look at it. Because see, potentially when I put fraction values, x equal to a half is a fraction, then I have this in my calculation, which is somewhat tedious. So I am going to use my brain. I am going to use my brain. A smart method. Can I write this like this? Right? Just try to see it. In fact, not like this, because see, like I need 1 minus 2x. No, 1 minus 2x. So what I am going to write, x cube minus x square by 2 plus 11, in fact minus 11x square by 2. So like see, like this is 6x square. I have splitted this 6x square into these two. Now the reasoning behind this is very simple. If I take x square by 2 as common, I will get 2x minus 1, which is 0, by the way, right? Now what do I have? So just I need to put half of it here, plus 11x by 4, right? Minus 3x by 4 minus 4. This is the thing. Now if I take 11x by 4 common here, I will get 2x minus 1 again, right? You must be worried, sir, there is calculation here also, but both these values become 0 when you put x equal to half. So you just have to put x equal to half here. So which gives you 3 by 8 minus 4, which is again equal to minus 35 by 8. Now this method may not seem to be giving value here. It may not be beneficial here, but it will be beneficial somewhere else. It will be beneficial somewhere else, right? It will be beneficial somewhere else. That is why I took a very simple example to explain this method. What have we done actually? If you try to understand it properly, I have tried to generate an expression which is actually already equal to 0. This was already equal to 0, right? This is what we do to find the remainder. Okay? Getting my point? Getting my point, guys? Sir, is there any similarity in JEE and IOQM syllabus? See, like the 40% of class 11th is already covered in IOQM syllabus. Whatever you study in IOQM is going to directly benefit you in JEE, and it will definitely make you master of mathematics. When you start JEE preparation, after completing your IOQM preparation, you will find JEE mathematics to be very easy. This is like the mathematics as a subject is the biggest problem for any JEE aspirant. Why are English courses once a week? Guys, we are going to double down the frequency in the coming future. But for now, it is 1 week, 1 lecture per week. The reasoning is very simple. We are still gathering the students for English course. This is the first time we have launched English course, right? So the audience will come mainly after NSEHSS exam, October-November examination, right? So till we gather the audience, we are just doing 1 lecture per week. Okay, let's move on to the next one. Now we have quadratic polynomial. Let's try to solve this one. So I am going to solve this question, right? I am going to give you the first line of it and then you will solve it. Now I am going to write division algorithm. See, you are dividing this polynomial. You will write qx into x square minus 1. And now since this is a quadratic polynomial, your remainder may come out to be linear. So that is why you have to write it as ax plus b. Okay, you have to write it as ax plus b. Getting my point? Getting my point? Getting my point? Getting my points? Now solve it, please. Can you please solve it? 9 minus x. Somebody is saying 9 minus x. Now see, like, the basic thing here is always make divisor to be 0. Always make divisor, this is the benchmark rule. Always make divisor equal to 0. So like this was your divisor. Hey guys, you understand what is divisor, what is dividend, right? It has been the nightmare with majority of the students. They get confused between divisor and dividend. So divisor is something with which you divide. Dividend is something which is getting divided. Okay. So x square minus 1 equal to 0 means x equal to plus minus 1. This is very simple. This tells us that we need to put x equal to 1 first. 1 plus 3, 4. 4 plus 6, 10. 10 minus 2, 8. 1 plus 3 minus 2 plus 6. Because when you are putting x equal to 1, this whole factor will become 0. Right? So this becomes 8 is equal to a plus b and x is equal to minus 1. So if you put minus 1 here, you will get 1, 3 plus 2 plus 6 is equal to, so this is how much? 10 is equal to minus a plus b. So you have these two as your equation. Now you just add them. 18 is equal to 2b, which means b is equal to 9 and which gives a is equal to minus 1, right? So these are the values. So your polynomial is, your remainder polynomial is minus x plus 9. Getting my point, guys? Getting my point? Getting my point? Are you guys getting my point? Right? You can write it as 9 minus x or you can write it as minus x plus 9. But again, let's think if we can do it by that other smart technique. Because with that technique, it gives me an additional information. Let's try to do this. X cube plus 3x square, right? I will write it as minus x, right? Now, I had plus 3x square, I will write minus 3. Now, what is left? See, I had minus 2x, so I have minus x again. I had plus 6, but here I am getting minus 3. So, to balance it out, I have to add plus 9. So, see, now this polynomial and this polynomial are same. You can see it. Now, why I wrote minus x? Because I was getting x square minus 1 to be common. So, this is the benefit. Now, you can directly see the benefit. The benefit of this is that you are also getting the quotient. You also got the quotient with this method, isn't it? This is the best use of this method. I think you got my point. I think you got my point. Okay. Okay, guys. Perfect. So this is a method which I call reduction. Right? This is the method which I call reduction. Right? So if you are using this method, you are actually doing reduction. So this is a homework question because you just need to check it. So I am going to go ahead. Yeah, please do it now. Please do it now. Find the value of a and b. Again, this is a very simple. Do not complicate it, please. It is my humble request. Do not complicate it. Do not complicate this question. It is a very simple problem. So these are the different typology of problems which we do. Sir, these are, yes, because I wanted to start very easy. Please try and understand this thing. This is done intentionally. This is done intentionally. Okay. This is done intentionally. Yes, the site has started working, but we are yet to get the result, right? So we just have to put, now I am going to do it fast. P of 1 means 1 minus a minus 13 plus b is equal to 0, which means b minus a is equal to 12. P of minus 3 is equal to 0, which means minus 27 minus 9a plus 39 plus b is equal to 0. So b minus 9a is equal to minus 12. Okay, you just subtract them. If you just subtract them, you will get 8a is equal to 24, which means a is equal to 3 and b is equal to 12. I think, no 12, b is equal to 15. So a is 3, b is 15. Okay, getting my point? Am I making absolute sense here? Am I making absolute sense here, guys? Am I making absolute sense? Tell me. Perfect. Let's move on to the next problem then. Right? Now this is all these are homework. Now this is something, this is the first part of it, right? This is the first part of it. This is the first part of it. And it has a second part also. It has a second part also. This is first part. Second part is x to the power 10 minus x to the power 8 plus 1. These two values are to be found. These two values are to be found. Okay. These two values are to be found. Right. And I am giving that x is greater than 0. Let's solve for both of these. Let's solve for both of them. Sir, if I give IOQM in 12th, so like there is no relation between IOQM marks and JEE advanced marks. I have seen students scoring so high in IOQM, like 77. I know a student who is scoring 77, right? And he is likely to get 100 marks in JEE main also, right? First is -1. Result, when is result coming? I don't know, guys, please. So like I thought it will come yesterday, but it did not. Okay. Now see, like you have x square minus x plus minus 1 is equal to 0. Now this is a very interesting thing. So you have x square is equal to x plus 1. Can I say this thing? This means you have x cube is equal to, I am just multiplying it by x, right? Now I am again putting x square as x plus 1. So I have x cube as 2x plus 1. Got it? So if I see x cube minus 2x is equal to 1. So I simply have 1 here, 1 plus 1 is 2. So the first one is 2. The first one is 2. Let's talk about this one. Let's talk about this one now. This was easy, right? This was easy. This was very easy. This was very easy to think. Sir, please teach Hindi. Guys, this is a mathematics class. Come on. This is a mathematics class. This is not English class, right? I am teaching mathematics in English language, right? This is not English course. Now, some of the people are thinking that I am teaching actually English. So, English is one subject in IOQM and I am teaching that. Guys, I, F, X, T, H, E, and these are English literals, okay. But this subject is not English. This is mathematics. See, I can crack jokes in English. People were actually thinking that I'll not be able to crack jokes in English. So, you do not need language to crack jokes, right? Language is just a medium. So, this is the second lecture. This is second lecture. You can see L2. Now, let's solve this. Now, I am going to see a pattern. IOQM patterns, these go hand in hand. So, you saw x square is x plus 1. Then x cube became 2x plus 1. Now, let's again multiply x to the power x again, right? And what do I get? I get this, right? 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 Do you see it, guys? Do you see it? X to the power 4 is equal to 2x plus 3. Do you see it, guys? Do you see it? What have I done? Oh, this was x, sorry. Just a second. This becomes 3x plus 2. Okay, x to the power 4. So now, x to the power 5. This is it. I get this. And after this, I get 5x plus 3. Now, if I see the pattern, what am I seeing here? What am I seeing here? Right? Just see these two. Then this, then this, then this. Coefficient here is 1. 1 plus 1 is 2. And this coefficient is coming here. See the pattern again. 2 plus 1 is coming here. And this particular coefficient is going here. Now, what is 3 plus 2? 5. It is coming here. And this coefficient is going here. Which means x to the power 6, addition of these two. And this coefficient will come here. X to the power 7, addition of these two. This coefficient will come here. What is x to the power 8? Coefficient of these two. What is x to the power 9? See, I need to find x to the power 10 minus x to the power 8. So, addition of these two. And what is finally x to the power 10? 55x plus 34. Now, let's subtract these two. X to the power 10 minus x to the power 8. 55 minus 21 is 34. 34 minus 13 is 21. Okay. Okay. So, x to the power 10 minus x to the power 8 is 34x. And I have plus 1 as well. So, essentially I got this, right, right, 34x plus 22, right. Please write DN if you have understood this. This is the power of reduction. What is the actual meaning of reduction? The actual meaning of reduction is I am representing higher powers of x in terms of linear expressions. So I have reduced their power, and that is why it is called reduction. I have reduced their power, and that is why it is called reduction. Got my point? Got my point? Please check the calculation. If the calculation is right, please check it. Right? Now, what people are trying to say, I got your point. This is smart. I agree. Sir, see, like this is this. Now, just multiply x to the power 8 here. Right? So, I got x to the power 10 minus x to the power 8 is equal to x to the power 9. X to the power 9 was directly this. And I also got this. It's okay. It's okay. If you are using your brain, I'm more than happy about it. I'm more than happy about it. Right? I'm more than happy about it. If you are using your brain, well and good. I like it. I support it. I appreciate it. Okay. So, this is the pattern, but you need to understand the pattern. What was the pattern? What was the pattern here? What was the pattern here? Leave this because there is a lot of calculation here. What you need to do, add these two coefficients. This becomes the coefficient of x in the next equation. Coefficient of x here becomes the constant in next expression. Right? Add these two, put here, put this here. Add these two, put it here, put this here. Add these two, put it here, put this here. Very simple. Very simple. Yes, this is for the next year. This batch is for the next year. Getting my point? But now this is 34x plus 22. Eventually, I did not get the answer. I just got 34x plus 22. But it is very simple now, right? If you see, x square minus x minus 1 is equal to 0. Right? This is x square minus x plus 1 minus 1 equal to 0. So, we have a very amazing formula known as quadratic formula. If this is the equation, then x is equal to minus b plus minus under root of b square minus 4ac upon 2a. So, this formula I will put, right? I will put I will find x using this formula. So, if I apply it here, x is equal to 1 plus minus under root of 5 upon 2. Now, it is clearly written that x is greater than 0. So, this value will be rejected and the x will only be 1 plus root 5 upon 2. 1 plus root 5 upon 2. This is like Fibonacci series. It is actually Fibonacci series. This is not like Fibonacci series. It is Fibonacci series only. Right? Got it? So, now let's put this value. 34. What was x? 1 plus root 5 upon 2 plus 22. So, what do I get? 17 plus 17 root 5 plus 22. 39 plus 17 root 5. Right? Now, how will IOQM ask this question? IOQM will say, this is a plus b root c. Find a plus b plus c. Right? This is how IOQM authorities will ask this question. Right? This is a perfect 3 marker. This is a perfect 3 marker of IOQM. This is a perfect 3 marker of IOQM. This is a perfect 3 marker of IOQM. Okay? Okay? Please make a star on this. This is a very, very important question. It is a previous year AIME problem. Nice. Nice. Perfect. This is amazing. Find all the zeros of polynomial if fx is this and two of its roots are minus root 3 by 2, root 3 by 2. This is perfect. This is perfect. Let's solve it. This is very basic. I am teaching it from the basic. Now let's apply factor theorem here. Let's apply factor theorem here. Let's apply factor theorem here. Find all the zeros of polynomial. See, like, now to start with, there are four linear factors to it, right? So if two of its zeros are this means this is one factor and this is one factor. Now let's do one thing. We are afraid of irrational numbers, right? All of us are afraid of irrational numbers. Let's do away with irrational number. Let's multiply. This is a plus b into a minus b, which gives us this. Okay. Okay. So this is, so these are one zeros. Now, if I put it as 0, I can clearly see 2x square minus 3 is one factor. So can I have 2x square minus 3 as one factor? Now, we will do our trick. 2x to the power 4, right, minus 3x square. See it. I want to get 2x square minus 3 to be common, right? This is my trick. Now, I had minus 2x cube. I am going to add plus x here, 3x, right? Because here I am getting, when I take minus x as common, this is perfect. Okay. See, like, this is taken care of, this is taken care of. But I have minus 7x square here and I have minus 3x square here. So I will add minus 4x square. But since I have only minus 4x square, I have to get plus 12 here, right? Till now, it is perfect, right? 2x to the power 4 minus 2x cube is sorted, plus 3x is sorted, plus 6 only, sorry, plus 6 only, okay? Because I need to, now this, see, like, this polynomial and this polynomial is same, you can check it. Now, in this step, I take x square to be common, perfect. In this step, I am taking minus 2x as common, perfect. In this step, I am taking minus 2 to be common, is it? Yes. Yes, 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 yes. Oh, this is complicated. This is complicated. This is not complicated. I am just taking x common here, minus x. Now this becomes easier. Okay. So now 2x square minus 3 is common and remaining we have x square minus x minus 2. Now simply you can see, if I put minus 1 here, x equal to minus 1, it is one factor. So this actually becomes this. Now this I have done by hit and trial. This I have done by hit and trial, right? This I have done in hit and trial, isn't it? I have done this by hit and trial, right? I have not taught you splitting the middle term. I am going to, in coming slides I am going to, but this is something which is to be done. Okay. Okay guys, am I making sense? Right? Perfect, perfect. Now this is a pressing question. Sir, how did you get it? This is a pressing question. This will be answered in this lecture only, don't worry, right? Now this is homework, guys. This is homework. Okay. Actually do it. Let's do it. Actually, let's do it. Right? Actually, let's do it. How do you solve it? It is to be done by division. Right? Now remainder theorem will not help here. Remainder theorem will not help. Factor theorem will not help because you are not being able, you will not be able to factorize it. Right? What if the other roots are irrational? We will see. We will see. First of all, if we have a quadratic factor, then we know quadratic formula. We will be able to solve it using quadratic formula. We will get the roots, right? Let's solve it, guys. X square plus x minus 1 is factor of x to the power 4 plus px cube plus qx square minus 1. 2 comma 1. Okay. So people are saying 2 comma 1. Let's see. Now, see, I have this. Okay. Which is equal to x square plus x minus 1 into obviously x square. Right? Now, this is something very important. If this is minus 1, I will definitely have plus 1 here and I will write ax here. So, I am going to tell you another method to cater this, another method. Why I got plus 1 here? Because minus 1 into plus 1 is minus 1. So, my constant and x to the power 4 are sorted. Now, I will compare x cube coefficient. X cube coefficient is p. What do I get as x cube coefficient here? X square into x 1, x square into ax plus a. So, this is one equation. Now, let me compare x square coefficient. X square here is q. How do I get x square coefficient here? X square into 1 is x square. X square into minus 1 is minus x square. X into ax. So, I have a is equal to q. This is another equation. Very simple. Now, x. Coefficient of x is 0 here. What is coefficient of x is here? X into 1, 1. Minus a into 1, minus a. This gives a is equal to 1. Now, as a is equal to 1, q becomes 1. As a is equal to 1, p becomes 2. This is another method. This is another method to go about polynomial questions. This is another method. Right? Right? Now, see, like this is one such class in which I will ask you, boys, can I drink some water? See, like the teacher is asking for your permission. So, there are two playlists for IOQM 2025. From which should I study? This is a very important question. If you are comfortable in Hindi and want to study more lectures per week, then you should definitely go for the IOQM recorded time-stamped course. It is available in Hindi. This is a live course. I have started a live course, but this is in pure English, right? It is in pure English. The grammar will not be pure, but the intent is very pure to teach those students who are not being able to study IOQM just because of language. Right? Right? Now, yes, yes. So, here I am going to tell you rational root theorem. Rational root theorem. Right? In a very simplified sense. Now, what have we understood? What have we observed? That see, like if I am multiplying these three, right, I get x cube here, something in x square, something in this, but this particular thing is a1 into a2 into a3, right, right, right. So what does this tell me? If leading coefficient is 1, if leading coefficient is 1, first of all, these type of polynomials are called monic polynomials. What do I call this polynomial? Monic polynomial. If my leading coefficient, what is leading coefficient? Coefficient of the highest power available, right? This is a monic polynomial because the coefficient is 1, right? So if leading coefficient is 1 and polynomial has integer 0, it implies it will be factor of the constant term, right? It will be integer factor. Now, what do I mean by this? What do I mean by this statement? Since I have 1 here, so when I have this polynomial, now I want to do some hit and trial here. So my hit and trial will be factors of 91, plus minus 1, plus minus 7, plus minus 13, plus minus 91. These are the only possible candidates, right? So we are not randomly doing hit and trial. There is a process to it. There is a method to it. There is some science to it, right? Because see, like there are infinite integers, but we have restricted the number of integers to only 8. Okay, okay, getting my point? Now I will just put 1. This gives me 0. Perfect, perfect. So since I have one factor, I will just simply divide it by this, right? So x cube. Now I have minus 1. I had plus 19x square. So I will write plus 20x. This way I have minus x cube minus x square plus 20x square is plus 19x square. This is matched. And to match the coefficient, what do I have to do? Just minus 1 plus 91 here. Now, I told you I will tell you this. I told you I will tell you this, right? So, see, what is the factorization of this? X plus a into x plus b, right? So what you need to do, you need to split this 20 in such a manner that the product of the two coefficients is actually equal to this. 13 7s are 91, right? And finally, once you factorize it, it becomes plus 13 plus 13, you will get. So I have told you two important points here. First, rational root theorem. Obviously, we have just done integer part of it, right? It is used, this is a broader theorem which is used to find the rational roots, not only the integer roots. But we have done the special case when the polynomial is monic. If the polynomial is monic, monic means the leading coefficient is 1, then all the rational numbers which are zeros will be integers only. You can write it down if you want. Second thing is splitting the middle term. This is called splitting the middle term, because see, like we have actually splitted this 20 into 13 and 7. So we have actually splitted it, right? IOQM score should be released any time now, right? Perfect. Perfect. Please write DN. If you have understood it, please write DN. If you have understood it, please write DN. How to simplify this process? Because there can be many factors. See, like we do not have any method. We do not have any method to, actually we do have, but it is very lengthy, to deterministically find the roots of cubic equation. We can always find, there is a formula to find roots of quadratic. So quadratic equation can always be factorized, but not cubic, not by quadratic, right? Perfect. Ah, nice. Now, this is where rational root theorem will come, because now we have 6 also here. Now let's see. Now let's see if we can factorize it. 6x to the power 4 minus 19x cube minus 23x square plus 10x plus 8. Let's see if we can factorize it. See, like sometimes hit and trial will work. Sometimes hit and trial will not work. Sir, will I qualify with 41 marks in IUQM? I think you should be able to. Fine. Cardano's method is for cubic, but I don't think you should use it. If you see the expression, it is very, very lengthy. Right? It is very, very lengthy. Double cross method. There is no method like I don't know any method which is double cross method, but we will certainly. So now these two things will come into the picture. So what is rational root theorem? The candidates are plus minus factors of 8 upon plus minus factors of 6 upon, right? So this means if I talk about integers, these will be my candidates. These will be my candidates, right? 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 So upon plus minus 1, plus minus 2, plus minus 3, plus minus 6. So if I talk about integers, only these will, but you can clearly see that 1 and minus 1 are not factors. In fact, so just put f of 1 is definitely not equal to 0. F of minus 1, 6 plus 19 minus 23 minus 10 plus 8. This becomes 0. Right? So this means x plus 1 is one factor. X plus 1 is one factor. Okay? X plus 1 is one factor. Yes, you will be able to qualify in 15 marks from Kashmir. I told you earlier this also. Right? Now let's do f of 2. What is f of 2? 16 6 are 96. 8 19s are, I don't know what is 8 19s are. Actually, this will also not work. 2. 2 will not work because it is too big. Now let's do f of minus 2. What is f of minus 2? What is f of minus 2? 96 again plus, yes, this might actually work. 19 8s are not, it will not work. 19 8s are is very big number. 152 minus 2 is minus 92. No, it is also not working. It is also not working. Right? It is also not working. So let's do one thing. Let's factorize it. I have x plus 1, 6x to the power 3 minus 19 plus 1 minus 20x square. No, not like this. It will not be like this. So see, like I have 6x to the power 4 now plus 6x cube. I want minus 19 x cube. So I will write minus 25x square. You can see it now, right? I have minus 23x square. Minus 25x square into 1 is minus 25x square. So plus 2x here, right? And plus 8. Does this solve everything? Yes. So now I want to factorize this. Now I have to factorize this. Yes. This is interesting. Now if I put x equal to 4 here, now see how I am going about it. X square is 6x minus 25 plus 2 into x plus 4, right? Now when I put x equal to 4 here, this becomes 16. 24 minus 25 is minus 1 plus 2 into 4 plus 4, which is again 16. So x equal to 4 is also one factor. Now this solves everything because I have plus 1 as one factor, minus 4 as one factor. Now I got minus 4 outside. So let's try to multiply it. 6x square. Now this becomes minus 24x square. I had minus 25x square. Write this and minus 2. This is perfect. This is perfect. Right? Now I will try to split this. This is very difficult. What is 6 into minus 2? This and this. This becomes minus 12. So I will split minus x into minus 4 plus 3, because minus 4 3's are minus 12. So 6x square minus 4x plus 3x minus 2. Now if you take 2 common here, you will get 2x common here, 3x minus 2 plus 1, 3x minus 2. So finally you have x plus 1, x minus 4, 2x plus 1, 3x minus 2. Kudos to those students who stayed till here, because some of them left because they were thinking that the level of this lecture is very low. This is some high level thinking. This is some high level thinking. This problem has calculation. This problem has formulation. This problem has manipulation. It has everything. Right? Right? I did not get x plus 3. I did not get x plus 3. Got it, guys. Got it. Perfect. Let's move on. This is already done. Okay, now HCF and LCM of polynomial. Now this is something which is very, very simple. Just consider it similar to numbers. Just consider it very, very similar to numbers. What is HCF and LCM of polynomial? So I'll just give you the example. Don't read these things, because otherwise you will get confused. Don't read these things, right? So what is, let's take Px as x minus 1, x minus 2 square, x minus 3. Qx as x minus 2, x minus 3 square, x minus 4. So the LCM polynomial, HCF polynomial becomes common factor. Is x minus 1 common? No. X minus 2 is common with one factor. X minus 3 is common with one factor. So this becomes the HCF. It is exactly like numbers. LCM polynomial becomes the highest powers of everything. X minus 1, x minus 2 square, x minus 3 square, x minus 4. And it also has the similar property that hx into lx is equal to product of two polynomials, right? Like you can see here. This is the last point. This is the whole explanation of this. This is the whole explanation of this slide. You do not have to write it. Just write this example, write the HCF polynomial, write the LCM polynomial, and just write this last statement. That is it. Nothing more is required. Anyway, you are going to get these notes. Right? Right? Done. Can somebody check IOQM result has come or not? Like this learner is claiming. This is also homework. All these are homework, right? This is very simple. So like if you see it, just club A here, club B here, right? So I'm not going to waste your time with these problems, right? This is clubbing and factorizing. Right? I told you, some of the learners like to by splitting the middle term. Yes, this is perfect. Now this is something new. Let's see if you can factorize the irrational things. See, like Arindam is like me. Arindam English is of the same level as me. He used came with not. Not come should have been there, but he wrote not came. Getting my point? So his intent is correct, just like me. X square plus 4 root 2x plus 6. Now see like it is very easy to see 6 as 3 into 2. But this is very difficult to split this 2 into root 2 and root 2. Now what is the addition of these two? Is it 4 root 2? So this is the ninja technique. If you have a monic polynomial here also, just write these two in addition. This is your answer. This is your answer. This is your answer. X plus root 2, not x plus root 3 into root 2 plus 1. No, this is the answer. X plus 3 root 2 into x plus root 2. Right. Perfect. Let's move on to the next one. Let's solve this. Algebraic expression is sum or difference of two cubes. Now this is interesting. Let's solve it. Let's solve it. This is very interesting. You need to take something common. So this is part of algebra. Whatever you take common, you take common. Take HCF. Where? Take 2b common. Okay, my lord, I will take 2b common. See, I am doing as instructed. So I have 8a cube minus 125b cube. Now, as this is the preliminary lecture, you can see factorization of algebraic expression as the sum of difference of two cubes. I have given you the hint. I have given you the hint. Now, this is perfect cube. This is perfect cube. So, I have 2b here. 8a cube minus this. So 2a minus 5b. What formula I am using? Let me write it here. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Got it? 4a square plus 10ab plus 25b square. Somebody told me that the teaching in English is just like writing with left hand. Now for me, I already have a practice of writing with left hand. So this is going to be challenging, but we will do it. Sir, is content of this series and your course which you are premiering are the content same? Which course should I follow, sir? See, like if you are comfortable only in English, then this is the only course you can follow. Perfect. Right? Now, this is mother of all identities. I like this. I call it mother of all identities. Take, right? So see, like you take MOTH here, R from this, A from this, Mothra. Have you heard this word Mothra somewhere? Have you heard this word Mothra somewhere? So, if you have seen Godzilla versus Kong, Mothra is the mother of all titans. So that is why these are related. It's just a poor joke. So now I have 2 root 2a, root 2a whole cube here, 2b whole cube here, minus c whole cube here, and then 3 into root 2a. I'm just going to write it like this and then I will leave it. Minus 3c, 3c. This is minus here. So this is a cube plus b cube plus c cube minus 3abc, right? Right? Now, there is a very straight, so like this is, see, like this is the theorem. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Now, there are certain conclusions with this. If a plus b plus c is equal to 0, it implies a cube plus b cube plus c cube is equal to 3abc. This is one. This is one of the conclusion, right? Second conclusion, a square plus b square plus c square minus ab. You need to write this is equal to half of a minus b square plus b minus c square. This formulation is very important. If you remember, sum of perfect squares. This came in IOQM 2024 as well. This was the direct question. Now, as this can be represented as sum of perfect squares, this will always be greater than 0, and that is why we have this result. This is a very important result. For IOQM, this is going to be a very, very important result. Please write it down. Please write it down. Right? Right? Yes, triangle that side one, yes. Right? So here I can see a plus b plus c is 0. So this is equal to 3 times x minus y, y minus z, z minus x. Direct conclusion. Direct conclusion. And also one more conclusion. If I have this, if the equality holds, then a equal to B equal to C. Okay. Okay. Can you please write it down, guys? Are you enjoying it? Are you enjoying it or not? You are enjoying it or not? If you are seeing this lecture as a recorded lecture, please leave a comment right now. Please leave a comment right now so that I can understand that you are actually seeing my lectures, and also put the timestamp so that I can see it. Okay. This, this we have already done. This is very trivial. This is also in homework, right? This is homework. You just have to factorize and find the LCM HCF as per our definition. This is the product property. Yeah, this is something very interesting. No, this is not interesting actually. Or is it? Factorize 8p cube. There will be a p here also, right? There will be p here also, right? So this is very simple, right? 2p whole cube plus minus 1 whole cube plus minus m whole cube, right? Minus 3 into 2p minus 1 minus. I think this explains everything. So anyway, I am just going to write down the expression because we have not factorized completely anything. So a plus b plus c, which means this: a square plus b square plus c square minus ab minus bc minus ca, right? This is going to be the expression. The reason why I am not letting you do it, because these are very simple problems, right? I have given time to you, right? Right? This is very trivial problem. Right? This we have already done. Oh, nice. How do you factorize this? How do you factorize this? How do you factorize this? Now, this is another factorization technique which you need to understand. I am going to solve it using, and then I will give you another problem as homework, right? So, this is a symmetric expression. What do I call it? Symmetric expression, right? And homogeneous as well. Homogeneous expression, right? Please see this. Please try and understand this thing. Every term is of 5 degree here. Degree 5. Every term is of degree 5. This is one. Second, if you see, after b square minus c square minus a square is coming, a square minus c square coming, a cube, b cube, c cube. So there is some symmetry or cycle to it, right? So this is also written in my book. By the way, you can see my book for this, right? So now what I am going to write it. So this is advanced application of factor theorem. This is advanced application of factor theorem. Now please see it. Please see it. Now I can say, if I put a is equal to b, then I am putting a equal to b. This becomes like this. This is already like this. A is equal to b, and this becomes 0. Can you see that this is also becoming 0? Now just go back to the factor theorem. If a equal to b is making this expression 0, this means a minus b divides f a b c. And since it is a symmetric expression, by symmetry, b minus c, c minus a also divides a minus b minus c. Now consider this as a degree 5 polynomial. If this is a degree 5 polynomial, you have 1 degree here, you have 1 degree here, you have 1 degree here. So your remaining factor will be a quadratic polynomial in ABC, and it has to be symmetric also. So there are only two types of symmetric quadratic polynomial. One is this and one is this. Symmetry means if you exchange A and B, you will get the same expression, right? 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 A minus B, B minus C, C minus A, and then M into A square minus B. Now, M is definitely 0. M is definitely 0. Why I am saying M is definitely 0? See, if how do you multiply? If you take A from here, B from here, and minus A from here, you will get minus A square B. And when this minus A square B gets multiplied with minus A square, you will get this, right? And there is no way to negate this term, and there is no such term here. So this term should not arise in the first place. This means M is equal to 0. This means M is equal to 0. And this leaves you with, and then N will come out to be minus 1. So your factorization will be. So after this, you just need to match the coefficients. After this, you just need to match the coefficients. You can read this particular part. This is very simple, guys. Do not consider it as very difficult. This is not difficult at all. It is just matter of practice. You may have seen it for the first time. That is why it is striking you as a very difficult concept, but it is not difficult. Okay, got it? Got it, guys? Minus A minus B, B minus C, C minus A into A plus B, AB plus B, C plus C. Can you please write down done here? This is my high recommendation that you see this part again and again if you do not get it. Why I am saying this as a symmetric expression, homogeneous expression? Please see this. We will be doing algebraic identities in this lecture. So see, like basically algebraic identities are used to factorize, right, expressions. So what do I mean by factorization, right? Let's talk about factorization. Very simple thing, right? Basically, when you have a whole and you factorize it as much as possible, right? You do not write 1 here, right? This is the smallest possible factorization, right? And we stop in numbers, we stop when there is a prime number, right? In numbers, we stop when there is a prime number. So we are stuck at prime number, right? You do not write it as like this, right? Root 2 into root 2 into root 2 into root 2 into 3, right? You stop here. So basically, at a basic level, algebraic identities will be used to factorize the expressions till the coefficients are rational. For example, you must have seen here that a square minus b square is a plus b. Have you studied this? Have you studied this? Can you please say yes? Have you studied this? A square minus b square is a plus b into a minus b. Have you studied it? Have you seen this? Now, can I say that a plus b is a plus b? This a minus b is root a minus root b times root a plus root b. Now again, I can factorize it like this. So there is no end to it, right? There is no end to it. So that is why we restrict our discussion to rational coefficients. Please write this assumption. Can you please write this assumption? Can you please write this assumption? We will restrict our discussion to factorization till rational coefficients. Can you please write it? Can you please write it, guys?
Got it? Got it? I'll keep my mobile here so that I can see your chats. But, okay, now I can see your chats. Okay, got it? So first of all, like in the first assignment, we will try to understand homogeneous expressions, right? Homogeneous expressions, right? Homogeneous expressions, right? So we will start where we ended our last lecture. So first of all is two variable, right? So f of a comma b, right? Then a naught a to the power n, a1 a to the power n minus 1 b plus a2 a to the power n minus 2 b square dot 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 an b to the power n. You can see here that this index and power of b are same. If it is 1 here, it is 1 here. If it is 2 here, 2 here. So when we write these expressions, there is some pattern to it, right? There is some pattern to it. And this is the pattern which I am talking about. 0, and if you add these things, 0 plus n is n, 1 plus n minus 1 is n, 2 plus n minus 2 is 1, n. Similarly, this is the defining feature. The sum of degree of each variable, sum of exponent of each variable is n. N minus 1 plus 1 is n, n minus 2 plus 2 is n, and this is n, right? So in each term, degree of variables is same. Degree of variables is same. This is one defining feature. This is one defining feature, right? This is one defining feature. Yes, yes. As today you have to manage, right? There is a heavy glare on the screen, but I think you will manage, right? It is not that much. So like I am also today, you know, it is 2nd of October, right? Gandhi Jayanti, the offices were closed, so I had to take this lecture from my home. The studio is not up to the mark, but still I did not want to like cancel this lecture. So that is why we are taking this lecture on this screen. Okay. Perfect. Perfect. And anyway, right, the knowledge takes precedence than everything, right? These are just mediums and it's not that much of a deal breaker, right? Perfect. So degree, got it? This is one. So like we'll just write the example. So 2 degree, if I talk about 2 degree, this is a 2 degree expression. If I talk about 3 degree expression, right? This is a 3 degree expression. Getting my point? Getting my point? And there is a very important concept. Homogeneous expression of degree m into homogeneous expression of degree n is equal to homogeneous expression of degree m plus n. Right? It just works like a polynomial. It just works like a polynomial, right? It just works like a polynomial, right? How does polynomial work? If you see a cubic polynomial into a quadratic polynomial is a degree 5 polynomial. It's a degree 5 polynomial. So let's see the application of this, right? I take a 2 degree expression, I multiply it with a 3 degree expression. What do I get? Just simply multiply it. A to the power 5 plus a square b cube plus a cube b square plus b to the power 5. Can you see that this is a homogeneous expression of degree 2. This is homogeneous expression of degree 3. When you have multiplied it, you get homogeneous expression of degree 5. 2 plus 3 is 5. You can see here, sum of the variables, sum of the exponents of the variables is 5. 2 plus 3 is 5, 3 plus 2 is 5. Getting my point? So basically, when we study algebraic identities, it is the study of homogeneous expressions, right? Algebraic identities are essentially study of algebraic identity are essentially study of homogeneous expressions. Got it? Got it? Got it? IOQM result will come. This is live, Aditya Sharma, this is live. Every Wednesday, it is my promise that I'll be teaching in English and it will be live. IOQM result will come on 4th of October, right? It will come on 4th of October. Got it? Perfect. So, can you write DN in the chat? Can you write DN in the chat so that I can understand that you have studied it, you have written it, right? Now we'll go on to explore the algebraic identity. Now we will explore the algebraic identity. And I will give you a whole new perspective. I will give you a whole new perspective to look at the algebraic identity, right? I'll give you a whole new perspective. Okay? Okay? Amog, you is saying, thank you for everything. I scored 42 marks. Nice. Glad to hear. Glad to hear. And this time we will be doing for our English learners also. Learners who study IOQM in English, right? I do not mean in English subject, right? Somebody was saying, sir, now you are teaching English, sir, like, can I get good marks in my English literature or English grammar, right? Sir, can you give practice for reading comprehensions, right? So they were taking it very seriously. This, again, I'm telling you, the language is English, the content is mathematics, right? The content is mathematics. Okay? Okay? Yeah, HM plus N. Sorry. HM plus N. Thank you. This is going to be M plus N. Thank you. Yes, not M cross N, it is M plus N. Got it. Okay. So, now let me give you a whole new perspective, like I say. So, let's take 2-degree expressions. 2-degree expressions. Right? F a comma b, one example, a square plus 5ab plus 4b square. Now, there is a trick to master homogeneous expressions, right? There is a substitution. There is a substitution which you need to do. The substitution, it is auto focusing. Okay. Put A is equal to MB. Okay. How it will help you? Let's see. Everywhere you have to substitute it. MB comma B. Right? This becomes M square B square. This becomes 5M B square. Is it? Yes. And 4B square. Now, your B square is common and you get M square plus 5M plus 4. M square plus 5M plus 4. Isn't it? Isn't it, guys? Am I making sense? Am I making absolute sense here? Am I making absolute sense? Now, this we can factorize, right? This we can factorize. We have factorized it in the last class, if you remember. So, you have, I'm writing it directly. I'm writing it directly. Okay. I'm writing it directly. B square into m plus 1 into m plus 4. Okay. Now this is the funny part. Just multiply 1b in this and 1b in this bracket. So you get mb plus b, mb plus 4b. Now what was mb? mb was a, isn't it? And this is how you get your factorization. This is how you get your factorization. See, like initially you have to approach it using substitution. With enough practice, you can actually do splitting the middle term. Splitting the middle term can also work here. If you are thorough with your practice, you just split it like this, right? You just split it like this. Take a common here, a plus b plus 4b, a plus b. Take this a plus b common and you are left with a plus 4b. Got it? Am I making sense, guys? So these are the two methods. With practice, you can do it with this, but initially you have to substitute it like this. This is what I call the ultimate method. It will always work, right? It becomes easier after using this substitution. It becomes easier to solve. You will be like the expression will look familiar, right? In this method, you may make initial silly mistakes. There is a possibility. Okay, there is a possibility. Can I make a plus b whole square? I don't think you should do it, right? I don't think you should do it. Okay. No, don't do it. Perfect. So like, see, like what he's trying to do, but like this method is particular to this question. So we should not go forward in those methods which are particular to particular problems. What he's saying is that, sir, let's make like it like this, right? We have this. Okay. So we are left with 3ab plus 3b square. This is a plus b whole square because he remembers all the identities. This is 3b times a plus b. So this becomes a plus b times a plus 4b. But you need to understand this is particular to this method. This is particular to this method. We should refrain from using those methods which are particular to a particular problem. Okay? We should always try to see general methods. So can we do one more factorization? 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 Got it. Are we ready, guys? Are we ready? Are we ready? Got it. See, like like one student is saying, sir, why there is a difference between the sequencing of English lectures and English lectures. If you see my English lectures, it assumes that you know like 9th and 10th. I started with elementary counting techniques. Okay. Then I went on to do some basic but advanced things. In this course, I am considering that you have very little knowledge of mathematics, but you are sincere. So I am trying to teach each and everything. If you see, this is of very basic level. This is of very basic level, if you see, right? And we will add on to more lectures here. We will add on to more lectures here. Don't worry about it. Okay? Yes. So let's factorize. Fa comma b, a square minus 2ab minus 35b square. Right? Let's do it. Let's do it like this. Let's do it like this. Why it is auto focusing? I'm not sure. Acha, it is at auto kya? I made it manual now. Now it will not autofocus. Do this problem. Sir, how many of English lectures are there? So like, see, like in total, there are going to be close to 100 lectures. Close to 100 lectures. We are keeping the frequency low at this particular time, but we will increase it. In the month of November and December, I'll be taking more lectures of English courses, because in total, see, like my like initial IOQM course was of 109 lectures, right? So it is going to be like that only. See, like you complete the answer. You are saying a minus 7, a plus 5, right? It should not be like this. Now, I will do with both the methods. M square minus 2m minus 35 times b square, right? So this becomes m minus 7, m plus 5. I am writing, see, like when I teach you something, I tend to do it directly. I did not write the intermediate steps here. B square, right? Again, take 1b here and 1b here. Okay, so this becomes a minus 7b, a plus 5b, a plus 5b. Okay, am I making sense? Right, do not leave out the b. Like one student wrote a minus 7, a plus 5. No, you need to write the complete answer. A minus 7b, a plus 5b. Got it? Got it, guys. Perfecto. Chaliye. So another method is this. So see, like when I approach this problem, I just see the coefficients, right? Right? I will always see that this, see, like this, it is equivalent to this equation, right? So I would just factorize it like this, and instead of x, I'll just write a and 7b, right? I will just make certain adjustments. This is easier to see, okay? Basically the method 2, right? Now, the another method is this, completing the square. Here you can use this. This is very elegant. This is very elegant. You have a minus b square here, right? Minus 6b whole square. So you can write it as a plus b, a minus b. Okay. So you have a plus 5b here, a minus 7b here. This is the answer. Okay. Okay. Got it? Perfect. Perfect. Can you write DN in the chat? Can you write DN in the chat? Can you write DN in the chat? Can you write DN in the chat, guys? Can you write DN in the chat? Yes, it is a very interesting question. Sir, you have said that we can write A is equal to MB. But can we write B is equal to AM? Yes. Because if you see, A and B are two variables for us, and they are arising in a particular format. So my assumption is, whenever I see coefficient 1 here, I'll substitute that. This is my approach, right? Anyway, let's move on to the next problem. Question. This might be a tad bit difficult. 4a square minus 35ab minus 375b square. Right? Now this difficulty is, just a second. Oops. I think it is not visible, right? It is not visible. So I'll write a bit down. Four a square minus 35 ab minus 375 b square, right? Gupta ji ke shorts. Gupta ji ke shorts is saying you will be stopping this course in mid like all others you do. I have never stopped a course, first of all, right? I completed my IOQM course, the first which I started. After that, all the courses that I did, I started the course and I told my audience that this, like, the live lectures are for initial, right? So that you can get used to it. After that, you have to see the recordings. Anyway, IOQM can be done only through recording. I am 100% certain of it. These lectures are basic, that is why some of you may be able to get it in one attempt. Otherwise, all my lectures need rewatch. Need rewatch, for sure. My JEE rank was 42. My JEE rank was 42. One learner is asking. Sit wrong. When is your IOQM nights? I am not in IOQM nights course. I am only in Ramanujan course, right? I just took one orientation class there. I am not in IOQM nights course. Hi Siddharth, how are you? So Siddharth is a good student, right? He studies in ISI and he used to be my old student. He is one of those students, I think he studied with me for at least 4 to 5 years. Right, Siddharth? If you are in the chat, can you confirm? 28 good in Chandigarh. I think it is good. No, this is not the correct answer. This is not the correct answer. My physics used to be bad when I studied, but my version of bad is better than majority of students. Like, I did clear physics Olympiad stage 1. So Jogiram's like, these are edge cases. You are saying like you are mixing numbers and polynomials. You should not worry about these edge cases. Yes, Vedant Verma, you are correct. Vedant Verma, you are correct. So now in this thing, right, just put A is equal to MB. And then I am going to teach you something very amazing, right? So you will get B square 4M square minus 35M minus 375. See, like, now one way to go about it is just use quadratic formula. So if you use quadratic formula, it becomes this 35 plus minus 35 square is 1225. How do I know it? Let me tell you, right? 35 into 35. There's a technique to it, right? 5 5s are 25. You just add 1 here, it becomes 4. 4 times 3 is 12, right? So this is one way to go. This is, I don't know, like it is Vedic math or something, but this is how it goes. Minus 4 ABC. Minus 4 times A is 4, 375 minus 375. Okay, upon 2A. 2A is 8. M is 35 plus minus, I'll just make a box of it, under root of 1225 plus 6000 upon 8. So this becomes M 35 plus minus 7225 upon 8. Now square root of 7225 is 85. Okay, it is 85. So you have 35 plus minus 85 times 8. So this becomes 35 plus 85 is 120 by 8, comma 35 minus 85 is minus 50 by 8. So this is 15 and this is minus 25 by 4. Right? So what I am trying to say here is this becomes m minus 15. These are two roots based on quadratic formula. Now if you cross multiply and match the leading coefficient, you get this. But don't you think it requires a whole amazing level of arithmetic? Arithmetic means plus, minus, divide, multiply. It needs a lot of arithmetic. So what if I tell you an amazing method, amazing factorization method? So see, like if anything is factorizable using splitting the middle term, it can be done. It can be done. And majority of the problems are of splitting the middle term only. Because why would anyone, see, like if somebody is trying to check your good mathematics, why would they want you to apply a formula, right? They will check your brain, right? They will check your brain, isn't it? So let's apply brain. Let's apply brain. Let's apply brain. See, like Siddharth is saying this thing. Thank you, Siddharth. Siddharth, by the way, is a very, very amazing violinist. ठीक है? He play amazing violin. And I don't think there is any of my birthday in which I have not heard his violin. He always makes sure that he's sending me a recording of his violin. Got it? Perfect. So let's see what do we have here. Let's see what do we have here. Okay. So see, I had 4m square minus 35m minus 375. See, like I am very, very comfortable when the coefficient is 1, right? I am very, very comfortable when the coefficient is 1, isn't it? It's getting blur. Oh, it is perfect now. So there is some lighting issue. There is some lighting issue, I believe. Just a second. Yeah, it must be fine now. 4m square minus 35. So like I am very, very comfortable when my coefficient is 1. So what I will do, I'll just take 4 and multiply it here. Right? Obviously it is not okay, but I am doing it anyway. Now see this number. See, our deal was to split this in such a manner that the product becomes this. Okay, let's factorize it. 375, let's factorize 375. It is 25 times 15, right? Or 125 times 3. So 5 to the power 3 into 3 to the power 1. And you have 4 extra. Okay. Now see, like you are getting minus 35, right? You are getting minus 35 here. You are getting minus 35 here. So how do you get minus 35? There has to be some 0 here and some 5 here, right? That is how you get, right? So this means your 4 has to be together. Because if any of the power of 2 gets multiplied with 5, it makes a 0 at the end. So 4 has to be multiplied with 5. Then you are left with 5 cross 5 and then there is a 3. So this becomes 60, this becomes 25. Now this is brain, right? This is brain. Now we'll have to do a final adjustment also. M square minus 16m plus 25m minus 375 times 4. So you have m minus 60 here. You have m minus m plus 25 here. Got it? Got it? But you did something, you actually did a mistake here by multiplying 4. You cannot multiply 4 here, right? So this is the final adjustment. You just have to divide by the same number, right? So if it becomes this, and then take LCM. You get the final answer. This is a factorization technique. This is one of the factorization technique which we use when we have like some coefficient of m square. This is the factorization technique which we use. Okay? Okay? Am I making sense? Yes, yes, yes. So it was blurring in between, but I think you have adjusted to it. I think you have adjusted to it. Okay? Should I solve your book now? Yes, you can start my book. If any one of you are if any one of you are serious aspirants, you should definitely start solving my books. Okay, perfect. Right? I hope you have understood it. This is a very important method, by the way. Guys, this is very, very important method. Okay, now that you have factorized it, let's see some algebraic identities. Now we are on our second. So we will remember certain algebraic identities. Okay, we will remember some of the algebraic identities now. Just a second here. Yes, now I don't think it will defocus. Now it will be stable, I believe. So, a plus b square is a square plus 2ab plus b square. If you replace b with minus b, then you will replace minus b everywhere. So, you get this. Okay? Okay? Then you have a square minus b square as a plus b times a minus b. I am writing the most important algebraic identities. I am writing the most important algebraic identities, right? I am writing the most important algebraic identities. I don't know why it's blurring like this. It never used to be like this. Anyway, we'll have to adjust to this lecture. A square minus b square. Okay. Then a cube plus b cube is a plus b, a square minus ab plus b square. 8 cube minus b cube is a minus b, a square plus ab. I am writing all the algebraic identities just for the sake of it, so that we have everything in our record. Okay, got it? A cube minus b cube. Then we have a plus b whole cube. So I want you to remember both types of it. So many of you must have seen this as the expression, but I want you to remember this as well. A cube in decreasing powers of a. See, I always write these expressions in decreasing power of a and increasing power of b. It helps me a lot. Right? I'm just replacing b with minus b. So here it becomes alternate plus minus. Right? So these are the identities which you have to remember for two variables. These are two variable identities. Two variable identities. Now I am going to introduce one more, which is a star. A to the power 4 plus 4b to the power 4. It is a square plus 2ab plus 2b square a square minus 2ab plus 2b square. Can somebody prove it for me? Can somebody prove it for me? This is called Sophie Germain. This is called Sophie Germain, one of the very few things which are named after women in mathematics, right? Right, using completing the square. Perfect. So how do we solve it? How do we solve it? I will just write this. This is a very important technique also. See, this is a square whole square. This is 2b square whole square. If I were to complete this perfect square, I would just multiply it with 2ab, right? A square plus, p square plus q square plus 2pq. So this is it. But in mathematics, you cannot add randomly. If you are adding something, you have to subtract this also. So you have a square plus 2b square whole square minus 2ab whole square. Now, some perfect square minus other perfect square. I'll use this identity. This plus this. So this expression plus this, but I will obviously write it in decreasing power of b. Okay. Some people also remember it like this. Some people also remember it like this. Got it, guys? Got it, guys? Got it, guys? This is very important technique. So I will not bore you with these problems, right? These are assumed that you know it. We will be doing problems of this or some of these, right? We will do these things. Okay. Got it? Got it? Please write done. Please write done. If you have written all these identities, please write DN. Please write DN. Why only a small number of students are aware of RMO, such Olympiads and beauty of mathematics? Why everyone? See, like this is one such initiative which I am taking, right? I am teaching in English because IOQM English courses are not available in its complete entirety, right? In its complete entirety, these courses are not available. I'm 100% sure once these courses are 1-2 months old, we will have thousands of students watching these. I'm pretty sure of it because they are in English. My old lectures, some of the lectures are like have views in lakhs, right? It is only because it is only because Hindi speaking students give IOQM more than like other students, and it is also awareness issue. It is also awareness issue, right? Perfect. So let's solve this one. Let's solve this one. Okay. Let's try to solve this problem. Factorize x to the power 4 plus x square y square plus y to the power 4. Let's solve it. Let's solve it. It is not directly Sophie Germain, but it has something to do with it. what do you get? X by y equal to t. Perfect. Perfect. See, like now I'm not going to say, I know this is a homogeneous expression of degree 4. I'm not going to bore you with x equal to my or something, right? We are not going to do it. We will simply see it as an expression which needs to be factorized. Now I will complete the square. So if I complete the square, I need this, but I had only 1x square y square, right? So this gives me x square y square whole square minus xy whole square. So this is the one. This is how you write it. Got it? Got it? Perfect. So let's factorize one more. Let's factorize one more expression. Okay. X to the power 4 plus 6x square plus 25. Let's factorize this. 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 IOQM results will be available on 4th of October. On 4th of October. They will be available on 4th of October. Also useful for AMC, yes. Good, very good, very good. Now you have understood it. Sir, you need to add 4x square here so that it becomes x square plus 5 whole square, and then you have to subtract 4x square, which means 2x whole square. Now sir, we can write it directly as this. Perfect, perfect guys, perfect. Perfect. Okay. Done? Yes, 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 yes. Perfect. Now this is amazing, this is amazing. We like it, we like it, we like it, we like it. Okay. Now let's introduce some irrational things to it. Irrational things to it, right? Let's factorize and simplify. I would write simplify. Simplify n plus 1 to the power 3 by 2 minus n to the power 3 by 2 upon just a second guys, 2n plus 1 plus under root of n square plus n. Right? Let's see how do we approach it. Let's see how do we approach this type of problem. There is an interesting way to go about it. There is an interesting way to go about it, for sure. Let's see if any one of you can get this problem. If any one of you can get this problem, let's see. How many super students do we have among ourselves? Let's see. How many super students? Yes, very good, Keshav. So Keshav has understood this thing. Sir, first of all, we do not like, sir, these square roots. Right, sir? So what we will do, sir, first of all, we will start on a new page because it can be a bit long. So sir, this is what we have, right? This is what we have. Okay. So sir, we have square root of n plus 1. Let me write it as x. And square root of n, let me write it as y. So sir, my x square minus y square is 1. Okay, sir. Okay. But here we have x cube minus y cube. Okay. Now let's talk about denominator. Denominator is n plus 1 plus under root of n times n plus 1. So this is y square, this is x square, and this is xy. Once you write it like this, it becomes very, very easy. It becomes very, very easy because now this is a factorization. Your this factor will get cancelled. You have only x minus y. What is x minus y? Square root of n plus 1 minus square root of n. Oh, this was interesting. Yes. What it was? X minus y. What was it? Square root of n plus 1 minus square root of n. Got it? Got it. October 4th, like I said. Done? Perfect. So this is one such expression. This is one such expression, right? This is one such expression. It is very, very important. Like this is a tool to something very big, right? It is something known as telescopic series, which you will study in sequence and series. It is one of the most prominent Olympiad problem, but asked in usually objective exams. So IOQM, like IOQM or AIME or AMC, right? Telescopic series are integral part of that. Now, let's talk about three variables identity. So there are very few of it which we need to remember. A plus B plus C square. This is sigma A square. Now I am introducing a new terminology. Sigma A square means, so since you have three variables here, sigma A square would mean A square plus B square plus C square. This is the terminology which I am introducing, right? Sigma AB means AB plus BC plus CA. whatever combination of two variables you can make, you just write here. Okay. A cube plus B cube plus C cube minus 3ABC. Right? This is sigma A square minus sigma AB. This actually, I like this because it is very short. It saves our ink, right? Although this is a digital ink, but you must be writing with a ink which is tangible, right? Maybe some ballpoint pen or something of that sort, right? So that is the thing. Why it is happening like this, I'm not sure. Focus assist. This camera needs to change, I think. We need to change this camera. I'll try to do something. I will try to do something. Okay. Do you get it? So like I call it mother of all identities. This is a very important identity because, see, right, you need to remember this expression which we have here, right? This is actually equal to half of A minus B square. We got one question from this, right? If you remember, we got some question from it. A minus B square plus B minus C square plus C minus A square. Okay. You just multiply it by 2 and then it gets verified. There is no nothing. Sir, your favorite math book? So I have written quite a few of them. So I have written 19 books in mathematics. So they are my favorite. Right? So A cube plus B cube plus C cube equal to 3ABC. So we have two conclusions, either A plus B plus C is equal to 0 or A equal to B equal to C equal to either this or this, right? We also have A square plus B square plus C square equal to AB plus BC plus CA implies A equal to B equal to C. Why this? Why this? Because this essentially gives this. Now how can sum of perfect squares be 0? Right? Sum of perfect squares can be 0 because this is greater than equal to 0, this is greater than equal to 0, this is greater than equal to 0, isn't it? This is greater than equal to 0, this is greater than equal to 0, this is greater than equal to 0. So how come we have this? Okay. So that is why we have A minus B equal to 0, B minus C equal to 0, C minus A equal to 0, which essentially means this, right? 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 Okay. Right? Did we get it? Are we getting it? Perfect. Okay. Perfect. Yes. So this is another identity. This is another identity. Okay. So let's try to apply AQ plus BQ plus CQ minus 3ABC. Right? Question. Factorize AQ plus BQ plus 6AB minus 8. Let's try to factorize it. Yeah, sure. Keshav, please send it. You know, right? You know, this is how you can send DM to me at the rate Prashant 42 Jain. Okay, send it to me. Do we have an answer? Do we have an answer to this? Do we have an answer to this? Right. So we will make AQ plus BQ. Now we have minus 2 whole cube, right? And then you need to write it like this. Okay. Minus 3 times A, B and minus 2. That is how you get 6AB. So there will be a problem of plus minus here, believe me. Okay. So AQ, so this becomes A plus B minus 2, then A square plus B square plus 4 minus AB, but after that A multiplied by minus 2 is minus 2A, plus 2A plus 2B. So this is the factorization. This is the factorization. This is the factorization. Okay. Okay, guys. Do it. Do it, please. Please do it. Right? Please do it. I am making one question for you all. Three, 18. Okay, so let's solve this one. This is GOAT problem. If any one of you get it, you are GOAT. This is GOAT problem, right? 27 a to the power 6 plus 10 a cube plus 1. Okay, this you need to have. This is a very difficult factorization. Like, I consider this as very, very difficult factorization. Very difficult factorization. let's see, a cube plus b cube minus 1. You give me the answer. You give me the answer of this. If you do it, you literally have very good mathematics, because this is a problem which is made by me just now. All the other problems you can see in one of these textbooks. This is the problem made just by me. It is PJ exclusive. It is PJ exclusive. You solve it and you are good. Try. A cube equal to x will not give you anything. It will not give you anything. You will try to make it into a quadratic. A cube equal to t will give you this 27t square plus 10t plus 1. But it is not factorizable. It is not factorizable. You need to use cube. And that is why I call it mother of all identities. That is why I call it mother of all identities. That is.
Yes, so I hope you have tried it enough. So I have written the solution. Meanwhile, there was some disturbance, and obviously the video quality has improved a lot now. So I have written the solution here. First of all, it is a PJ exclusive. Like I said, 27a to the power 6 plus 10 a cube plus 1. Now one way to look at it is like if you assume a cube to be t, then you make a quadratic, but it is not factorizable at all. You have seen that it is not factorizable. So we will use the mother of all identities, that is p cube plus q cube plus r cube minus 3pqr. But the problem here is that you have 3 terms here and it requires 4 terms, which means 2 terms are actually of same degree and they are getting added and subtracted. So our hunch is that it is this one, because this is the only term which is not a perfect cube, right? So what I have written here, this is a perfect cube, this is a perfect cube. I have added one perfect cube here, and then I have written minus 3a square from here, 1 from here and ap from here. So what is the coefficient of a cube now? A cube is p cube minus 9p, right? You can see p cube is coming from here, minus 3p is minus 9p is coming from here. Now what do we have here? P cube minus 9p is equal to 10. So I have solved it here for you. P cube minus 9p equal to 10. P is equal to minus 2 is one solution. In the last lecture, we have seen this thing that such cubic equations can be solved using hit and trial. But obviously, while using hit and trial, we will see that the things which are being hit are divisors of this, right? Rational root theorem, integer root theorem, which we discussed in the previous lecture. So I put p equal to minus 2, it is hitting, and hence p is equal to minus 2. So our final thing is this, right? Now when I factorize it, a cube, p cube plus q cube plus r cube minus 3pqr, p plus q plus r, p square plus q square plus r square minus pq minus qr minus pr, okay? And then you can see 4a square minus 3 square, you can add these numbers because they are the coefficient of same degree expression, that is a square, and this is your factorization. Now the problem here is that such a beautiful expression was there, only 3 terms, and now you are factorizing it and you are getting such a complicated expression. But that is the beauty of algebraic identities. It is a black box. When you open it, then only you can see if the expression is good or bad, right? So we have factorized it using a cube plus b cube plus c cube minus 3pqr. This identity is really, really beautiful. And the reason why I call mother of all identities, because there are lot of problems based on this identity which are made which require a lot more thinking than usual problems. This is one. And second, it is not always very easy to see that this identity will be applied. See, like just think of it. You are watching algebraic identity lecture. You have just done a cube plus b cube plus c cube minus 3abc, and after that you are able to think that okay sir, we need to use this identity. But if this question comes directly in your exam, then you will not be able to think it properly. That is my assumption, right? So you can note it down and write done when it is done in your notebook. This is a good problem, like I said, PJ exclusive. I made this problem just now, and this problem is very, very amazing. Okay. Now let's go on to the next problem. So this was actually this was one such problem. In fact, you must not have written it, but it was one such problem which I think is very relevant, but it cannot be asked directly in Olympiad. So what kind of problem can be asked in Olympiad? I told you completing the square is a very important tool. So we are going to do a very basic problem next, which is asked multiple times in IOQM using different types. Okay, so let's do this problem, and I'm going to make it simple for you, right? Given AB belongs to natural number, and a square plus b square plus 4 is equal to AB plus 2A plus 2B plus 3. See, I have written 4 here and I have written 3 here. I could have simply written it as 1, but I did not do it. It is done just to make it simple for you, right? Find number of ordered A comma B satisfying above expressions, right? Above expression, right? This is the problem which needs to be solved. I am going to give you 2-minute head start, and then we will see the formal solution of this, right? Let me give you 2 minutes of head start. Okay, let me give you 2 minutes of head start. Do it now. Last 50 seconds. Okay guys, let's see now. Perfect. So see, now the identity here is very simple. If you write it like this, 4 is 2 square minus AB minus 2A minus 2B equal to 3. So you know that this becomes half of A minus B square plus A minus 2 square plus B minus 2 square, right, equals 3. So A minus B square plus A minus 2 square plus B minus 2 square equals 6. So this is what you have got. Now just imagine just imagine if it would have been like this. If it would have been like this, then very easy solution was A equals B equals C equals 0. But it is coming out to be equal to 6. This is where we use this condition. A and B are natural numbers. A and B are natural numbers, which means these are perfect squares. 3 perfect squares adding up to 6. Think, 3 perfect squares adding to 6. 0, 0, 4, no. 0, 2, 4, no. 2 is not a perfect square. 2, 2, 2, no. Not 2 is not a perfect square. 1, 1 and 4. 3 perfect squares adding up to 6. 4, 1, 1, 1, 4, 1, 1, 1, 4. This is how you solve it. This is the thought process. This is the thought process. In algebra, this will be the template to solve everything. You get to the expression which you need to solve. This is the expression which you need to solve. And then think. This is manipulation. And then some manual work now. Let's do the final working, right? So like I said, we have reached up to this level, right? This is not usable. 411, 144, I have solved it for you so that you can simply note it down. In the first situation, A minus B whole square equal to 4. The solution comes out to be A minus B equal to plus minus 2. Now we are not going to solve this. The second one is beautiful. A minus 2 whole square is 1, which means A minus 2 is plus minus 1. This gives A equals plus 1 and 3. B minus 2 whole square is plus minus 1, means B is also equal to 1 and 3. Now, in all these solutions, you have to make sure that A minus B should give us plus minus 2. So, these are the two solutions from first condition. A equals 1, B equals 3, because A minus B is coming out to be minus 2. A3, B equal to 1, A minus B coming out to be 2. In the second, 1, 4, 1, A minus B is plus minus 1, A minus 2 is plus minus 2. Now, when we solve this, you are getting A equals 4 and A equals 0. Since A was natural number, 0 is automatically rejected, you get A equals 4. B minus 2 equal to plus minus 1, B equals 3 and 1. Now, since A was uniquely 4, you have to make sure that A minus B is plus minus 1. So, you can only select B to be 3, because if you select B equals 1, A minus B comes out to be 3, which is not possible. So, A minus B 1, B equals 3, A equals 4, B equals 3. So, in this condition, A equals 4, B equals 3. Obviously, if you see this initial expression, A and B are symmetric. So, which means if you exchange A and B, you do not get any different equation, which essentially implies that if A equals 4, B equals 3 is one solution, then automatically A equals 3, B equals 4 is another solution. So, in total, you have 4 solutions and it is a 3 marker, right? In IOQM 2024, this type of expression came with geometry, with geometrical touch. In that problem, we had to apply triangle inequality. Right? And this is the way to approach such a problem. It can be asked in the future also, because it has already been asked 3-4 times. And I am of the opinion that this is something which is very, very important, right? You should remember it to the core. Okay. So, I hope guys you liked it. If you do like it, please do share it. This is part of IOQM English course, and we are committed to completing this course for our new audience, which is English audience. This course is primarily for those students who cannot understand Hindi lectures, and in my opinion, language should not be the barrier to for beautiful mathematics, right? Perfect. So, I hope you liked it. If you do like it, please do share it. Let's crack it. So, guys, today's lecture is for solving polynomial equations. So, I want to mention some things here. Polynomial equations, right? So, basically, we know how to solve a linear equation. So, if there is a linear equation and we are given here that A is not equal to 0, it implies x is equal to minus b upon a, right? This is called solution or root of the equation, right? This is the basic definition. So we have a very complicated definition of root and solution which you are going to study in your class 11th. But for now we are using a very simplified version of it, right? Because see, like, solution cannot be imaginary, for example, but root can be imaginary. So there are many conditions which come along with these definitions, but we are going to skip it for now. For now we are going to assume that all that we are solving, whatever that we are solving is actually real. We are going to assume this thing. So this is first part. Second is quadratic, right? Quadratic. Ax square plus bx plus c is equal to 0. Here also we are going to assume that a is not equal to 0. Now what we are going to do? We are going to multiply it with 4a. If I multiply the whole equation with 4a, I am going to get this, right? Now this is 2ax whole square plus 2 times 2ax into b. Now completing the perfect square is a very, very important strategy. Now for that we have added b square here. So I'll add b square here. 4ac, I will just put it here. This is 2ax plus b whole square is equal to b square minus 4ac. Now I am going to put b square minus 4ac is equal to d square, right? Is equal to, yes, d square. In fact, let me put it as d. Okay. Let me put it as d, right? So, in fact, let's put it as root d square. Okay. So we have 2ax plus b is equal to plus minus root d. So x is equal to minus b plus minus root d upon 2. So see, if the equations are linear and quadratic, if the polynomial is linear, the polynomial is quadratic, we have a definite way of solving the equation. But if we have cubic equations, degree 4 equation, we do not have such solutions. So first of all, what we are going to do, we are going to solve these two types of equation, and then we will focus on cubic and higher order polynomial equations. So see, like, very simple definition of polynomial equation is polynomial is equal to 0. Okay. Okay. Perfect. So let's go and solve this one. Let's solve this one, and then we will again come back to it. Just solve this. These are the two quadratic equations which you need to solve. Let's solve them. X square minus 6 root x. This is x, guys, right? This is x. This is x, guys, not 6 root x, 6x. Okay, right? And I am going to tell you about imaginary roots, real roots, right? I am going to tell you about these things. Can I qualify with 12 marks from Kashmir? Yes, you will definitely qualify from Kashmir. For sure you will qualify. Okay. See, you can directly put formula here. X is equal to 6 minus b plus minus under root of 6 square is 36 minus 8 upon 2, 3 plus minus root 7. But I do not do it like this. I will always try to complete the perfect square. See, I have this. Now to complete the perfect square, I just have to add 7 here. So I get x minus 3 whole square is equal to 7, which means x is equal to 3 plus minus root 7. Now solving quadratic equation is a skill. This skill is to be implemented very, very fast. Here finding the correct answer will not be an issue. The issue will be how fast you can come to the answer. This is going to be the real issue. This is going to be the real issue. Now in this equation, you can see x square minus x plus 1 is equal to 0, right? This is where we are having one problem. If you see D, it is equal to b square minus 4ac, we have minus 3. This is the problem here. So whenever whenever we have such type of scenarios, we will write a square root of minus 3 as root 3 into square root of minus 1, and this we will replace with this. So basically I square is equal to minus 1. This introduces the imaginary numbers. Just consider it as a number. For IOQM purposes, we have to consider I as a number. If we square this number, we get minus 1. That is it. Nothing more, nothing less. So we have x is equal to 1 plus minus root 3i by 2. Can I say this, guys? Can I say this? Can you please confirm it? Can you please confirm it? Done. Either both are quadratics or none. Both are quadratics, right? This is one. Okay. Now let's solve them. Determine whether the given values are solution of the given equation or not. Just check. Just check. So if something is solution, you put it, and if LHS is equal to RHS, then you have the solution. Just check it. Just check it. See, like these are basic lectures. I told you these are basic lectures. By the end of November, I think we will be done with the basic lectures. After that, we can you can assume that there will be increase in level. But in last lecture, there were 2-3 problems which really puzzled you. IOQM is not about solving only difficult problems. IOQM is also about building the basics from the scratch. So what I would do, I would simply factorize it. Right? Let me factorize it. 3x square plus 2x minus 1. I actually, we have already discussed this using splitting the middle term in my previous lecture. So x is equal to minus 1 and 1 by 3. This shows that 1 by 3 is a solution. Now let's talk about this. We have also factorized it actually. Now this is a square x square minus 3abx plus 2b square. So we have ax minus b, ax minus 2b. Remember homogeneous expressions? What I would do, I would divide it by b square, and then I will put a by b as t. That is when I will get the complete answer. So we have x is equal to b by a and 2b by a. This means this is a root, this is not a root, or you can say solution also, right? And there is a theorem called fundamental theorem of algebra, which says that degree n polynomial equation has n roots. This theorem enables us to stop here only. Just imagine, like we have two solutions here. Now one would say Sir, what is the problem here? There are two solutions, right? Can we have more solutions? Now, just imagine somebody says x plus 1 is equal to 0. This gives x equal to minus 1. This is one solution. What if I say that this is, and then I do more, like I apply more mathematics and I get to more solutions, right? So, there has to be one theorem which is there to stop me from doing all these things. So, this is one such theorem which says that if you have a polynomial of degree n, after solving you can get n roots only. Getting my point? N roots only. Got it? Got it? Am I making sense, guys? If I am making sense, please write DN. Please write DN in the chat. Please write DN in the chat so that we can proceed further. Sir, if I buy an Academy's JEE subscription, will I be able to access your paid IOQM lectures? See, like the problem is that the JEE subscription, all the lectures of 3 years old, like 3-year-old or even older lectures, they have been removed from the platform because like that's too much data to store, right? So, if you want to access my lectures, you can purchase Olympiad subscription, right? And like I think you should all go for Ramanujan course. Ramanujan course is a perfect course. Okay. When will geometry start? It will take some time. It will take some time. Now, solve this. Determine the whether this is a homework. This is homework. You can do it as a homework. Now, just a second. This is homework. Yes. Find the value of k for which this equation, right? Just solve it now. Please solve it. Find the values of k. This is another way to ask this question. I am keeping this lecture very, very basic so that when we have real problems, then we are able to solve them. Because see, like what will happen in IOQM, this advanced part will be different. But eventually, you will find a equation, you will find a polynomial equation here. I'll give you the example of this model. What I'm trying to say is, there will be an advanced problem here. You do some manipulation, but at the end, you will reach a quadratic equation which is to be solved. And for that, we are doing it. For that, we are doing it. If x equal to 1 is a solution, then we have 1 plus k plus 3 is equal to 0, which means k is equal to minus 4. Second, see like this is a number sense. When I see minus a, like a plus b here, I just simply see it like this, right? This is how I am conditioned to do. Now, this is x square minus a plus bx plus ab. Comparing the coefficients, we have k is equal to ab. Getting my point? Am I making absolute sense? Am I making absolute sense? Right? 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 Now, there are certain equations which are called equations reducible to quadratic. Reducible to quadratic, which are not quadratic in the mother equation, but they can be formed quadratic by using certain mathematical operations. So, we are going to deal with those problems first, but for that to happen, you need to say done here. If you have understood this typology, you need to write DN in the chat. Just write DN in the chat. Just write DN in the chat. Let me open the chats here also. I'm not being able to see your chats here. Oops. oops, perfect. Now I can see your chats. Now I can see your chats. Yes. With 9 marks you cannot be selected. 10 marks is minimum eligibility. Right? 10 marks is minimum eligibility. You will not be able to get selected. Perfect. Right? Now let's solve. This is another thing. So I have written many problems here. Now solve this one using the factorization method. Factorization means splitting the middle term, right? So you need to identify that this is a perfect square, right? And then solve it. Yes. So this is x minus a whole square equals b square, which means x minus a is equals plus minus b. So which means x is equal to plus a plus minus b. So see, like, you will be able to see the roots just by looking at the equation, but it requires a lot of practice. You will need to solve at least 100 to 200 problems of quadratic, and that too without using any pen. Getting my point? So this is the answer. So I have added many simple problems here, right, which can be solved using factorizations or whatever, right? But at the end there are some difficult problems also. So you see, like, why I have added these problems here, so that when you download these notes, you need to solve them without using pen. That is the challenge. If you use pen, then it is of no use, right? Has no real roots, right? Just a second. Sridharacharya formula. We have already done this. Again done this. Solve it. Solve this quadratic equation. This is a real tester. No, Jogi Ram, you have to reduce it. $41 to get enough. Yes, I think you are through. Sorry, let us solve it first. Now the way to look at it is 9x square minus 9 times a plus bx. Now it will be very difficult to solve using quadratic formula. Quadratic formula will also be very difficult to solve here. Now, but what we can see here, this is a plus 2b into 2a plus b, right? This is what I mean when I say you should have understanding of coefficients, right? See, like at the basic level, product of these two, right, is one thing, and then you have to split this sum in such a way that you get the product same. So you have a plus 2b here. Now see here what I am going to do here. Can I write it as a, like I am taking 3 inside and I am writing this as this. Okay. Can you see it? Can you see it here? Right? Now, I told you a simple ninja technique in the last class. Just multiply 9 here, right? And I'm writing it like this, right? Now you can see that sum of these two, like just when you multiply 3 here and 3 here, you can multiply it like this, right? Then the product of these two will be product of these two. This means I can simply write x is equal to 3 times a plus 2b as well as 3 times 2a plus b. But remember what we had done. When you multiply, when you are taking 9 from here and you are plugging 9 here, then you have to divide both the roots by 9. This is what we did in last lecture. If you did not see the last lecture, please do see it. Otherwise, you will not be able to understand it. Guys, this is not a Tom and Jerry show in which you can just come anytime and you get a laugh. It is a detective series. You have to watch from the starting to understand it. Yes, I'll see to it. I'll get it uploaded, guys. I'll get it uploaded. Done? Perfect. Now let's solve it. So this is what I was saying when I told you, pseudo quadratic equation. This is called pseudo quadratic equation. In pseudo quadratic equation, you factorize, right? But before factorizing, you make some substitution through which you get a quadratic, right? Through which you make a quadratic. Okay. Yes, NACJS, you see, like with Olympiad Gold subscription, you get NACJS also, right? You will get NACJS also. Okay. Now you have 81 times 9 to the power x minus 18 times 3 to the power x plus 1 is equal to 0. Now what I am going to do, I will just put 3 to the power x as t. This gives 9 to the power x as t square. So I have 81t square minus 18t plus 1 is equal to 0. This gives me 9t minus 1 whole square is equal to 0. And we did discuss about the perfect square things. If it is equal to 0, t is simply 1 by 9. Now what was t? It was 3 to the power x. What is 1 by 9? 3 to the power minus 2. This gives me x is equals minus 2. This is the only solution which I am going to get. This is the only solution which I am going to get. Right? Right? Am I making sense, guys? Rijula is saying, sir, cutoff in Kerala. Kerala cutoff will be very low. Guys, tomorrow I will declare the complete cutoffs. You don't have to worry about it. I will declare the complete cutoffs. Right? Okay, perfect. Now this is again a pseudo quadratic equation. Now the level is going to be further up. Now the level is going to be further up. Please solve it. Let's solve it, guys. Let's solve it. Now, you will find a problem here. You will find a problem here. First of all, see what is this? It is square root of 2 plus square root of 2 plus square root of 2. So, this clearly is greater than square root 2. You will have to remember this. Why? I'll tell you. Now, let this be x. Let this be x. Let this be x. Now, if this is x, what is this? This is also x, no? This is also x, right? Because this is a infinitely continuing series, I can say it. So, if this whole thing is x, then this is also x. It is just like, see, let's just imagine Pacific Ocean. Why I am saying Pacific Ocean? Because the name, Hindi name of Pacific is Prashant. That is, I am using the example of Pacific Ocean. Just imagine Pacific Ocean. Now, you take one bucket of water from it, right? After taking out one bucket of water, what is remaining? The remaining is still Pacific Ocean, isn't it? The remaining is still Pacific Ocean. So, what I am trying to say here is, from this infinite sum, if you remove this, this will also remain x. So, what is x? Root 2 plus x. Just square it. You will get this quadratic equation. Now, this is the problem here. You are saying that the answer is x is equal to 2 and minus 1. Now, what I am saying is, in the mother equation, we had this condition. What is the mother equation? The mother expression or equation is something which is given in the question, right? So, in the mother expression, we noted that this expression is greater than root 2. So, we have to reject this. We have to reject this solution. This is a very, very important point while solving the equation. When we square, which we have done in this step, when we square, which we have done in this step, we tend to get extra solutions. Please note it down. Please note it down. This is very important. This is very important. You tend to get extra solutions. So, x is equal to 2 and minus 1. This is rejected. X equal to 2 is the only solution. So, benchmark rule here is whenever you square, just check back in mother expression. Just check back in. Somebody say, sir didn't even hesitate to reject. Yes, we are fan of Samay Raina. Perfect. Got it. Now, let us move on to the next problem. Now, this is a degree 4, right? This is something called symmetric coefficient problem, and there is a hack to it. Symmetric coefficient, you have to write it symmetric coefficient. In this, what do we do? Step 1, divide by x square, and then put x plus 1 by x is equal to t. Again, a pseudo quadratic equation. It has to be a pseudo quadratic equation. Solve it. This is a very important typology. Done. So, what I am trying to say here is 2x square plus x minus 6 plus 1 by x plus 2 by x square, right? Symmetric coefficient means when you see it from here or you see it from here, you will find the same things. Now, can you see it? Can you see it like this? Now, when I am saying that put x plus 1 by x as t, you just square it. What do you get? You get x square plus 1 by x square as t square minus 2. So, you put it here. Okay. Plus t minus 6 is equal to 0. 2t square plus t minus 4 minus 6 minus 10. So, this is 2t plus 5 and t minus 2. So, t equals minus 5 by 2, t equals 2. These are the two solutions, right? But it does not end here. Obviously, it does not end here. This is your t. So, you have x plus 1 by x as 2. This gives you x equal to 1 only. You can check. When you have x plus 1 by x is equal to minus 5 by 2. So, you have x is equals to minus 2 and minus half. You can check it again. So, 1 minus 2 minus 1 by 2. These are your three roots. Now, you would say here, sir, this is a biquadratic equation. It's a degree 4 equation. I am getting 3 solutions. Actually, you need to understand here that 1 is a repeated root. 1 is a repeated root. So, see, like what I am trying to say is if you factorize it, you will get this x minus 1 into x minus 1 into 2x minus 1, 2x plus 1 into x plus 2. This is going to be your factorization. This is going to be your factorization. Okay, got it. Yes, 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 yes. So this is one such thing. Now again, this is infinite sum. Let's solve it. Let's solve it. Can you guys like this video? Is it possible for you to do it? Find the value of this x equals 1. So like see, like again you need to understand, if you are saying oh just x equal to 1, you can you not clearly see that x is greater than 2? How can you accept answer which is less than 2? Just put it like this. Right? Now this is x. So you see x is starting from 2. So this whole thing will be x, no? So x is equal to 2 plus 1 by x. So you have x square minus 2x minus 1 equal to 0. X equals to 1 plus minus root 3. Sorry. X is equal to 1 plus minus root 2. Now since x is greater than 2, your only solution which you are going to accept is x equal to 1 plus root 2. Getting my point? Getting my point? Always check the mother equation. Always check the mother equation. Always check the mother equation. Perfect. Okay. Yes, this is the one. Now, this is not quadratic equation per se. You have to make it a quadratic equation by systematically squaring. Right? Solve it. Solve it. By systematically squaring. right? X equals 9. Is it the only solution? That is the only question. So obviously I cannot solve it like this. I am going to square it. 4x a square plus b square plus 2, right? Now 4x gets cancelled. You get 10 times this, which means 5 equals 4x minus 11. Again do the perfect square. 25 equals 4x minus 11. You get x equals 9. Now since you have squared it multiple times, you need to check back the answer. Just check it. 2 times root 9 minus under root of 4 into 9 minus 11. So this is 6 minus 5 equals 1. LHS equal to RHS. Answer is verified. So you will accept this solution. You will just accept this solution. Got it? Got it, guys? Am I making absolute sense? Perfect. Got it, guys. Let's move on to the next one. Yes, you have this. This is very simple problem. This is very simple problem. Just do it. I won't say anything. You just do it. You just do it. Do it, guys. It is not quadratic. Okay, so it is cubic. What is the matter here? This is cubic. Cube minus this is equal to 11. X minus 5 equals 1331. X is equal to 1336. What is the problem here? You just put x equal to 1336 here. You will get the answer. Not 1346. Not 1346. This is live, guys. This is live. What are you saying? This is live. Okay. Are you getting it, guys? Are you getting it? These are quite trivial, yes. Obviously. Solve it. This is another thing. Solve them. Let's solve it. Kashmir cutoff is 10. I have already told you. I don't know in which language you will understand. I have tried it in Hindi, but seems you are not understanding it in Hindi. So let me tell you it in English. 10 is enough. 3 root x. I have just cross multiplied it. Now 6 root x into root x is 6x. Minus 11 root x plus 36 root x minus 66. This is 6 root x, 6x plus 3 root x. 6x and 6x gets cancelled. 66 equals 25, 22 root x. Root x equals 3, x equals 9. X equals 9. You could have also done it like this. You could have put root x equal to t. This would have been simpler to look at least. Right? Right? This is how you solve it. Whenever you are afraid of anything, just substitute it with a simpler thing with which you are more comfortable. With which you are more comfortable. Right? Perfect. We are not going to solve word problems. We are not going to solve word problems, obviously. All these word problems are homework for you. Ah, yes, this is the one. Solve it. Solve it. See, with infinite time, anybody can solve it. You need to be smart while solving it. Show me your smartness. Show me your smartness. Hollandite and Loney good enough for IOQM and RMO. Dude, what are you saying? Hollandite and Loney are JEE books. They are not IOQM books. They are not IOQM books. Right? Solve it, no? Like who are saying that this is going very easy? Ayush, if this is easy, then give me the answer of this. Give me the answer of this if this is easy. I am good, Asif. Asit Kumar Patnaik, I am very, very good. Perfect. Now, just see. Now, can I write it like this? 8x plus 23 upon 20 plus 1 is equal to 5x plus 2 upon 3x plus 4 plus 2x plus 3 by 5. Right? I don't know what is going to happen, but I am committing myself to this. Right? This is what I have. Okay. If I take LCM, I will get 25x plus 10 plus this is the quadratic which I am getting, which is a problem for me. 3x plus 4, 3x plus 4 into 2x plus 3. I'm just going to solve it in rough. This is 6x square plus 9 plus 8, 17x plus 12. 6x square plus 17x plus 12. Okay, so this is 6x square plus 42x plus 22 times, we will try to solve it. This looks very promising yet difficult. 5 times 4. Now if you solve it, 8x plus 43. See, like this is a linear expression only. If you see, eventually it will become a linear equation. 168x plus 88. You have 24x square here, 129 plus 3161x here, plus 43 times 4 is 172. 24x square get cancelled. You have 1284 here, 7x here, x is equal to 12. X equals 12. Hi sir, first time in your life. Welcome podcast media. Welcome podcast media. Ah, nice. I like it. Yes. This is a very good thing. See what this learner is trying to say. Sir, this is it. You put 8x plus 12 upon 20. Just write this like this. And then take 5x plus 2 here. This is very good. I like it. Minus 1. Now, since the denominators are same, this becomes 11 by 20. 5x plus 2 and just add 1 here. Plus 4. 31. 31 into 3x plus 4 is equal to 20 times 5x plus 2. You have 93x here plus 124. 100x plus 80. You have 7x equal to 84 again. 40, sorry. So x equal to 12. This is alternate method. Like I said, in these problems, manipulation is going to be the important thing. Manipulation is going to be the important thing. Perfect. This is homework. Guys. Solve it. This is for manipulation. Again, this question is for manipulation. You have to do something which will solve this problem. Plus minus kuch kar do. Plus minus what? See, like now can you see this is this, right? And I'm just writing LHS here. So can I write it like this? Can I write it like this? Okay. Okay. Now simply you can put it and you can cancel 2 also. You have 1 upon x minus 10 minus 1 upon x minus 9 is equals to 1 this and this. Again take the LCM, x square minus 19x plus 90 upon x minus this is 1 minus 6 plus 7. Again 1 by x square minus 13x plus 42. X square gets cancelled. 19x minus 90 equals 13x minus 42. 6x comes 48. X equals 8. 8. Right? So usually the answer here is, you see, 6, 7, 9, 10. What is the average of these 4 numbers? The average of these 4 numbers is 8. So usually the answer is average of these numbers. Sir, what we have to do to actually master these manipulation, you have to follow these lectures, guys. It comes through experience, and like there are lot many problems in this notes, like in these notes, which you can solve, by the way. Musab is saying that, sir, I brute forced. Oh, is it? This is the idea actually. This is the same problem, right? You can solve it later. It uses the same idea. We have used it. We have solved it. Why they are repeating? Yeah, this is the one. Now solve this problem also. Solve this problem also. Solve this one. Square. Learners are saying suggest square it. Okay, I am doing it. Like you are saying, x plus 5 into 3x plus 4 equals 12x plus 1. So what do we have here? 2 times square root of x plus 5 times 3x plus 4. We have 12x minus 4x as 8x minus 8. Perfect. Perfecto. Right? So again square. When you square again, I think this is the correct one. Yes. So x plus 5 times 3x plus 4. Now can you see 2 getting cancelled with this? Like I can cancel 2 and write 4 here. So this is 16 into x minus 1 square. So this is 16x square minus 32x plus 16. What do I have here? 3x square, 19x plus 20. So what do I have here? 13x square minus 51x minus 4 equals 0. X minus 4, 13x plus 1. Okay, this is what I get. X equals 4 and minus 1 by 13. Obviously I'll have to check all these solutions. All these solutions I have to check. Oops. So if I put x equals 4, what do I get? 3 plus 4 equals 7. This is right. Now this is a very, very problematic thing, right? X equals minus 1 by 13. So 5 minus 1 by 13 plus 4 minus 3 by 13. Now what do I get? 68 by root 13 plus 7 by root 13. This gives me 15 by root 13. And RHS will be 1 by root 13. So it does not match. So this is rejected. X equals 4 is only solution. Getting my point? This is the only solution. This is the only solution. Okay. Okay, guys. Guys. Got it. Perfect. Done. No, I don't know anything about it. Ayush Goyal. I don't know anything about it. So this is worksheet, guys. This is for you to solve. This is for you to solve, right? You can solve it, right? This is for you to solve. So we have included the worksheet in this only. Okay, this is the worksheet, guys. All the questions are from the lecture, so you can solve it. Okay. So these are certain links. This is my Telegram link. Every single one of you should follow this channel. The reason why I want you to follow this channel is because every update about me, my courses will come here. Every single update will come here. Okay. So today we are going to study ratio and proportion. So what are ratios? Ratios are tool to compare two things, right? Ratio is something which we have studied in class 6th, 7th, 8th, but we have actually not used it. That is what my opinion is. At least my opinion is this, right? So let's start with the basic. Let's start with the basic thing. What is a ratio? A ratio is a comparison of two numbers by division. The ratio of A to B is written as A is to B or A upon B. In the ratio A is to B, A and B are called terms of the ratio. A is the antecedent, B is consequent. Now this is something which is very bookish, right? Now we don't use it. We don't use this definition per se. Two things to note here is, comparison is always between same type of things. Same type of things. Okay? Definitely between same type of things. Is it okay? Between same type of things. Correct? This is one. This is one. Second, ratio is nothing but division. These are the only two things. What do we call A? What do we call B? It is immaterial. It does not matter at all. All we need to understand is that this is ratio between two things. And since these are quantities, these can be velocities also. Now velocity can be negative also. So this ratio can be negative, can be positive, can be zero also. So A by B is essentially can be any real number. Can be any real number. So these are the two things which you need to mention when you are writing the definition of ratio. You do not need antecedent, consequent. This I have included for the sake of it. For the sake of it means to complete the definition which you may write in your copy. Okay? One student is asking, how is your book for boards? I hope you are not asking about the IOQM mathematics book. IOQM mathematics book is not for boards, right? In fact, there are certain methods which are written there. You cannot use those methods also in your board examination. But yes, my Envision book of class 10th is highly useful for boards. If you want to grab that, you can definitely do it. You can definitely do it. Okay. So this is basic definition about ratio, right? Now, like I said, in ratio, two quantities are compared, so the quantities must be of same kind, that is, they must be expressed in the same units. Okay, and yes, ratio is unitless. It is always unitless, right? It is always unitless. The order of the terms is very important. 2:3 is not same as 3:2, right? Obviously, it is very important. Now, in this particular lecture, we are going to study very important techniques in which ratios are to be used. Just to give you the perspective, there is a very important chapter known as vector and 3D in mathematics. Usually it has weightage of 8 to 10%. Getting my point? So, which means out of 120 marks of mathematics in JEE advanced paper, around 12 marks will be of vector, and in vectors, ratio is of immense importance. For that matter, this is the form of line in 3 dimension. Just see, can I say that this looks just like 3 ratios being compared? Can I say this? Can I definitely say this? Right? So this is the importance of ratio. You need to understand the importance of ratio. Only then you will be able to stress on it. And why students tend to ignore it? Because these things do not come in class 9th and 10th. They may have studied it in their till their 8th class, but in 9th and 10th they do not study these, and that is why they really do very bad when it comes to JEE mathematics. So this chapter is highly useful. This particular lecture is highly useful for JEE as well as it is highly useful for IOQM. Right? Perfect. Let's move on. The value of ratio remains unaltered if the given ratio is multiplied, right? Because at the end of the day, you have to consider it as a division. So if this is a division and I multiply m here and I multiply m here, it is immaterial. Obviously, m should not be equal to 0. Otherwise, you will end up making, in denominator, you will end up making 0, right? Which is not good. Okay. But now I am going to tell you something which you may not have studied till now, right? I am going to write that thing. Right? I'll write it here, right? Can I write this as ratio? See, x minus 3 upon 0 is equal to y minus 2 upon 4. Is this a valid representation? And if it is a valid representation, what does this imply? If this is a valid representation, what does this imply? You can directly say, sir, this is not valid. Sir, this is invalid. How can 0 be in denominator? I want to clearly differentiate between division and ratio, because majority of the students think that ratio is nothing but division. It is not division. Parikshit, what Prakshit is saying, yes sir, it implies y equals infinity. It is wrong. It is completely wrong. Just solve it, just solve it. How do we solve ratio? We put this equals a. Now we have this equation. Y minus 2 upon 4 equals k. This implies y is equals to 4k plus 2. So y is of the type 4k plus 2. But when you put these two equations, x minus 3, this implies x equals 3. So yes, this is a valid representation, but whenever you see this representation, always assume that the numerator is also equal to 0. This is the representation. This is a very important note. Every single one of you should mention it. If denominator is 0 in the ratio, it is possible, but it is only possible when numerator is also 0. So this implies x equals 3. Please write it down and write done in the chat. This is a very important point. Sir, can class 10 students learn this? Yes, definitely they can learn it. So these are basic lectures only. These are basic lectures only. Like I am going to record a very important video, roadmap to IOQM 2025. I am going to record that, and in my opinion, that video is going to be very, very important. Right? Done? Obviously, yes, I am going to explain that. And in fact, in this lecture only, I think we will be using some of these techniques. Okay? Yes. Now, this is very important. To divide a number into parts in a given ratio, right? This is a very important skill. And I am going to use this skill as well. Let x be the given number. The given ratio is x1 is to x2. X is to be divided into two parts such that the value of first part is to value of second part is x1 by x2. So, what does this mean? See, what I am trying to say here is divide 14 in ratio 2 is to 5. Okay. So, in numbers it is very easy to see. Sir, 1 will be 4 and 1 will be 10. These are the two parts. Dividing whole into parts in a certain ratio. Divide 14 in ratio 2 is to 5. The two parts are 4 and 10. This is very simple, right? This is very simple. But when we do it in variables, then it becomes very, very tricky. And in fact, majority of the students struggle to understand it. If I say that x is the given number, in this ratio it is to be divided. If I say that the first part will be this and second part will be this, they feel great difficulty in understanding it. They feel great difficulty in understanding it. Okay? Okay. They feel great difficulty in understanding it. And see, like, even if you understand it, understanding and applying are two different things. Understanding and applying are two different things. You should be able to apply these things in problem solving. While doing the problems, you should be able to solve it. That is the most important thing. Yes, you should definitely listen to it. So see, like, this is the thing. This is certain example. You can do it if you want. Just do it. To divide a number into the parts. How it will be useful? See, let's do one example. This is A, this is B, this is C. Okay. Now let's imagine that this side is 26, this side is 30, this side is 28. This is angle bisector, right? This is angle bisector. What do I mean by angle bisector? This angle is equal to this angle. Now we know that BD upon DC, this is angle bisector theorem, equals AB upon AC. Find BD and DC. Let's solve it. Let's solve it. Sir, please discuss about the scam and fraud done by MD. We want justice. See, like, we have done enough in this, right? Guys, we have to study also, right? We need to move on also. We cannot stay here forever. We have made 2 videos. I have made 2 videos. You have seen my videos. And I have mailed also. I have written on LinkedIn. I have written on Twitter. I have written on Instagram. I have written everywhere, right? Now it is upon you to spread that information. Nothing is going to happen if I come here and speak about it. Nothing is going to happen. I have already spoken about it. all you need to do is to share it everywhere. Share it on your WhatsApp channels, WhatsApp groups. Share it with your father, share it with your mother, share it with your family members, share it with your friends. Ask them to share it forward, because this can only be resolved if many people talk about it, right? Got it. Perfect. So see, now what I am going to do, this, see, like AB upon BC is 13:15. Now I always make sure that the addition of these two, 13 and 15, it is coming out to be 28, which means essentially these are the lengths only, because the ratio is 13:15 and the addition is also 28. So like I said, in one line, you should not be writing these things. So let x be this, the parts be x1 upon x1 plus x1. No. This is not board examination. This is IOQM examination. You should be able to write this in one line. That is the practice which is required. Okay. Okay. So like Prakshit is writing, it is incorrect. Getting my point? Guys, please like the video, yaar. Come on. Please like the video. I request you to like the video. Perfect. Let's move on. So, if A, B and C, D are two given ratios, then, now do you agree that this is valid? Do you agree this is valid? It essentially says that A by B greater than C by D implies AD greater than BC. It is only applicable when ratios are positive. When ratios are positive. Please write this line. Ratios are positive. Please write it. When the ratios are positive, then you can write it. What is the cutoff for national certificate? I think the cutoff for national certificate is going to be 29. 29 is going to be the cutoff for national certificate. Right? Right? Got it. Let's move on then. Second point is obviously same. Yeah, but this is true always. Because in all such circumstances, you can just consider this as fractions. A upon B equals C upon D. Right? This is true always. Okay? This is true always. Ratios can also be compared by expressing the ratio in fraction. So this is the thing. This I have already told. Now again, these are included in the notes just for the sake of it, so that you can make proper notes. These are not at all important while solving an IOQM problem, right? Two most important things are, first is componendo dividendo, and the other one is addition. How does addition work in componendo, like in this? I will talk about them, right? So let's talk about them, right? This is all theory. It is not required, believe me. Compounded ratio. So all these things are important for ICSC students. In ICSC students, like this is, I think this is in their curriculum. It is not at all required for us. But I have still included it. So that you can make notes after downloading it, right? I will give you the proper notes. You can just like write these things, okay? We are going to focus on the most important thing. Yeah, this is thing. So this is proportion. So ratio, you have understood. Now this is proportion. When you say A is to B is proportion to C is to D, this implies that two ratios are equal. And this means AD equals BC. AD equals BC. Okay? Okay? Yes, product of extremes equal to product of means. That is true. Okay? Now this is important, right? This is important. These properties are important, right? Componendo, dividendo is still coming. So what is invertendo? So if this is the ratio, you just reverse it. Obviously, what you need to say here is that B, D should not be equal to 0. Okay, B and D should not be equal to 0. So you have just inverted the ratio. There is nothing new in it. No, these properties are not at all important. This property is important. Whatever are the properties of proportion. So in ratio, only this thing is important, how to divide a particular whole into certain ratio. This is important, I agree. But in in proportion, there are certain properties which are very important. Invertendo is important, componendo is important, dividendo is important. Right? Perfect. Let's move on. If A is to B is proportion to C is to D, this result is known as alternando. Right? So basically, cross product you can say it. Right? So this is going here simply. Okay. A by B equal to C by D implies A by C equal to B by D. Right? Perfect. Now this is componendo. This is very important, and the proof is also written here. If A upon B equals C upon D, you just add 1 to it, you will get this. Similarly, if you subtract 1 from it, you get this. And when you divide it, you essentially get, if A by B equals C by D, it implies A plus B upon A minus B equals C plus D upon C minus D. This result is called componendo and dividendo. How do you understand it? This is numerator, this is denominator. Numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator upon numerator minus denominator of the right hand side. This is left hand side, this is right hand side. The left hand side is being transformed in this manner, right hand side is being transformed in this manner. You just need to understand it, you just need to remember this thing, that the transformation of left hand side is same as the transformation in right hand side. Right? In fact, you can also write it like this. If A by B equals C by D, it will also be equal to LA plus MC upon LB plus MD. This is very important property. You can write it. Please note it down, guys. This lecture is going to be around 75 to 90 minutes. Please write done if you have understood it. I am just going to write the dividendo also. If you have written them, just write DN. I expect you to make notes, guys. Right? If you are here for casual watching, then there are many interesting things on YouTube to see rather than this lecture. Right? My face is not that beautiful that you just come to see me. Right? There are many beautiful faces around there. Just go and see them. If you are here, if you want to study properly, study in proper posture, make notes, ask doubts. That is how it is to be done. Otherwise, there is no point of me taking these lectures live. Might as well just record these lectures and put it. Shaurya Kumar Maurya is saying, sir, 21 marks not qualified. Come on, yaar, you have got 21 marks. You should be very happy about yourself. You have such a beautiful rhyming name, Shaurya Kumar Maurya, right? How many of us have this type of rhyming in our names, right? You will always be an interesting person in a room just because of your name. This is so good. Okay, let's move on. Right? So this is called componendo and dividendo. Now this is something which we will study in GP also. This is called continued proportion. If A upon B equals B upon C,
it implies B square equal to AC. Now B is called geometric mean of A and C. Now how many of you want to know why it is called geometric mean? What is so geometrical about it? How many of you want to know this? How many of you want to know this? Why it is called geometric, sir? Thank you, Babita Singh. How many of you want to know, sir, why this is called geometrical progression? Like why this is called geometrical mean? Right? So should I tell you this thing? Should I tell you this thing? How many of you want to know it? Perfect. Perfect. So see, now let's take this as 90 degree. This is A, this is B, this is C. This is also altitude. Now let this length be A, this length be C. Okay? 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 Am I making sense? Right? Let's call it H. Let's call it H. Now this is theta. Right? So tan theta is A upon H. But if this is theta, this is 90 minus theta. And this is 90, this is theta. Right? If you do not know trigonometry, just ignore it. So tan theta is also equal to H upon C. So can you see that H square is AC and H is square root of AC. So if an altitude is drawn from the vertex of right angle triangle onto the opposite base, its length will be the geometric mean of these two segments, and that is why it is called geometric mean, because this whole configuration is geometric, isn't it? This whole configuration is geometric. This whole configuration is geometric, isn't it? Isn't it, guys? Guys, am I making absolute sense? Am I making absolute sense? Right? Perfect. Perfect. Right? I think, yeah, this is the property. This is the property which you have to remember, guys. Very, very important property. It will be of very, very immense use. A upon B equals C upon D equals E upon F. Now, see, like these three are numerators. Now, you are multiplying K with first numerator. You are multiplying L with second denominator, with numerator. You are multiplying M with the third numerator. Now, what you have to do, you have to multiply with same numbers to corresponding denominators, and that ratio will be same. That ratio will be same. So I think we should definitely prove it. I think we should definitely prove it. Otherwise, you will not be able to understand it. So what I am going to do, let me first see if, yeah, the content is free here. This is the last property. After this, we will be doing problems. Now let's solve it. A upon B, C upon D, E upon F. Let this ratio be X. Let this ratio be X. Now, we are given with this number, Ka plus Lc plus Me. Consider this fraction. If this fraction comes out to be X, then we are done. If this ratio comes out to be 1, then we are done, isn't it? If this ratio comes out to be X, then we are done. Now, what I am going to do, I will put A equals Bx, C equals Dx, E equals Fx. Right? 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 This is Kbx, Kdx plus Kfx upon Kb plus Ld. Oh no, Lm. Ld
plus MF. Can you see this reducing to X? Right? Yes, Prakshit. This was precisely my point. If you are listening to me very, very carefully, you could have understood this thing. Sir, this is the property where you have written this, right? This implies X equals 3, right? This is what I was trying to say. I have already explained this property. I have already explained this property in earlier slides, but I just wanted to prove this. The proof is not very trivial. It is not very obvious. It requires some effort. Can you please note it down, guys? Got it? Perfect. Let's move on. Combining two ratios. This is very important. So like this is an elementary lecture. You need to understand this thing. This is an elementary lecture and I will be giving you more problems. I will be giving you more problems on it. Right? I will be including PJ exclusive also in this. But this is an elementary lecture. Like I told you, my initial lectures are going to be very, very basic. Can you just write the answer in the chat? And I will give you the exact correct method. (20 is to 36 is to 63). Please write these problems in your please write these problems in your notebook also. So see, like the benchmark rule here is, this is A upon B, which is equals 5 by 9, okay, right? B upon C equals 4 upon 7. Now B is your connecting dot. B is your connecting dot. Now here B corresponds to 9, here B corresponds to 4. Just take LCM of 4 and 9. Just take LCM of 4 and 9. What is LCM of 4 and 9? What is LCM of 4 and 9? Is it 36? Now my intent is going to be convert this 9 into 36. How do I convert it? A upon B, I'll just multiply it by 4, and we have done this property that if you multiply the ratio with the same number in numerator and the denominator, the ratio won't change. Similarly, I will write this B upon C as by multiplying 9 in numerator as well as denominator. Once you get same number corresponding to B, just do this thing. Combine them and write it in this manner. A upon 20 equals B upon 36 equals C upon 63. This implies A is to B is to C, 20 is to 36 is to 63. Getting my point? Getting my point? This is how you do it. This is how you do it. Right? So this is where the manipulation was involved. There has to be a protocol to combine the two ratios, right? So you just have to make this connecting dot, which was B, both these B should correspond to same number. Here B is corresponding to 36, here B is corresponding to 36. Okay? Please write done. If you have noted it down, just write done so that I can move on to the next page. Please write done so that I can move on to the next page. Done? Perfect. Now, the monthly income of two persons are in ratio 4:5. The monthly expenditure of them are in ratio 7:9. If each saves rupees 1000 per month, find their income. Okay? Let's do it. Monthly incomes of two persons are in ratio 4:5. Now again, this is a very procedural question, but obviously you need to understand that procedure. If their monthly incomes are in ratio 4:5, this means they have this income. Their expenditures are in ratio 7:9. So 7y and 9y. Now they have same saving. So these are the two equations which you get. These are the two equations which you get. But you should not be solving this. You should be very smart in solving them. You will just equate these two. And hence you will get x equals 2y. Right? Am I making sense? How do you get x equals 2y? Just 4x minus 7y equals 5x minus 9y. 9y goes here, 2y, and x goes here. Okay? 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 4:5. Got it? Now this is x equals 2y. So, since I want their income, I want x. So I will put y here. Y equals x by 2. 4x minus 7. Y is x by 2. So x by 2 here equals 1000. Here I get x equals 2000. Now their income was in ratio 4:5. 4x and 5x were their incomes. So 8000 and 10,000. Getting my point? Getting my point? This is how it is done. This is how it is done. I think we can move forward. This is very simple. This was very simple. I think we can move forward. Let's move on. Yes. Please solve it now. Take some time. Take some time, guys. Take some time here. Solve it. Solve it, guys. Solving it. Are you able to solve it? This is very difficult, right? This looks very difficult. But we can solve it using very simple techniques. Yes, this is from Holonite. This is from Holonite. This is from Holonite. Right? Now I am going to use a very famous technique known as LHS equal to RHS. LHS equal to RHS. My LHS is this. Now, the reason why I taught you algebraic identities first, I can say that these are symmetric expressions, right? If this ratio equals k, then this will also be equal to k, this will also be equals to k, because x is related to a. Now you see here, x by a, let's call this ratio r, okay? So x square by a square is r square, isn't it guys? Isn't it guys? Very simple, right? Now see here, please look at it very, very carefully. I will put x square as a square r square and x as ar. So my this expression reduces to, see, a square 1 plus r square upon a 1 plus r, right? So this becomes a times 1 plus r square by upon 1 plus r. Now you should be able to observe that if this is this means this is going to be, this LHS is going to be a plus b plus c upon 1 plus r square upon 1 plus r. Because that way your life will be much more easier. Now your life will be much more easier. Why? Let me tell you. This right hand side is very, very easy now. Just put x as AR. So if you see here, this is a plus b plus c times r plus a plus b plus c, okay? In numerator, you have a plus b plus c whole square into r square, because this whole thing is this, and if you're squaring it, this thing gets squared, r gets squared, plus a plus b plus c whole square. Now, take a plus b plus c whole square, one factor will get cancelled, and you will get a plus b plus c into r square plus 1 upon r plus 1. Our favorite technique, LHS equal to RHS, left hand side equals right hand side. Obviously, this was the critical step. Assuming this ratio to be r, replacing the value of x, y, z in terms of the denominator and r, and coming up with this expression, and then observing, this was the master stroke, then observing that if this is a times something, this is going to be b times something, this is going to be c times something, and this whole expression becomes a plus b plus c into 1 plus r square upon 1 plus r. Done? Now this is very bad. Yeah, now this, in fact, it is good. Somebody was saying, I wanted, sir, r. I have assumed k. K is also good. K is also good. Perfecto. Perfect. Now solve it. This is very similar to what we have done. This is very similar to what we have done. And I will solve it in the same manner. Let's see if you are able to do it. Let's do this, guys. Let's do this. X upon b plus c minus a, y upon c plus a minus b, z upon a plus b minus c. Let's solve it. And you just have to think, how do you get ax, how do you get bx, by? You have to think in this manner. And it involves, sir, can we solve your book after this? Yes, the ratio and proportion you can definitely solve. You you have IU. So like my new edition is coming. The new edition has only one change. It has IOQM 2024 paper solved. That's it. Nothing more, nothing less. Prakshit, you are in the correct direction, but I don't think it will work here. I don't think it will work here. Yeah, that is okay, Akshansh. No problem. Akshansh, you can solve that also. Perfect. Thank you. Thank you. Now let's see. Let's see. I always approach ratio proportion problem by seeing what is required. Now this is very simple. All I have to do here is, if I add all the numerators, please see here, this is x, right? Now, as long as I am doing the same thing with numerator and denominator, I am adding these three numerators. So this ratio should remain intact if I add the three denominators. Now, if I add three denominators here, I will see there are two a's in addition and one a in subtraction. Interesting. So let's assume this ratio is r. This whole ratio is r, which means your left hand side has come out to be r. Your left hand side has come out to be r. Okay. Your left hand side is reduced to r now. Now let's solve the right hand side, and let's use some manipulation. Let's use some manipulation, shall we? Let's add these two now. If I add these two, I have x plus y. Now if I add these two, c remains here, a gets cancelled, b gets cancelled. So you have this. Automatically, since you are, see, like this ratio will remain intact. So y plus z upon 2a, z plus x upon 2b. This is a very critical step. This ratio will also be r. Please see this. Please see this, guys. If you are okay, then we can move forward. What I have done here, I have just added these two numerators, x plus y, added these two denominators, which means the ratio will remain intact. Y plus z, these two 2a. So this is coming out to be my final expression. If we are okay here, please write done, because this is the most critical step. This is the critical step. And this is where the magic happens. This is where the magic happens. The magic is about to get, like it is about to happen. The magic is about to happen. Now, see what I'm seeing here. Y plus z has x. A also has x. Let's do one thing. Can I use that property of mine that if I had z here, it can be written as this? Whatever is absent, just introduce it, right? So this means if I'm multiplying the same number in numerator and denominator, the ratio remains intact. So this ratio is also equal to r. And what you have to do now, just add the numerators and add the denominators, you will get this expression only. Isn't it? This is magical. This is manipulation. This is why we do IOQM preparation. This is the hallmark of IOQM preparation. It prepares you for such amazing manipulations that your mind gets trained to, like your mind will get trained to accept any type of challenge. Any type of challenge. Right? Like I told you, this is where the magic happens. Got it? So just add the numerator, add the denominator, you will get the right hand side. You will get the right hand side. Okay, perfect. Perfect. This method is OP, yes. So just add the numerator, you will get this. Okay, perfect. I hope you have noted it down. I hope you have noted it down. Next, let's do this. This is application of componendo dividendo. Let's use this. Let's solve it, guys. Let's solve it. This is example of componendo dividendo. Tell me the answer. Hindi, yeah, there is Hindi batch. Hindi batch is recorded. I have already taught. And see, like next year, I'm not going to teach in English. Obviously, it is going to be a recorded course only in the next year. Hindi and Hindi batch. If you want to study live in Hindi, you have to join Ramanujan course. Now let's do it. Now I can see like this is very, very dramatic, very difficult looking. I don't have to worry about it. I will just write it as x a plus b upon a minus b. Now, what does componendo dividendo says? Numerator plus denominator upon numerator minus denominator is a upon b. See, like there are two conclusions. There are two conclusions of RMO, like of componendo dividendo. If a by b equals c plus d upon c minus d, this automatically implies a plus b upon a minus b equals c by d. This is very important. So, if you want to convert this into numerator plus denominator upon numerator minus denominator, then you can just simply write this as fraction like this. Now just see, do you want to generate a cube here? Yes, so I will generate a cube here. Let's do cubing on both sides. Now if you remember, what was a cube? M plus 1. What was b cube? M minus 1. Now, we have done algebraic identities. I will write this as this, decreasing powers of x. This as decreasing powers of x, right? And alternating. Got it? Now, this is another manipulation. in the next step, I am going to do something very amazing. I am going to club the positive terms, x cube plus 3x plus 3x square plus 1. X cube plus 3x minus 3x square plus 1. Now this is m plus 1 upon m minus 1. So again, this is numerator, this is denominator, this is numerator, this is denominator, this is numerator, this is denominator, this is numerator, this is denominator. This implies x cube plus 3x. Reverse of component to dividend, numerator upon denominator equals numerator upon denominator. Okay, now just cross multiply and get this answer. Just cross multiply and get this answer. Am I making sense, guys? So x cube minus 3mx square plus 3x minus 1 equal to minus m equals 0. Okay? 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 Can I follow your 2023 playlist? Yes, you can most certainly do it. If you want to follow me, if you want to follow my Hindi lectures, my time-stamped Hindi lectures with worksheets are being uploaded every Monday, Wednesday, Friday at 7 p.m. My English course is on Wednesday live at 5 p.m. Right? So I have given two options to all the learners. Getting my point? Perfect. Now let's do this. So this is a job things, right? These are direct problems. Work problems. We call it work problems. These problems directly come in IOQM. In my book, these are covered in commercial mathematics. Yes, I will complete full IOQM. And in fact, SPS sir will also take some lectures. Done. Let's do it. 4 men and 3 women finish a job in 6 days, and 5 men and 7 women can do the same job in 4 days. How long will 1 man and 1 woman take to do the work? Right? So see, how do you solve it? Right? The basic step to do it is 4 men are putting efforts in 6 days. So there are 4 into 6, 24 man days, right? 3 women are putting in their effort. So 18 women days, right? So the work is worth 24 man days and 18 women days. Okay. Let's write man days with M, women days with W. Similarly, 5 men, if they work for 4 days, which means 20 man days, plus 7 women for 4 days, 28 women days, it is also the same amount of work, which means 4 men equals 8W. So M equals 2W. So 1 man day is equivalent to 2 women days. Now how does this solve our problem? We will now represent our work in man days only. 24 M equals 2W plus 18W. Okay. So we have 48, 66. So our work is worth 66 women days, right? So see, like, there has to be some unit. If I am not a student of physics, I would not know what is the unit of work. I cannot say it is Newton meter per second square, right? Because I don't know physics. What I know is mathematics. And in mathematics, we can invent our own units. So I have invented a unit called Women Day. So my work is worth 66 Women Day. Now what is the question? The question is asking me one man and one woman. Right? How many days will they take to complete this work? How long will one man and one woman take to do this work? Right? This is the ask. This is the ask, isn't it? This is the ask. Okay? Am I making sense? Am I making sense, guys? So now, let it be T days. So 1 MT plus WT should be equal to work. Should be equal to work. I think I have made some calculation error here, right? 24 into 2W plus 18W, 4866, right? It should come out to be 22 days, right? It should come out to be 22 days only, right? So this is T days. Now M will be equal to 2WT plus WT equals 66W, right? WWW will get cancelled, T comes out to be 22 days. The answer should be 22 days, right? Isn't it? Oh, this is where I have made the mistake. Yes, this is where I have made the mistake. Sorry. This is where I have made the mistake. Maha mistake. Let me correct it. Guys. See guys, I am also a mortal, right? Human beings make mistake. So this is where I have made the mistake. It is 10W, which means 2M equals 5W. So my work is worth 12 into 2M, 5W plus 18W. So this is equal to 78W. Right? So now my one man do work for T days and my one woman do for T days. It should be 78W. Now replace W, replace M with 5W by 2, right? So that my WWW gets cancelled. So this becomes 78 into 2 by 7, which is equals to 156 by 7, which is equals to 22 2 by 7, which is option number A. Now do you know what is the convention method? What is the conventional method? You must have seen this method. 4 men, 4 by M plus 3 by W equals 1. These are the two equations which usually you see in all the textbooks. This is how you do it. 4 by M plus 3 by W equals 1, and you need to find the value of 1 by M plus 1 by M. Right, equals to 1 by T. So this T you need to find. This T you need to find. So this is the equation which is usually formed, but I do not follow this. I follow the man day approach, man day and women day approach, because this is where I do not have to use any fraction. I am genuinely very bad in fractions. And just see, if I am saying for myself that I am bad in fraction, that you can assume yourself to be worse in fractions, right? Got it? Got it? Perfect. Let's move on to the next problem. A person distributes his pen among 4 friends, A, B, C and D in the ratio. What is the minimum number of pens that the person should have? Very interesting problem. Very interesting problem. Let's solve it. Let's solve it. Very interesting problem. 57 pence. Distribute among ratios. See, like, first of all, ratios should not be in fraction. So what is the LCM of 3, 4, 5 and 6? What is the LCM of 3, 4, 5 and 6? It is 60. So multiply every number with 60. Right? What do I get? 20 is to 15 is to 12 is to 10. Just add them now. 57 pence. So if you have 57 pence, you can give 20 pence to A, 15 pence to B, 12 pence to C, and 10 pence to D. Right? 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 Perfect. Now, this is now these are homeworks now. These are homework now. Right? This is homework. This is first homework. This is second homework. This is third homework. Same type of problems, right? I have given you more problems now. Right? You can ignore this. If you want, you can ignore this, because variation is something which is not asked usually. Yeah, this you can find definitely. So yeah, thanks for watching, guys. So this was a lecture which you can use as a tool lecture, and it is beneficial for JEE and IOQM, and both has equal weightage of ratio and proportion, right? So I hope you liked it. Now, I am going to start with a very, very simple equation. AX plus BY equals C, right? And let's take one example. 2x plus 5y equals 20. Okay. If you have studied in class 8th, 9th and 10th, this equation represents a straight line. In fact, you can plot it also. Right? You can plot it also. Indeterminate equation. You can also plot it. Now, how do I plot it? See, Euclid said in one of his very famous lines, for a line, you need 2 points. If you have 2 distinct points, you can make a unique line. So this is x-axis, this is y-axis. Let's try to find 2 unique points in this line. The very trivial way to do it is put x equals 0. You will get y equals 4. This means that 0, 4 will be a point on this line. Next, put y equals 0. You will get x equals 10. Right? You just have to put any one of the value here. 10, 0. So this is the line. Right? 2 points determine a unique line. Now, the thing is that there are infinite points on these lines. This is a point on this line, 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 this is a point on this line. There are infinite points on this line. Right? But if I introduce something, if I say find the points on this line such that both the coordinates are natural numbers. Now, natural numbers is something which it is the term which we use in our NCERT, right? But in an Olympiad term, this is called positive integers. right? You will find positive integers written everywhere. Okay. So find the points on this line such that both the coordinates are natural numbers or positive integers. We are not getting homework now. This is for yes, the worksheets, right? You will be getting the worksheets in this also, and in the Hindi lectures we will be attaching the worksheets very soon, right? We will be attaching the worksheets very soon. Currently our focus is on NACJS. That is why we have halted that course, right? That course will be like it will resume after 24th of September. Okay, so find the points on this line such that both the coordinates are natural. Now this is very interesting, right? This is very interesting because now you can see this is a natural number 1, 2, 3, 4, 5. These are again natural numbers 2, 3, and this is 4th. I can see here that for y, you can clearly see y is less than equal to 4 from this diagram, because when y is greater than 4, your x coordinate will be negative. If y is greater than equal to 4, your x coordinate is negative, which is not okay. And x is greater than equal and x is less than equal to 10. You have these two possibilities, right? And these possibilities are simultaneous. Basically, your y has to be less than equal to 4 and your x has to be less than equal to 10. But again, how do we solve it? This is a very pressing thing. How do we solve it? One of the learner is saying only 5, 2 is a valid solution. Only 5, 2 is a valid solution, right? In this lecture, we are going to study fundamental things only, right? Like there is a very advanced technique which is called Bézout's lemma. Bézout's lemma is one thing. Then another thing is Euclid division lemma, which is used to solve it. One thing is, I don't remember actually the name. I don't actually remember the name, but it had something to do with the HCF. Right? So these are the three things which we are going to study in number theory lectures, right? To deterministically solve this equation. But in this session, we are going to do hit and trial. And obviously, when there is IOQM, there is always hit and trial, but that hit and trial should be directed. It cannot be random. It has to be directed. Right? So let's use these two informations. Have you written it? You just need to write this equation. You have to plot this and you have to write these two observations. When you are done writing, just write DN. Right? Junnu and Mirab, 17 in RMO, South Bihar. Guys, we have released the cutoffs yesterday. Right? You can see it in our video. Expected cutoff. Can you take IOQM Hindi lectures live on YouTube? Please sir, accept my request. No beta, I have already done that in past. This request was coming at least for last 2-3 years. So I had to take the lectures. Right? IOQM 2025, yes. So the book, my book of IOQM 2025, it is going to come very soon. In fact, if you go on Amazon, my book is out of stock. It is only because it is out of stock, right? And the new edition will have IOQM 2024 solutions as well, but rest of the book will be same. Okay, perfect. Now let's see again. Let's establish some things, certain things. 20. I have x is greater than equal 0, right? This is a very important, this is a very simple thing, right? Because x is a natural number, so x has to be greater than equal to 0. Let's write x in terms of y. So I have x
equals 20 minus 5y upon 2. Right? Now let's put this value here. 20 minus 5y by 2 greater than equals 0. Right? 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 Obviously, I can cross multiply 2 here. It will be of no consequence. So, clearly, I can see 20 minus 5y is greater than equal to 0, which obviously implies 20 greater than equal to 5y or y less than equals 4. What I did here is we observed something in the last slide. Now we have proved it mathematically. Y less than equal to 4 was our observation, but we have proved it mathematically. Hence, like I said, we need directed hit and try. So, y can only be equals 1, 2, 3, 4. Because our ask was natural numbers. Only these are the 4 natural numbers which satisfy y less than equals 4. Let's put these value of y here. If you put y equals 1 here, you will get 15 upon 2. This is x. Right? Y equals 2 here, you will get 5. Y equals 3, you will get 5 by 2. Y equals to 4, you get 0. So this is the only solution in which your x is also a natural number. And hence you conclude that 5, 2 is the only solution. Is the only solution. Do you get this process? Do you get this process? See, like this is very boring. This is very boring. 2x plus y equals 10, x minus y equals 5. Solve these simultaneous equations. This is very boring. This is the stuff which you get in NCERT. But IOQM is much beyond NCERT. IOQM opens the door of curiosity for all of you. Right? And this is one curious case. If you get it, please do write it and write DN in the chat box. When you are done writing, write DN in the chat box. Unset round 2. Sir, please tell some books for IOQM 2025 we are preparing by your free lectures on YouTube. See, like one book is obviously, just 1 second. One book is obviously my book, right? For IOQM. For IOQM, it is very relevant. All the books that are mentioned like everywhere, you must have heard about mathematical circles, you must have heard about pre-college mathematics. All these books are RMO and beyond. For IOQM, you need to follow a targeted book, which is IOQM mathematics. Done. Learn with Prakarsh. Sir, should we solve different books for algebra, geometry, number theory and combinatorics if we are aiming for beyond IOQM? If yes, then please recommend. Yes, you should definitely do it. See, like every year, the trends in mathematics Olympiad are changing. And there are different handouts which are coming up from the teams. For example, US team is being trained by Ivan Chan. So he releases some of the very beautiful assignments. So you can follow those. But first of all, you need to develop an expertise, right? At least conceptually. This is very important thing. And that is why, first of all, you need to complete one book. Complete one book first. Be very thorough with the theory. And then you can focus on targeted things. For example, for algebra,
you can do one book. For number theory, you can do David Burton. David Burton is a very good book for number theory, right? So let's do one more problem. If you have understood it, then let's do this problem. Let 2x plus 7y equals, just a second, (142), right? Find ordered x comma y satisfying this equation, and find ordered x comma y satisfying this equation and x comma y should be natural numbers. Let's solve this. Is your book for NMTC 2? Yes. NMTC is a subset of IOQM. Whatever you see in IOQM, right, it is a superset of NMTC. Every topic of NMTC is covered in my book. Sir, those guidelines for Nimbus batch is only for mathematics or for all subjects? It is for all subjects. It is for all subjects. Guys, please like the video. Find 2x, let 2x plus 7y. Again, what I will try to do, see the benchmark rule here is express one variable in form of the other and choose the variable which has very low coefficient, relatively lower coefficient. These are just problem solving techniques. So I have 2x equals 142 minus 7y, right? X equals 142 minus 7y upon 2. Again, I have 142 minus 7y, that just the numerator, because see, like, denominator will not contribute in the sign. This is greater than equal 0. So my 7y is less than equals 142. So my y is less than equals 20. Or 20 point something, but since y is integer, you can definitely say this thing. Okay. Now this is a very tedious task. Putting y equals 20. Then x equals 1. Put y equals 19. Now 19 sevens are 133. So you have x equals 9 by 2. Put y equals 18. 18 sevens are 126. 142 minus 126 is 16. So your x equals 8. Now let's represent these things in decimal. This is 1 only. This is 4.5. The difference here is 3.5. The difference here is 3.5. This is very interesting. This is very interesting. We are seeing a likely pattern here. So, if my y is 20, x equals 1. My y is 18, x equals 8. Going by this logic, if I put y equals 16, I should get, add 7 here, x equals 15. Now let's verify. Let's verify. Put y equals 16 here. 16 sevens are 112. 142 minus 112 is 30. 30 upon 2 is 50. So x equals 15. This implies that this is a solution. Now my pattern is working, which is amazing. Why it is amazing? Because I can just simply
subtract 2 here. Just see here. You are subtracting 2 here and you are adding 7 here. Isn't it amazing? And what are these? Are these two any randomly generated numbers? No, they are not randomly generated numbers. They are coefficients. Just see. Right? So this is the likely pattern. This is the pattern. What is the pattern here? See. You have the equation here. Okay. Now, what you need to do? Write this coefficient here and in subtraction. Write this coefficient here in addition. Okay. Okay. This is one. Now, keep y as big as possible. Now, this will come with hit and try. See, this is the biggest y you can have, right? We got this from the equation, 20. And correspondingly, the x will be 1. Now, what does this plus 7 says? You have to add this here. You have to add this here. So, if you add minus 2 in 20, you get 18. Essentially, you are subtracting 2 here. So, if you add 7 here, you subtract 2 here. If you add 7 here, you subtract 2 here. Right? 29, 36, 43, 50, 57, 64. That is it. Because the next solution will be 0. And y cannot be 0 because x and y are natural. So how many solutions did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 solutions. Okay. 10 solutions. This is a very important solving method. This is a very important solving method. You have filled NSEJS MP expected cutoff. You can see the video. We have given this in the video. Right? Please write DN here. Yes, Shashwata Ghosh. Correct. So this is how we are going to approach it. Obviously, since IOQM is integer based examination, what will be asked? Number of solutions. Right? It will be asked. Only number of solutions will be asked. So let's do 2-3 problems here. Guys, you can do the exercise. We have the worksheet of intermediate. We do have the worksheet of indeterminate equations. We will be posting it, right? We have indeterminate, right? So we will be posting the worksheet in this lecture only, right? So let's solve. Solve for number of solutions. Solve for number of solutions. X comma y. X, y belongs to natural number. First, 3x plus 5y equals 135. Second, five x plus 12y equals 39. These two problems only. Let's do it. Sir, Unacademy NSEHSS registration. I'll ask the team to call you, right?
First is 8. Okay. First is 8. Ojas Agarwal is also saying first is 8. Let's solve this one. You do second. Meanwhile, I am writing the solution for first. 3x plus 5y equals 135. Right? Again, I will keep y as big as possible. Right? And for that, you can put x equals 0 as well. Put x equals 0. Y equals 27. Right? Obviously, I will reject this solution because x is not a natural number. But you can simply subtract 3 here and add 5 here. This will be one solution. You can check it. Right? And then keep on doing it. Right? Now you must have observed this will be increasing natural number. This will be decreasing natural number. So you just have to write this. To find the number of solution, you just write this. This is rejected anyway. This is rejected anyway. Now 1, 2, 3, 4, 5, 6, 7, 8. 8 solutions. See here, you are not asked about what the solutions are. You are just asked the number of solutions. You can get number of solutions only using y coordinate. Because x is anyway not an issue. Because it is an increasing sequence of natural numbers. Right? If you keep on adding, you'll keep on getting natural numbers, right? This is not an issue. The issue is with y because it is decreasing. Once it goes below 0, it is not a natural number. So you have to keep it above 0. Till here, you are getting natural solutions. So you have 8 solutions. Right? But like I say, or like I always say, speed is secondary here. First of all, you need to grasp the concept. If you are very thorough with the concept, eventually you will be able to get the speed also. Because for speed, you just need to solve multiple problems. For second, it is only one. Interesting. 5x plus 12y equals 39. Right? Now, if I put y equals 2, I am getting x equals 3. Right? If I put y equals 2, x equals 3. Now, this is very interesting. This is very interesting. Because if you add 5 here, you have to subtract 12 here. This is rejected since x coordinate is negative. Right? Now, if you add 12 here, you have to subtract 5 here. So again, you are getting minus 3, which is again rejected. Are you getting my point? This is again rejected. Are you getting my point? And hence, you are getting only one solution. One solution. Okay. X equals 3, y equals 2. This is the only solution that you are getting. This is the only solution that you are getting. Okay. Solve for number of solutions. One thing which you must have observed, with these coefficients, if I complicate these coefficients, finding this one particular solution which we get from hit and trial will be increasingly difficult. Right? Let's try to do this. 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 Can you write dn here? Can you write dn here? right? Sir, which batch to join for complete JEE Maths? You need to join Nimbus batch, right? Nimbus batch is the one in which I am going to teach complete JEE live. Nimbus batch. It is available in description, right? Nimbus batch. You can just simply pin it. Or just add it in the description. Nimbus batch, right? Now let's complicate the coefficients. What is more complicated than prime numbers, right? Nothing is more complicated than prime numbers. Let's use some prime numbers. Let's use 13x plus 17y equals 1, 1, 1. Devil's number. Let's use devil's number. 1, 1, 1. 13x plus 17y. Solve this. I think there is going to be a unique solution to this. Find that unique solution. Two comma 5. Amazing Sid. This is very good. You solved it very fast. I like it. See, like one way to do it is, let's solve it. One way is to write it like this: 13y plus 4y equals 1, 1, 1. Then we have 13 times x plus y plus 4y equals 1, 1, 1. Now replace this x plus y with another coefficient, another variable rather. 13z plus 4y equals 1, 1, 1. Now this is amazing. This is interesting. 13 times z plus 4 times y equals 1, 1, 1. Right? All you have to do here is to put z in such a manner that it is divisible by 4. See, like the deep theory related to this will be dealt in number theory course. Obviously, it will be dealt in number theory course. But currently what we can do, we can simply use hit and try. If I have z equals 1, obviously I have one more thing, z is greater than y, right? Because x plus y equals z. So you cannot keep z equals 1, right? Let's keep z equals let's start with 1 only. Let it be. So you have 4y equals 98, which is not a solution. Z equals 2. Now z, again see here, z cannot be even. Z can't be even. Why z can't be even? Because you have 4y equals 111 minus 13z. This will become even, and odd minus even is always odd. You need to write these observations, otherwise you will not be able to absorb them, right? Odd minus even is always odd, and you have an even number here because 4 times natural number is an even number. So let's forget z equals 2. So my next thing is z equals 3. 111 minus 39. 111 minus 39 is 2. 72. Okay, so this way I have 4y equals 72, y equals 8. But this solution is rejected because my z has to be greater than my y. Now let's put z equals 5. Z equals 5. If I put z equals 5, this is 65. This becomes 4y equals 46. Again rejected because y is not a natural number here. Z equals 7. You have 13 sevens are 91. 20, y equals 5. Now this is interesting. This is interesting because my y is less than z, y equals 5, x equals 2 is my solution. Right? X equals 2, y equals 5 is my solution. So this is the only solution. But this is very complicated, right? This is again very complicated. It is very lengthy. What if I tell you a definite method? Yes. Yes. What Shaheen Malik is saying, just use Euclidean algorithm. Euclidean algorithm gives us the definite answer to this equation. The whole problem here is to find one solution, because finding next solutions is very easy. It is just adding coefficients in each other. Add coefficient of x in a solution corresponding to y. That is what we have been doing in last 3 problems, isn't it? The only problem here is to find this one solution. So let's try to find it out, isn't it? Yes, Nisha Yadav, you will get it. Yes, Nisha Yadav, you will get it. It will be, see, like Vikas, go for the plus subscription. Take plus subscription using code PJ Live, right? You will get physics, chemistry, maths of any educator. That way you can choose your physics, chemistry educators. Otherwise, if you take only Nimbus, then you will be able to get only like classes of the educators who are in Nimbus. In plus subscription, you have the advantage, and it will cost you only 12,000. But this price is till 5th of November only, right? So let's move on. Now, I am going to give you a very simple algorithm, right? How do you find HCF of 13 and 17? You know it is 1, right? But if you remember, we use this type of method for HCF. You divide it, you get the remainder, you make this divisor as the next dividend, then the final number which you get, so that the remainder is 0, is your HCF. Now, how do I write it in equation? I can write this as right? This is my eventual HCF. Right? This is my eventual HCF. Got it? Am I making absolute sense here? Right? Now, using these two, can I get equation with 17, 13 and 1 in it? See, the only numbers which are of any consequence to us are 13, 17 and 1. Because the HCF is being found for 17 and 13 and the HCF is 1. Right? This 4 is extra. So let's try to replace this 4. How do I replace this 4? Using 13 and 1 from this equation. Can I write 4 as this? Take 1 here, divide by 3. Let's put this here. So you have 17 equals 13 into 1 plus 13 minus 1 into 3. Multiply the whole equation by 3. You have this. Right? So you have 13 times 4 minus 17 times 3 equals 1. Right? But sir, how will we be able to solve it using this? We had 1, 1, 1 here. Right? This is the problem. This is the problem. Let's solve it. But we'll do it in a next page. So if you can write this, this is actually Euclidean algorithm. Euclidean algorithm. Or it is called Euclid division algorithm, EDA. This is called EDA. This used to be in NCERT, but now it is deleted because of the protests of learners. Have you written it? Have you written it? See, like Vikas, that is again hit and try. Whatever you are suggesting is hit and try. Got it. So let's use this. Now I had this 13 times 4 minus 17 times 3 equals 1. Compare this with this equation. See, I have plus here. So let's make plus here. 13 times 4 plus 17 times minus 3 equals 1. Now I have 1, 1, 1 here. So I'll just simply multiply it by 1, 1, 1. 13 times 444 plus 17 times. Now this is very interesting. This is very interesting. This is very interesting. Why this is interesting? Because you have one solution here. Now compare it with this. Can I say that 444 and minus 333 are one solution? Like this is one solution. Obviously it is rejected since y is not a natural number, but we have got the starting line, right? We have got the starting point here. What I have to do, I have to simply add some multiple of 13 here and I have to subtract some multiple of 17, same multiple, right? So that this is a natural number, right? So 13 times, what is 13 times 20? It is 260. Okay, it is still not a natural number. 25, let's try 25. 25 times 3, 325. We are very close now. 13 times 26, 338. So we will use 26th multiple of, 13, right? So add 13 times 26 here. So we will have to subtract 26 times 17, right? If you are adding, so what does this mean? You are adding 13 26 times. So what is the conclusion here? You will subtract 17 26 times. So this is essentially you are adding 338. What is 17 times 26? 17 6 are 102.
10, 442. You are subtracting 442 from it. So if you subtract 442 from 444, you get 2, and plus 338 is 5. Confirm. Please confirm. Was this the solution? Was this the solution? Can you please confirm? This is that one deterministic method which will always give you that one answer from which you can get all the other answers. In RMO for question 2, I wrote all steps correct, but I thought one won't come. Hence, I neglected one and wrote only 5. How much will I get? See, like if you have not included one, but your reasoning for 5 is correct, and you have proved that anything greater than 5 will not work, then I think you will get good amount of marks. You will get at least 14. Perfect, right? Now we are going to do some PYQs. This is, I think, pre-RMO 2013 PYQ, if I'm not wrong, right? It was a alphanumeric problem. My mother gave me ₹1,000 to get notebooks and pen, right? Right? One notebook is of ₹35 and one pen is of ₹30. If I have to consume the whole amount, and get the maximum number of commodities how many notebooks will I have? See, like one interesting fact about practical mathematics. So this is practical mathematics, right? You can see these problems coming in your day-to-day life. Obviously, like your mother will instruct you exactly how many notebooks to get, how many pens to get. But this mother is like, she wants to test her son's mathematics. Okay. So you need to find the equations and you have to solve it. Let's see. Correct. Yes. Mohammad Shaheen Malik, he has written 35x plus 13y equals 1000. Correct.
2 notebooks. That's it. It's way too less. MP safe score. So like 50 is safe score anywhere. $10 and $50. Arav Sharma is saying 10 and 50. Right? So, see, like in first 5 seconds, you got the equation. Let's have X pen and Y notebooks. One pen is costing you rupees 13. So X pen you will get for 13x. 13x plus 35y equals 1000. Let's do certain observations here again. Can you see that observation number 1? 35y and 1000 is divisible by 5. It implies 13x is divisible by 5. This is very interesting. This is very, very interesting conclusion. See, this is divisible by 5. This is divisible by 5. So, this has to be divisible by 5. If you are not being able to see it, let's write it like this. Now, can you take 5 common here? You will get 200 minus 7y. So this is 13x. Now, since RHS is divisible by 5, your LHS has to be divisible by 5. And hence, you can write x equals 5p. When you put it here, you will get 13 times 5p equals 5 times 200 minus 7y. 5 and 5 gets cancelled. So, you have 13p plus 7y equals 200. This is very interesting now. I can see here, oh, 13 plus 7 equals 20. And this is 200. So, if somehow I am being able to add these two coefficients, then my life will be very simple. So, let me put p equals y here. So, you get 20p equals 200 and hence p equals 10. Now I get it. Okay, p equals 10. So, p equals y equals 10. Since x was 5p, I got x equals 50. Right? So, this is one solution. 13x plus 35y equals 1000. I got 50 pens, 10 notebooks, right? Then I have to add this here, subtract 35 here. This is another solution. This is another solution. The next solution is this, but this is obviously rejected because you cannot have minus 20 pens. And this is the practical use of indeterminate equations, right? Now, nowhere it was written that x and y have to be natural number. It is arising because of the problem design. You cannot have negative number of pens. You cannot have negative number of notebooks. automatically your x and y becomes natural number. So hence, this is the only solution. These are the only two solutions. Okay, but it was given that the commodities, number of commodities have to be maximum. So you have 60 commodities here, you have 38 commodities here. This is rejected, this is accepted. And what is asked then? What is the original ask in the question? The original ask is how many notebooks will I video in this video we are going to study miscellaneous equation. Till now we have talked about, if you have seen our videos, we have talked about the algebraic identities, we have talked briefly about polynomials, and we have talked about factorization. But it all culminates to basically solving equations. Solving equations and mathematics are practically synonymous, at least they are considered synonymous. So first of all, you must have heard of these two words, identities and equation, right? Identities and equations. So let us distinguish between them. Let us distinguish between them, right? Let us distinguish between them. Correct? First, if I give you this expression, what do you call it? What do you call it? Is it an identity or an equation? What is it? This particular expression, a plus b whole square equals a square plus 2ab plus b square. What is it? Is it an equation or identity? Please tell me. The learners are saying that this is identity. Now, why they are saying that this is an identity? Because it is true for all the values of a and b. You can randomly choose any value of a or any value of b. So let's choose a equals 2, b equals 5, right? So my left hand side is 49. Let's talk about right hand side. A square is 2 square. 2 times 5 plus 25. So this gives me 4 plus 20 plus 25, right? So the basic identifier for identity, is that identities are valid. Identities are valid for all values of a and b. They are not valid for some particular values of a and b. They are valid for all the values of a and b. That is how you distinguish between identity and equation. What is an equation? Equation is true for some values. Let me give you an example. Now let's take this case. A square plus b square equals a plus b whole square. Right? Let's talk about this. Now, this is an equation. This is equation. Some of the learners might think that this is wrong. This is actually wrong. I won't say this is wrong. If you are saying that this is an identity, this statement is wrong. This is not an identity. But does this mean that it is not an equation? No. Let's try to solve it. If you solve it, you get a square plus b square plus 2ab equals a square plus b square, right? If I expand this, I am getting this. Now let's cut these things and you have ab equals 0, which means either your a is 0 and b can be anything, or your b is 0 and your a can be anything. This is the only solution. So basically, in layman words, one of the a or b has to be 0. One of the a or b has to be 0. That is how it is going to be true. Getting my point? That is how it is going to be true. So guys, we have changed the schedule of IOQM English live course. Every Monday now the lectures will be taken. Every Monday. Every Monday the live lectures will be taken. Getting my point? Every Monday. Right? So a square plus b square is equal to a plus b whole square. This is equation. A square plus b square if you have solved it. So basically now you are seeing one thing here. Equation has to be solved, and this is the conclusion of the equation. For what values of a and b this equation holds true. So these two will be called solution of equation. Solution of equation. So this is the basic definition. Basic definition is that equation has some particular solutions and identity is true for all the solutions, for all the values. Getting my point? Am I making absolute sense? Am I making absolute sense? Please tell me, guys. Batao bhai. Is it okay now? Perfect. Perfect. Let me see your chats. The thing, just a second. Okay. Just a second. Yes. Correct? Okay, perfect. Let's go, let's go, let's go. So, you have understood the difference between equation and identity. Now, let's solve this question. Alright, let's solve this question. Find values of A and C so that given equation holds true for all values of x. All values of x. Right? This is what is given. Right? This is what is given for all values of x. For all values of x, this should be true. Right? A minus 2 times x equals c minus 3. This is your equation. This is your equation. Right? What I am trying to say, find values of a and c so that given equation holds true for all values of x. Right? Whatever be the value of x, this equation should satisfy it. Why you not started? Basically, Dolly, what we are trying to do in the recorded course, we are trying to complete basics of all the things. Geometry, then number theory, and then algebra. We are going to complete till 10th. And then quadratic equation, what we have in IOQM is of JEE level. So these chapters will be dealt later. Getting my point? I hope I am making sense, Dolly. Right? So, see, like if I see this now, let's try to focus on this. Let's try to focus on this now. The meaning of this particular sentence is that if I put x equals 1, it should hold true. If I put x equals 2, it should hold true. Right? So let's try to solve these questions. Let's try to solve let's try to solve this equation. If I just simply subtract it, 2 times a minus 2 minus 1 times a minus 2 equals 0. So this gives me a minus 2 equals 0 or a equals 2. Right? This gives me a equals 2. When I put a equals 2, I get c minus 3 equals 0 or c equals 3. Right? Right? So these are my two values, a equals 2, c equals 3. Right? In general, if I have a linear equals 0. Usually what have you studied? That sir, x equals minus b by a. It is only valid when a is not equal to 0. So this is an identity. This is an identity. What do you mean by an identity? Identity is one particular expression which is true. Identity. Which is true for all values of x. It has to be valid for all values of x. So if I just put a equals b equals 0, just see 0x plus 0 equals 0. It is true for all x, right? For all x. Am I making sense here? Please note this down. This is very, very important point. Very important point. What do I mean by an identity? This is a very important point. Right? This is a very important point. Getting my point? Done, guys? Am I making sense? Perfect. Perfect. This is good. Now, let's talk about basic equation. Guys, you need to understand that either we can solve polynomial equation. So, what is a typical polynomial equation look like? Eventually, it will be like this. Right? I'm just giving you an example. Now, if you are given this equation, find solution. What is the solution to this equation? And you need to understand, what does this say? This particular expression multiply by this particular expression, multiply by this particular expression, multiply by this particular expression equals 0. Now you are being asked, what is the solution to this equation? Right? What this means, what can be the possible values of x for which this entire expression is 0? Right? This is the ask. Now when I am talking about solution, it is assumed, please write it down, it is assumed that only real x is taken. This is assumed when we are talking about solution. Let me give you a very simple example of it. Right? See, one of your friend comes to you and is asking for a solution to his personal problem. Right? So you will give him a real solution, right? If he is your friend, you will not give him an imaginary solution. There is nothing called imaginary solution. Right? Am I making sense? So in real life also, we are expected to give real solutions to the problems which are posed to us. If your friend is asking you a question, you give them real solutions, not imaginary solution, right? So here also, you will assume that this expression cannot be 0 for any real x, right? Why, sir? Because this is perfect square. You are adding 1 to it. How can you add 1 to a perfect square and get 0? It is simply not possible for any real x. So, your solution is that either x minus 2 equals 0, x minus 3 equals 0, or x minus 4 equals 0. Right? Which eventually gives you the solution 2, 3, 4. Which eventually gives you the solution x equals 2, 3 and 4. Right? 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 Am I making sense, guys? Am I making sense? Am I making sense, guys? Yes, perfect. Now, just see the progression of this lecture. X minus 2, x minus 3, x minus 4. What is x? What is x? And I'm not talking about your x. I'm talking about the variable x. X is a variable. X can be anything. So let's assume that I put this equation. I'm solving this equation. Let's talk about this now. Right? Let's talk about this. Equals 0. And I'm saying that x is 2 to the power t. Find t. Find t. Right? This is the question. This is the question. Sir, I try hard to solve your book. Not able to solve. So how will you be able to solve it? It is not a self-explanatory book. It is an IOQM book. You have to study for IOQM and then you will be able to solve it. It is not something of foundation level or basic level or your school level. You need proper training first to do that book. And all the lectures are free of cost also available. And if you want to join any live course, you can do it. Now, Sid is saying 1, 2, 3. Shubh Kedia is saying 1, 2, 3. Girish Jain is saying 1, 2, 3. Now, if I would have given you like this, right? This is a polynomial equation, but this is not a polynomial equation. Do you know the name of this equation? Do you know the name of this equation? Do you know the name of this equation? Like sometimes it is called exponential equation, but largely these things are called transcendental equations. Transcendental equations, right? Which are basically non-polynomial, but eventually you are solving it using the methods of polynomial. You are solving them using the methods of polynomial. Am I making absolute sense here? Right? What you are doing actually, this was not the question. This is the usual question. You have put 2 to the power t as x, and then you get this polynomial equation for which you know the solution. We have done this multiple times in this playlist. X equals 2, 4 and 8. And then you put the value of x again. These are the 3 solutions. And the way to solve exponential equation. So if you have 2 to the power x equals 2 to the power a, this simply implies x equals a. Please note it down if you did not know this. If you did not know this, please note it down if you did not know this. Right? So this is 2 to the power 1, 4 equals 2 to the power 2, 8 equals 2 to the power 3. If I simply, these are called bases, right? In exponents and radicals, you must have read these terminologies, right? This is base, this is exponent, right? So this base is same now. So I can say t equals 1 from here, t equals 2 from here, t equals 3 from here. So this is my eventual solution. This is my eventual solution. Am I making absolute sense, guys? Am I making absolute sense? Am I making absolute sense? Am I making absolute sense here? Please note it down and just write UDAN so that I can move on to the next question. Eventually, we are going to study miscellaneous equation, because miscellaneous equations are not some random equations. They are essentially equations reducible to polynomial equation using suitable substitution. We will use suitable substitution and solve the equation using polynomial methods. What are polynomial methods? Factorization. Right? 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 Essentially, we are going to do this. Chalo, let's move on to the next one. Majority of the learners are saying this thing that they have understood it. Right? Let's do this one. This is PJ exclusive. What do I mean by PJ exclusive? This is the question which is designed by me. Solve for x. Right? You need to solve this equation for x. 27 to the power x minus 13 into 9 to the power x plus 13 into 3 to the power x plus 1 minus 27 equals 0. Right? Solve this equation. Now this is equation which like I have taken the motivation from a book called Prelepko. Prelepko is a very good book to start with to solve equations, different type of equations. This is exponential equation, but I am going to solve it using polynomial methods. Right? Let's see if you can do it. We need to use possible substitution here. One zero two. Now let's solve it. Sir, I can see 3 to the power x, 9 to the power x, 27 to the power x. So this is my silver lining. I am a sincere student. I have studied from the basic. I have good observation skills. Good observation skills are essential to problem solving. I can see here, this is 27 to the power x, which is actually 3 to the power x to the power 3. I can see 9 to the power x here, which is 3 to the power x to the power 2. Right? I can see 3 to the power x here also. But there is 1 here also, which is bothering me. So what I'm going to do, I'm going to write 27 to the power x here simply, 13 times 9 to the power x plus I am going to shift this one here. How do I shift it? 3 to the power x plus 1 is nothing but 3 to the power x into 3 to the power 1. So I am going to multiply 13 with 3, and that is how I get 3 to the power x. Right? Now let me put 3 to the power x as t. If I do this, this becomes t cube minus 13 t square plus 39t minus 27. Now if you remember my earlier lectures, I have given you a method to solve this type of cubic equation through hit and trial. I am simply going to put 1, and if I see 1 minus 13 minus 12 plus 39 is 27, 27 minus 27 is 0, which means 1 is a root. And then I told you a ninja technique. T square will definitely come. This is minus 13. Coefficient of t square is minus 13. You have already got minus 1 here. So minus 12t. And then simply plus 27. To manage your constant, minus 27. How do you get minus 27? When you multiply minus 1 with plus 27. Now, this can be done using simple splitting the middle term. I am writing it directly because we have invested sufficient amount of time in solving these type of equations. So what do I get? T is 1, 3 and 9. But what was my t? My t was 2 to the power s, 3 to the power x. 3 to the power 0 is 1, 3 to the power 1 is 3, 3 to the power 2 is this. So x is nothing but 0, 1 or 2. Am I making absolute sense here? Am I making absolute sense here? This is your problem. You are giving me answer 1, 3 and 9. 1, 3 and 9 are not the answer. You are asked x. You are giving me t. T is 1, 3, 9. Please note it down properly. This is miscellaneous equation. This is how you solve miscellaneous equation. This is nothing but miscellaneous equation. What are miscellaneous equation? Which you do not see in your routine problems. These are problems which are designed in such a manner that after a possible substitution like this, you will eventually get a polynomial equation. Getting my point? Please note it down. Please note it down, guys. Guys, please note it down. It totally depends on you how you want to proceed, right? See, the learner is saying that, sir, I could have easily done like this, t cube minus 27, right, this and this, and then minus 13, t minus 13t, t minus 3. So here I would have got 3t minus 3 here, t square plus 3t plus 9, and then here minus 13t, t minus 3. Then I could have taken my t minus 3 common, t square minus 13t and plus 3t is minus 10t plus 9. And then you could have factorized it like this. See, like solving equation, there is no unique method to solve a particular equation. There are n number of ways to solve a polynomial equation. You could have applied anything, right? Said this is what you wanted to say. This is something similar you wanted to say. Okay. Perfect. Now this is exponential equation. This is exponential equation. But let me give you another twist in it. Let me give you another twist in it. Right? Shall we? Let's give it. 9 to the power x. Solve for x. Minus 6 to the power x upon 2 times 6 to the power x minus 4 to the power x equals. Right? Let's solve it. I'm just making the question so that it all makes sense. Just a second. Let's solve for x. Solve for x. How do you solve it? How do you solve such an expression? See, in my classes you will find we'll always start with basic and eventually we'll go to a level which is actually IOQM 2 marker to start with. This is IOQM 2 marker. Like the new level of IOQM, right? IOQM used to be a very difficult examination, but this year, like, I don't know what has happened to MTI, but I think it is going to be of this level only. Right? Let's try to solve it. 9 to the power x minus 6 to the power x upon 2 into 6 to the power x minus 4 to the power x equals 45 by 56. This is a very, very difficult problem. In my opinion, this is a very, very difficult problem. In fact, Based on the principle which we are going to study here, we are going to solve a RMO level problem. Just imagine the complexity we are going to deal in this particular lecture. Just a second, it should not be like this. I don't think your answer is correct. I don't think your answer is correct. But what you are saying is absolutely correct. What you are saying is absolutely correct. Sir, I can see here that 9 to the power x, let's solve it in a different ink. What is 9 to the power x? 9 to the power x is nothing but 3 to the power x whole square. What is 4 to the power x is nothing but 2 to the power x whole square. And what is 6 to the power x? These are the only exponents involved here, right? So let's assume it to be a square. Let's assume it to be b square. Then this becomes ab. Right? Let's solve it. Let's solve it. This becomes a square minus ab upon 2ab minus b square equals 45 by 56. Are we making absolute sense here? Please tell me. Please tell me. Now this is something called homogeneous expression. A square minus ab is homogeneous expression of degree 2. What is homogeneous expression? See, just see this expression. This is quadratic expression. Now this is linear into linear. This is also quadratic. So that is why I call it, in fact everybody call it, homogeneous expression of degree 2. Because every single term of this expression is of degree 2. Similarly, denominator is also of the same level. So in such questions, you can simply divide by b square, right, in numerator as well as denominator. Right? So if you do that, you get a by b whole square minus a by b upon 2a by b minus 1. Now this is looking very, very complicated unless you put a by b equals t, your favorite t. So I am getting t square minus t upon 2t minus 1 equals 45 by 56. Now just simply cross multiply. Because you know how to solve a quadratic equation, isn't it, guys? Right? So I am getting 56t square minus 146t plus 45 equals 0. Now this is very, very complicated. It is a very, very complicated equation to solve, in my opinion. In my opinion, this is very, very difficult calculation to solve. But we will manage. We will try to manage somehow. Right? This is 146. This is 56. Right? This is 45. So 7 times 8 times 5 times 9. So I give 4 to this, right, 36. So I have remaining 2 here. 2 times 5, 10, 10, 70. This does not give me anything, right? 56 times 45. Yeah, this is the only thing which I have here, right? I have put in. So, but I can do something here. I think 56t square. So is it 4t minus 9, 14t minus 5. Is this correct? Is this correct? I think this factorization is very, very correct. This factorization is correct. Can you check the factorization? Can you check the factorization? Can you check the factorization? Is this factorization correct? That is why now you all must have understood this thing, why this is a 2 marker. Even after getting the answer, even after getting the quadratic equation, solving this quadratic equation is an effort in itself. It is an effort in itself. Right? Yes, this series is enough for IOQM 25. right? 4t minus 9 times 14t minus 5. Tell me, guys. Yes, sir, this was very difficult. Now, if my 4t minus 9 equals 0, I get t equals 9 by 4. What was my t? A by b. That is 3 by 2 to the power x. This gives me x equals 2. This is one solution. If my 14t minus 5 equals 0, my t is 5 by 14, which is 3 by 2 to the power x. Right? There is a way to solve it. We will deal it in logarithms. We will deal it in logarithms. Right? Please, this is a super question, super problem, which includes such a difficult factorization also. It is a very, very difficult factorization in my opinion. It's a very difficult factorization in my opinion. Right? Right? This is the question. This is miscellaneous equation. Right? But we have got a very interesting type of problem here. We have got a very interesting type of problem here. Sir, can we solve homogeneous polynomial equation? Homogeneous equation of some degree in multiple variable. This is a very simple problem. Right? Right? This is I would say this is a curiosity which may be arising in your head, that can I solve all such type of problems? Is there a method to do these type of problems? Yes, there is a method. We are going to deal it in the next page. Please note it down, guys. Please note it down. Please note it down, guys. Done? Done? And if there is a way, you can clip this one, you can clip this problem. This is a very interesting problem and this was super. Right? And don't ask me in the comment section how do you did it. We have already dealt these type of quadratic equation. We have studied short ways to do it also. So my question is, can I solve all homogeneous equations? Right? Very simple problem. If I have this type of equation, let's assume I am going to study this. Right? To start with, because the algorithm is going to be the same. Right? This is the type of problem. My answer to you is yes. My answer to you is yes. We can always solve these type of problems, provided we know how to convert them in polynomial. So step 1 is conversion in polynomial. What is step 1? Conversion in polynomial. How do you convert them? Please make sure that 0 is here. 0 should always be here. It is a must thing. Must condition. Conversion in polynomial. How do you convert it into a polynomial? Let's see. You divide the whole equation by y cube. Why y cube? Why can it not be x cube? It is just matter of preference. I prefer y, right? So if you divide it by y cube, you get a times x by y whole cube, b times x by y whole square. You can check it. Please see to it. x by y and b. But now you would say, sir, how can you divide by a number which can be 0? Which can be 0? Yes, you are correct in this observation. I cannot divide any expression with a variable which has possibility of becoming a 0. So we will deal with the case of 0 separately. If you see x equals y equals 0 is an obvious solution. Right? Now there is a term to it. Right? Obvious is too obvious, right? It is very simple English. So we have coined a new term for it. This will be called trivial solution. What do we call it? Trivial solution. Trivial means obvious. It is an obvious solution. X equals y equals 0 is a trivial solution, means obvious solution. Right? And then now that y cannot be equal to 0 because we have dealt the case of x equals y equals 0 separately, this equation will make sense. And now what will I do? X by y equals t. And now this has become a simple cubic equation which I can solve. Isn't it, guys? Isn't it? I can solve it, guys. I can solve it. Right? I can solve it. Hello, sir. Got 23 in IOQM 2024. Aiming for 50 to 60 plus in 2025. Any tips? The tips is complete the full course. Without structured preparation, it is not possible. For example, if I take the case of Debayu, like Debayu took 4 years to get 77. But he was in constant touch. He was in constant mentorship. He has done complete IOQM course first. And then RMO, then INMO, obviously. Right? Right, guys? Am I making sense? Perfect. Right? Let's do one problem of it. Right? Let's do a simple problem. Solve for relation between x and y. Solve for relation between x and y. Right? X cube minus 9x square y plus 26xy square minus 24y cube. Right? x equals 2y. Now this is one solution. So sir, what is the algorithm that you have told us? You have asked us to divide the equation by y cube. You have asked us to divide the equation by y cube, which we will do, and we will eventually put x by y equals t. Right? Now I am taking the liberty to write it down directly after substitution. So I am going to get t cube here, minus 9t square here, plus 26t here, minus 24. Now, are you getting this point? That eventually, after every type of substitution that I am going to study, eventually I am going to get a polynomial equation. And that is why study of polynomial is of utmost importance in IOQM preparation, for that matter, JEE preparation also. So let's factorize it. This is t minus 2, t minus 3. Polynomial factorization, you should be very, very fast in. Just by looking at the coefficient, you should be able to factorize. You should be able to factorize. Right? So this is, what do I get here? T equals 2, 3 or 4. Right? These are my three solutions. But these are the solution for t. Actually, x by y equals t. So means x is either equals 2y, x is either equals 3y, x is either equals 4y. Right? Please note it down, guys. Please note it down. Please note it down, guys. Right? Perfect. But sir, these are simply relations between x and y. We did not get any particular solution of x and y, right? Obviously, we did not get any particular solution of x and y. So let's try to find a way to do it. What if I am given extra equation? What if I am given this equation? Right? Solve these. What do I call them? Simultaneous equation. Simultaneous. Simultaneous means which are happening together. Simultaneous. This is the word for it. Solve these simultaneous equations. Right? X plus y equals, just a second, 60 and x cube minus 9x square y plus 26 xy square minus 24 y cube. What do I mean by simultaneous equation? These two equations are holding true together. So whatever the solution of x and y is, you can put it here. Right? Perfect, Sid. Lakshmi Jain. Lakshmi beta, you can follow my lecture of roadmap to IOQM 2025. I have already given roadmap to IOQM 2025. I have already given roadmap to IOQM 2025. Done. Yes, yes, the roadmap is given there. Very good. Sir, I got your point. First of all, I will solve this. After solving this, I have these three as my solutions. Right? These three are my solutions. Now, let's put them. Now, if I put x equals 2y here, I will get 3y equals 60. And hence, my y equals 20. And since my x is twice of y, my x is 40. Right? Y equals, I think I'll get 15 here. X equals 45 here. X equals 12 here. Y, oh, sorry. Y equals 12 here. And x equals 48 here. Right? 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 Am I making sense, guys? Am I making sense? Am I making absolute sense here, guys? Please. So, you need an additional equation to come up to a final solutions. These are the final solutions. So, should we do one more problem of this? Should we do one more problem of this? Should we do one more problem like this? Should we do one more problem like this? And the most important thing is, will you be able to solve it? This is the most important problem, right? Will you be able to solve it? Right? Perfect. Let's solve one more problem. I am going to give you a simple problem, but this has been asked earlier in one of the years in RMO, but it was very early, 1986 types, right? Solve for x and y, right? You have to solve for x and y, and I'm giving you the equations. X square plus 5xy plus 2y square equals 8, x square minus 7xy plus 19y square equals 30. Solve these two equations. Solve these equations. X square plus 5xy plus 2y square equals 8. X square minus 7xy plus 19y. Now these are not homogeneous equations. You do not have 0 here. Please note this down. You do not have 0 here. So you'll have to apply your mind to do it. You have to apply your mind to do it. You have to apply your mind. Please give me the final answer. Perfecto, perfecto, perfecto. X square plus 5xy plus 2y square equals 8. X square minus 7xy plus 19y square. See, basically you need 0, right, in the right hand side. How do you do it? How do you get? How do you convert? But see, at the end of the day, as a mathematician, you should think very positively about it. Why you should think very positively about it? Because there are only two variables and two equations. You should have the mental muscle power to solve such an equations. You should always feel very, very positive about it, right? So let's solve that. Can I say that x square plus 5xy plus 2y square upon 8 equals 1 equals x square minus 7xy plus 19y square upon 13? I can definitely say this. And now just remove this one, right? These are simultaneous equations. These are simultaneously true. This is equal to this. This is equal to this. This means this is equal to this, right? There's a term in mathematics to it. This is called transitivity. A equals B, B equals C implies A equals C. Transitivity. This is how transitivity works, right? This is how transitivity works, right? Now, I'll multiply 13 here. So I get 13x square plus 65xy plus 26y square. I'll multiply 8 here. 8x square minus 56xy plus, what is 19 times 8? Oh no, 152y square. So I get 5x square plus 111xy minus 116. Oh no, 121xy, 126y square. So this is x minus y times 5x plus 126 equals 0. So my one solution is that I have to put x equals y. My another solution is that I have to put 5x equals to minus 126y. This is brilliant. This is brilliant actually, right? This is actually very, very brilliant. But I don't think this is a very easy calculation, but this is an easy calculation. If I put x equals y here, what am I getting? What am I getting? 8y squares equal 8. Right? This is what am I get? This is what I am getting. So my y equals plus minus 1, which essentially means my x is also plus minus 1. So 1 comma 1 and minus 1 comma minus 1 are two of my solutions. These are two of my solutions. Now, can you check for this also? Can you check for this also? Why am I speaking in English? Guys, this is IOQM English course. I don't think you people listen to my announcements. I announced it that this year I am going to teach live for English. SPS sir also took one of the lecture in English. You need to understand that we are investing for those learners who have been constantly asking for the English lectures in IOQM. But the English lectures have not been available till now. We are the first platform to introduce pure English lectures of IOQM. Right? Right? Now, let's try to solve this one. Let's try to solve this one. Now, this requires patience and some good level of manipulation. I have x square plus 5xy plus 2y square equals 8 and 5x plus 126y equals 0, right? This is what I have, right? Now, I'll multiply it with 25 so that I get 25x square here, 125xy here plus 50y square here equals 200, right? I have multiplied with 25. Now my 5x is minus 126y. I am going to put it here. So this becomes 126y whole square plus 125, not 125, 25y times 5x, which is essentially equal to minus 26y plus 50y square equals 200. Now what I am going to do, I am going to take 126y common here. 126y common here. So I get 126y here minus 25y here plus 50y square equals 200. So this gives me 126y times 101y plus 50y square equals 100. This gives me 63, this gives me 25, this gives me 200, this gives me 100. Okay, now 63 times 101 is 63y square plus 25y square equals 100. So I have y square equals 100 upon 6368. Right? Right? 6368. So this is 1y, right? Plus minus obviously. So let's assume that this is equals to something. So just put it here to get 2 more solutions. So eventually we will have 4 solutions. We will have 4 solutions. Getting my point? We will have 4 solutions. Right? Right? 6388. Yes, my mistake. 6388. 6388. Only if I had 12 here, this would have become 6400. 100 would have gotten cancelled and y would have become 1 by 8. But such is life. You do not get everything. Thank you for appreciating my jacket. I wore it so that somebody can appreciate it. You are the first one to appreciate it. I have been wearing it for last 30 minutes, but you are the first one. I like it. Thank you. Right? So this gives me 4 solutions. Now where do you find such type of problems? In my Pathfinder book, you get miscellaneous equations as last section of Basics of Algebra. Right? This is the last section. You can find AIME problems in my book, latest edition, and IOQM PYQs as well. There was one particular problem in pre-RMO 2017 which can be solved using directly these methods. Right?